So, hello everybody, and welcome to Getting Started in Computer Security. My name is John Strand, and I'm really happy that you're here. As we were talking about, this is going to be a little bit of a co-teach today. I will be taking the first part of the class, and then one of my good friends, who is also a former SANS instructor, Doc, will be taking over for the last couple of hours. And the reason for this is I got double booked. I knew I was teaching down here, and I was going to be doing instruction, and that's great, but we also booked a family dinner cruise tonight. So that's on me. That's my fault. But Doc is awesome. He's one of the finest instructors I've ever worked with, and we are absolutely honored to have him part of this team at Anti-Siphon. So a lot of people were asking about virtual machines and where the class labs are going to be. And we have instructions and resources. Everything we do connects to Discord. If you're watching this on YouTube, you can still join. If you want to, you can just still go register for this class. And in there, we have a link that'll get you to our Discord server. And in the Discord server, we have instructions on accessing the cloud labs for this class. And we will be using MetaCTF. Now, MetaCTF is the platform that we use for cyber range challenges like CTFs, which hence is in the name. And it's also what we use for our cloud lab environment. All of our labs for this course are built into the browser, and we're using it. We're actually hosting it up in Amazon. And nothing bad ever happens with Amazon, right? So we're going to be hosting it there. You'll be able to gain access to absolutely all of the labs. And when you register, you're given a code. If you actually go to the link in the instruction documents, there is a code. And I know at the top of the doc, it says cyber deception. That's fine. I use the same labs for deception as I use for this class. So you get like 3 classes for the price of 1. And actually, that's not even true. I have some more cool labs coming up for you all. We give a ton of crap away, and we're super excited about it. And I'm probably going to share with you all some additional cool things. Like, who here wants to learn satellite hacking? Anyone? Like, do we got any hands or anybody on Discord? Anybody interested in learning some satellite hacking stuff? Yeah, got some people that are interested in that. I can show you our satellite hacking labs that we are building, which is also going to be in the cloud. Like, you don't have to build your own satellite hacking rig to do it. And I'll show you the type of stuff that we teach in that class that's going to be coming up on demand predominantly starting in January. We're getting the labs pretty well polished at this particular point. And then I'm going to move into creating the slides. I always start with Jesse's like, yes, a new class. We also have some new network threat hunting labs, and I'm going to be giving you codes. And let me show you how those codes work. All right. So you go into MetaCTF, you register, you log in, and then you select Cloud Labs, and it says access code. If you've been given an access code, enter it here. And then you would paste in that access code, and then it unlocks the lab for you. So right now we have 3 separate labs here. We have active defense and cyber deception. We have the Rita version 5 lab. What's that? What might we do with that? You might ask. Good question. And I'll be sharing that with you here a little bit, but hint, it's a Rita lab, which I think is cool. And then the other one is SOC core skills, which we are not doing. And eventually this one's going to go away and everything's going to be rolled up into, I got to come up with a name for it, but like core lab infrastructure, and everything will roll together at that particular point. But I'm also going to be giving you guys a code for the satellite hacking class. And I think our wireless stuff is getting tweaked right now, but I can show you what that looks like as well. It's in essence, what we're working on that I'm super excited about is 2 separate things. Zach and I are working on a certification, which seriously, Zach, I don't know if you're still here, but dude, we're so close with this. I don't know about you, man, but we're so close to the certification, getting that out, the ATT core cert. It's been busy, man, right?
Yeah, it's been fun. It's been busy and fun, but I'm excited.
Your house flooding with sewer
Yeah,
water.
no, I
So,
don't. We're gonna talk about that because it's still a pain for me. But yeah, no, it's
yeah.
exciting, man. I'm excited. I think it's gonna be a nice change for the industry. I really
And
do.
that's going to be coming up in January. But you know what's awesome is you can do the ATT core cyber cert today if you want. I don't recommend doing it today. Go through this class first. And we will walk through how to do that. Zach has a document that gets you early preview access to the ATT core cert. Now,
Oh,
the final thing about this. And Zach, I don't know if I've told you yet, but you know, our interns in Romania and Poland have been doing awesome things.
Oh yeah.
They've been creating like absolute like they're like these little worker ants. They've been creating tons of additional labs for all kinds of different tools and all kinds of different aspects. They're just out there. Every tool they're creating a lab for it. And we're going to be releasing in next year the Open Lab project, where you will be able to do just tons of labs, not just for this class, but a ton of other topics as well. So we have so much cool stuff coming down, but it all starts here. It all starts in MetaCTF. And Zach, I kind of brought you in to remind you, it's like, we got to get that document. I don't know if we got the document in resources.
I'm getting it right now.
We're doing it right now.
Yeah, come on.
All right, dude. Thanks. But we have a lot of cool stuff. And then once you put in the codes, you're able to access your virtual machine environment. Now, when you start, you get 16 hours of access to the lab environment for free. Okay, 16 hours is actually enough to get us through this course. If you burn through those hours, you go to billing and credits. And I guess I can do this now. Where's my, I don't know what I did with my cell phone. But it's around here somewhere. There it is. I'm going to need that. All righty. Let's say I burn through all my credits and I want to buy more. I just click on this. And then I go into Stripe and I've got a confirmation code that is sent to my phone. Maybe it's coming up here in just a second. All right. But then you can buy additional credits right here, and it's not coming through, which probably because I'm down in Costa Rica. But you can purchase more credits if you run out. So that's easy peasy lemon squeezy to do. All right. Now, once you have entered the code, you're ready to go. You have this set up. You select View Manage Lab. And then there's this button right here that says Start Lab. That's the button you want to start. Oh, I just got the verification code. I'll come back and buy more later because I have 13 to get started. So then I click on Start Lab. And now it's going to kick off the process to start a Kali system and a Windows Server 2022 computer system that we use for all of our labs in this course. All right, so it starts both of those up. Now here in a second, it's going to say it has like another 120 seconds, and it's going to start doing a countdown timer. And it will take about 2 minutes for it to get completely set up, maybe a little bit more. And then you have a full lab environment ready to rock and roll. No VMs to download, don't have to get your hands dirty. Life is really, really good at this point. So that's how we get started with the lab environment. Now, what labs do you gain access to? Well, let me show you. So if I go to Strand.js labs, this is our GitHub repository. Oops, I've gone too far. There we go. Go to navigation. Let me share this in the Discord server. I'm going to put this in resources for everybody. And I'm also going to put it in the main chat. There we go. These are the labs. I mean, this is already extensive, but just so you know, I think we've about doubled the total number of labs that we have, chat. I think we've about doubled them out. So we have Intro to SOC, that's Linux command line memory analysis, TCP dump, weblog review, Windows CLI, Wireshark, Nessus, Deep Blue CLI, Hayabusa. Intro to security, we have AppLocker, Atomic Red Team, Deep Blue CLI, Nessus, host firewalls, and Nmap. Password cracking, password spraying, external password spraying is a new lab that we're going to be doing in this class. Responder, Rita and AC Hunter, Sysmon, web testing, Azure, Pingcastle Wireless. Wireless is pretty flippin' cool because if you go into the wireless, it talks about how to get set up into the wireless environment at home. And I'll talk about that later when we get there. But you also get access to all of these labs as well. We got Spider Trap, we have Cowrie, Canary Tokens, Rita, Blue Spawn, Beelzebub. We have all of these cyber deception labs that are set up that are ready to go. And as Brian pointed out, one of the things that's really cool about the way that we're doing our classes is we have new labs that we're generating like all of the time. So with that in mind, we a lot of people take these classes again and again and again, right? So I want to show you the satellite security labs that we're working on right here. And you don't have access to these yet, but I want to show you like this is coming up in January, right? So what have we done? So a lot of satellite hacking is software-defined radio and a number of different attack scenarios. So here's the labs that we have built so far. We have Interceptor, which is intercepting traffic, denial of service, takeover, doing relay, drift, where you can create drift in kind of like DOSing in a slightly different way, and then Blue Team labs on how to detect those things. So all of the labs that we have, once again, have step-by-step instructions on how to set them up, get software-defined radio, adding in all the modules for sort of software-defined radio hacking and all these things. And it really helps you get started with this stuff in a way that, once again, is completely virtualized, and it's just a cool environment for you to learn. But that's all the stuff that's coming up. And you're now built into this ecosystem, right? You are part, because you're part of the ecosystem of the BHIS tribe of businesses and anti-siphon security training. Welcome. We try to be like one of the most like open and sharing groups on the internet for these things as well. Also, for the record, Zach in the Discord server has just dropped the link with the instructions on how to do the ATT core certification. And I'll show you what that looks like. Oh my God, is Black Friday still going, Brian? The Black Friday sale?
It is.
Okay.
Well, the material says through to December 31st.
Yep.
Oh, well, then I guess it's through to December 31st. That's crazy.
Yes.
So
But wait, there's more.
But wait, there's more.
Yeah, not only do you get the full subscription, you get a
on-demand course catalog. These are all of the 2-day classes that we have. Active defense, cyber deception, active directory hardening, advanced endpoint investigations, pen testing non-Western infrastructures. If you want to learn how to hack Russia and China, you can learn how to do that because it's completely different. AI for cybersecurity professionals, assumed compromise methodology, bash scripting. I think we have like 47 classes, and you get access to every single class that we have on demand, every single class, for $1,500 for the entire year. It's the entire course catalog, everything we have, for $1,500. And if you're trying to figure out what the percentage off of that is, it's something like 95% off, maybe even a little bit more than that. But this is our Black Friday sale. So if you're trying to jumpstart your career and you want to just sink into computer security, I don't think that you would find a better bundle than this. And I know that there's a lot of things out there like Udemy and Coursera, and those things are fine and they're cheaper. Absolutely. But if you're looking at these classes in anti-siphon, this is like SANS equivalent quality, since we're outside of the statute of limitations, for like a fraction of the cost, right? Alyssa Torres is a SANS instructor. I was a senior instructor as well. Joff was a SANS instructor. We have a ton of SANS instructors that are here that have joined anti-siphon as well. So that's what we got for you. There's a lot, and we'll keep doing these things. Also, you get a Wild West Hack and Fest virtual ticket with it as well. So just super cool access to all of the things, because we're trying desperately to do computer security training a little bit different, where the goal of computer security training for a lot of companies is to maximize profits as much as you can, right? Our goal is to try to get as many people prepared in cybersecurity and get them ramped up with the skills they need as we possibly can. From an altruistic, we want you guys to kind of rock out and just really do a great job in computer security, because I think all of our problems that we have in computer security are predominantly skills-based issues, right? Having the right appropriate training to be able to do these things. And that's why we're doing it. Also, if you really, really, really want to understand from the marketing perspective, this also helps us drive sales to BHIS. In anti-siphon training, we do make money on it as well. Now, we don't make like ridiculous 97% profit margins, but we're not VC funded, none of that crap. We're just trying to help people. And that's why we're here. Actually, that's why this whole team is here as well. All right, so let's go ahead and let's get started with the class. In addition to doing all of this from an anti-siphon security training, there are partners that we have that are a huge help for us. One of them is the MSP group, just amazing group of individuals. I don't know if we have anybody here from the MSP community, but a cyber call with Andrew Morgan is amazing. Right of Boom is a great conference that I go to every year. I would like him to get it out of Las Vegas, but that's okay. I try not to go to Vegas. He gets me there because I love him like a brother, but not a fan of Vegas at all. But it's a great conference. You should check it out. It is so incredibly cool. Check out the Cyber Call, register for that podcast. Andrew Morgan does a great job with that. Also, the cloud VMs and everything that we're doing here is provided by this really wonderful person that I met a number of years ago. His name is Arnie Bellini. And Arnie Bellini was the founder of ConnectWise. He was the guy that built that company from the ground up. And it was kind of weird. I met Arnie and we were just at a conference. We were sitting at a table. We were talking to each other and we bonded over like mountain biking. He does triathlons. He's one of the fastest triathlon runners, sprinters, swimmers in his age group. Like the dude has swam the English Channel twice. Now, he says he's only swam it successfully once. I think that's absolute like garbage. Arnie was swimming across the English Channel with another gentleman, and they weren't like friends. They were just doing it at the same time. And the other guy like literally passed away in the water. And Arnie was with him and helped him, you know, like get out of the water and stuff. So he didn't finish, but I guess he was within visual distance of the shore, but you know, he stayed there and helped this dude. And that's just like a hell of a good story. And I remember I was talking about my training and he's like, well, what's the biggest problem that you have? And I'm like, VMs. Downloading VMs, doing VMs in the cloud would be, you know, really cool if we could do that. And I'm trying to figure out how to do that. And like the next day he showed up and he's like, here's a business card, here's an email address. These guys are going to hook you up. And he is really dedicated to the idea of computer security in the industry and trying to train as many people as you possibly can. And he's right with that mission of what we're doing with Anti-Siphon. And he has a great conference called Cyber Bay in Tampa, Florida. You got to check it out. They had like this drone show and that was flipping ridiculously cool. So you got to check that out. So if you get a chance, go on Facebook and tell Arnie Bellini, thank you for what he's providing to us to allow this to continue to move forward. All right, so what is this class? So this class is kind of meant to be a sort of bootstrap security class. This assumes that you have some basic fundamental skills in the area of computer security, like operating systems and networking. And if you don't, that's fine. Those classes are available on YouTube. You can watch them and the labs will all work for you as well. But it's meant to really get you started in computer security with all killer, no filler. Right? What are the core things that would be effective in actually stopping an attacker from trying to break into your environment? Now, you have a lot of classes that are intro to security level classes, and we've been talking about renaming this class as well over the past couple of years, because we kind of tied it to MITRE because everything needed to be tied to MITRE, I guess, by law in computer security. Not 100% certain, but we kind of set this up to get away from what a lot of traditional security classes are doing. Like, I'll give you an example. I'm not going to pick on any specific class, but there's a lot of classes that are like, well, we're going to teach you the Bell-LaPadula model or the BIVA model, or we're going to teach you how crypto works. We're going to spend half a day or a day on what is a stream cipher? What is a block cipher? How do these things work? What are the models? What are the different modes of running RSA? What is the difference between electronic codebook mode and chaining block mode and all these different modes? I've been doing computer security for a long time. Like I'm now over yeah, it sounds very suspicious. I've been doing this for a quarter century, right? And in that time, there's a whole bunch of things that I've learned in computer security explicitly and only from the perspective of teaching computer security classes over the last 25 years. I've never implemented any of those things at all, ever. And I wanted to create a class that was 2 days that straight up what it is you need to know to defend a network in your organization. We are going to be covering what works. Also in the Discord, I saw somebody posted Arnie's LinkedIn. Please go, friend him and connect with him in LinkedIn. I guess we don't have friends on LinkedIn, and tell him thank you for everything that he does for the computer security community, because it is substantial. And like I would say the primary goal of his life right now is to try to level up security training. So go tell him thanks. All right, so these are the things we're going to be covering, y'all. We're going to be covering application allow listing. Now, there's a new version of this. The concept is still the same. It has more flexibility. Password controls, egress traffic analysis, UEBA, which I guess is now artificial intelligence, advanced endpoint protection, logging, host firewalls, internet allow listing, vulnerability management, Active Directory hardening, and then, of course, backup and recovery is there. We call these the atomic controls. These are the things that you need to do in your organization if you want to be properly protected against attackers coming into your organization. There's a ton of different compliance frameworks that are out there, right? And a lot of them are like hundreds and hundreds and hundreds of pages of all kinds of garbage that doesn't actually directly relate to securing your environment and securing your systems. So we take, like, I'll explain how we got to this point, but we take these 10 things, and these 10 things are the core 10 things that you do and you do properly, and you will stop attackers coming into your environment. Absolutely guarantee it, right? Now, how do we actually come across these 10 things? Let me go through, well, we'll get to that here in a second. So these are the 10 things that we cover, right? And then we also have a class from Brian Strand, which, by the way, is available in the Black Friday bundle, Blue Team Foundations with Atomic Controls and Brian Strand. That's auditing side of this. But we're not going to be covering intro to Windows, intro to Linux, intro to TCP, intro to crypto, intro to security models, the common body of knowledge, NIST 800 series, or DLP, or the exploit du jour that we see. We're not going to be covering these things for a couple of reasons. One, we spawned off the Intro to SOC Core Skills class, which has Intro to Windows, Linux, TCP IP, and not crypto. But we have those core things. So, all right, we did that because we created this course and we realized that there was a whole group of people that really needed those basic fundamental skills. Now, all of the labs are very much copy and paste, going through them step by step by step. And that's great. But if you don't understand these core models, you can go back on YouTube and you can watch the Intro to SOC Core Skills class to get you started with these, okay? And that's also on the on-demand bundle as well. So we're kind of jumping in, assuming that you got some basic understanding of Windows, basic understanding of Linux, and some basic understanding of TCP/IP. And that being said, there's going to be a whole bunch of stuff that we'll do. And like I said, it's very much copy and paste with good descriptions of what's going on as well. Now, I had mentioned that this class is fundamentally based on what works. Now, I've had people in the industry that like saying things like, well, what makes you an expert on this? And there's a bunch of experts, and I totally get it. I understand it, right? Like, you know, when you go to a conference and you've been doing this stuff for a long time, and you have people that come out and they're like, well, this person is an InfoSec luminary. A lot of people, that makes their skin crawl, right? Like, this is a thought leader in this space. And you have a lot of people in this space that have been doing it as long as I have, and they're like, God, that really makes me uncomfortable, right? And it's one of those things where the more you know, the more you realize you do not know, right? Like, the more you understand about something, the more you understand you don't know shit about it. Unless you're into quantum computing and like quantum mechanics. One of my favorite presentation beginnings was a university professor that came out to a quantum, like this beginning intro to quantum mechanics class. And he said, I want you all to know that I do not understand quantum mechanics. And he said, after this semester, all of you will have enough expertise so that you can say professionally that you don't understand quantum mechanics either. So I like that, right? I get that. But when we're looking at computer security, especially like the fundamentals, I'm now kind of moving past that like false humility. And it's like, sure, I feel fairly comfortable. I do this all the time. I've trained thousands of people, but all of that doesn't really get to the heart of why I came up with this class, working with Brian and a number of other people, and how we came up with these 10 things. Like, what makes these 10 things? And it's really derived from our incident response practice, which is ran by ATT&CK. And it's also derived on the fact that BHIS does over 650 assessments per year, okay? Over 650 assessments per year. And here, I want to pause my sharing real quick, and I'm going to open up something here, see if I can find it. And then I'll resume my sharing. Let's go here. I got to go to Excel spreadsheets. And I've got to update this, but this gives you the idea of it. And I can share this link with you all on this as well. Let me share a link. Paste this link in. There you go. All right. And let me resume. There we go. So now you should be able to see my screen. And this is from, I want to say, one quarter. These were the actual findings from different reports, and this is based on count. How many times we saw these different types of vulnerabilities. Now, this doesn't have the criticality. I started adding in the criticality in here a while ago on some of these, but when we're looking at it like unpatched software, that's absolutely a critical. Information leakage via data breach, that's a critical. Unsupported software, that would be a critical. Weak password policy is a critical. TLS SSL certificate errors. So you have all of these different vulnerabilities. And this is from a 3-month period at BHIS. And like I said, I've got to get a redo on this as well. So you have these vulnerabilities that show up, right? Where how often we see these and what is the criticality is interesting, because if you take all of these different types of vulnerabilities that exist, right? These vulnerabilities can be mapped to this class very, very, very easily, right? We're talking about default credentials. Well, vulnerability analysis would take care of that as well. Password policy nonconformance. We have a password section dedicated to this class of two-factor authentication and how do we do password cracking and password spraying. ATT&CK, aggressive mode pre-shared key. God damn, this is old. But this is, your standard vulnerability analysis would be able to detect that as well. So we have all of these different vulnerabilities that we have discovered in an organization and how many times we've identified these vulnerabilities. And this is really the fuel for what this class is, right? How are we going to go through and try to deal with these vulnerabilities and stop these vulnerabilities from being effective for attackers trying to break into a system? Right? So this class is based on what works. And this also required a little bit of unlearning, right? Because when you're looking at a lot of vulnerabilities and vulnerability analysis, we have this idea of what is the vulnerabilities that hit organizations. And a lot of what you see in the news is built around what is a novel new attack that's out there. And there's also news cycles where security news sources really have to play up stuff that isn't novel or all that interesting, right? They're like, well, there's a new piece of malware out there in ransomware land. And a lot of malware does the same crap. You'll see an article, it's like this malware establishes a command and control using HTTPS. They all do, right? This malware allows them to run commands on the local system. They all do, right? To be honest with you, it's a lot like trying to get excited for an Avengers movie. When the Avengers first came out, it was just like, this is amazing, right? And now they got it so it's so formulaic, you know exactly how it's going to play out, right? You're going to be introduced to the scrappy heroes at the beginning that are reluctant to become the hero. You're going to be introduced to a bad guy or a bad person that has a sympathetic but evil cause, right? The universe is overpopulated and we should get rid of all of these people. Or the Avengers killed my family when they were fighting these bad people and all this stuff. It's a sympathetic hero or a sympathetic villain, right? And then the hero finally they reach their nadir, their low spot, and then they come back and they realize who they are. It's like they see this arc again and again and again, and it's kind of boring, but they keep trying to pump it up. It's like, well, now we have the multiverse of madness. It's going to be the same arc. We have the Ant-Man. It's going to be the same arc. So it's really rare you see something absolutely fundamentally new through the process of this, and that's a lot of computer security. Because a whole bunch of computer security is core fundamentals. It's not the exploit du jour, it's the core fundamentals in your environment. And this class is built around those core fundamentals. We also like to start, I was talking about compliance and all of this stuff. And there's far too many frameworks that exist out there today. There's tons of overlapping and conflicting recommendations. The recommendations get out of date very, very, very quickly. The NIST Green Book is one of my favorites. And in the old NIST Green Book from 1985, they said that your password should be 8 characters, and it should change once every 60 days or something like that. And that's crazy, right? But almost every compliance standard since then adhered to that exact same standard. I like how Megan's like, wasn't that like a decade ago, right? 1985, is that, no 20? No, wait, 30. Oh God. Right? But that standard still exists in a lot of compliance frameworks. In fact, up until like last year, PCI was recommending a minimum password length of 7 characters. That's insane. 7 characters. I don't. I think it's crazy, right? And a lot of compliance frameworks are completely predicated and built upon meeting the absolute minimum required, right? So a number of years ago, Alan Pollard, the founder of the SANS Institute, got a number of us together, and he said, we've got a problem with all of these compliance standards out there, and I've got a solution to this. I got a solution to this problem. And all the SANS instructors gathered around. They're like, "Shut up, everybody! Alan's going to teach." And Alan goes, I've got an idea on what we're going to do with compliance standard. We're going to create a new compliance standard. And we all laughed because we thought he was joking. Turns out he was dead serious. So what actually happened, and it was brilliant, is he created the original SANS Top 20. What are the top 20 things that an organization should do in their environment? Now, eventually they handed that over to the Center for Internet Security and the critical controls out there. And they've been kind of open. I don't want to say open source because CIS does own them, but they're available for everybody and anyone can access them, right? And we have these really cool tools like CIS Navigator that allows you to automatically map the critical security controls to every other audit framework that exists out there today. And that makes your job a lot easier. Because if you're working computer security, you might be dealing with something that's healthcare and you're processing credit cards. So you have PCI and you have HIPAA, right? You might be a university hospital. So you have PCI, you have HIPAA, you may have some NIST compliance framework in there as well. It's just, there's so many frameworks that a lot of times are leveraged against organizations depending on their market vertical that it can become almost impossible to manage all of them. And you can use the Center for Internet Security as a Rosetta Stone. So if you look at one of these particular ones, like we got the Cloud Security Alliance, Cyber Risk Institute, Health Insurance Portability and Accountability Act, ISO standards. You meet that standard, you're going to be in compliance with all of these other standards as well. Becomes that kind of Rosetta Stone for everything in your organization. So everything we do is built on MITRE, of course, but you can also take it from the CIS controls perspective, and you can map that in as well. Now, when we're talking about MITRE, okay, many people, when they're trying to teach how to deal with the MITRE attack technique matrix, they go into each individual tactical MITRE technique. And they're like, here's how you detect this one. Here's how you detect this one. In this class, we're going to be knocking out entire classes of attacks. We're not going to be looking at it as how do we detect this? How do we detect that specific thing? But instead, we're going to go through and we're going to take out entire categories. We had a quick question. Can I destroy the lab when not in use? Absolutely. When you've stopped the lab or destroyed the lab, it's not burning your credits. So we recommend that you start up the lab like right before the lab starts. And then when you're done with that, you can actually shut it down as well. You can just kill it and then restart it, just turning it off and on again. So you keep those sweet credits for you to be able to work on these labs a little bit later as well. All right, so we're going to start at the very beginning. We're going to start at application allow listing. So let's go over here to MITRE real quick. Let's go to the MITRE attack framework. We're going to go to the enterprise matrix. And if we look at application allow listing, once again, this is one of those weird things where it's like, what is the specific thing that this is going to stop? Turns out it stops a lot, okay? Like if we're looking at initial access, like drive-by compromise, this shuts down a lot of the drive-by compromises that are out there as well. If we're looking at execution, command scripting interpreter, container administration command, exploit client injection, a lot of these are taken off the table. Persistence mechanisms, a lot of those get broken because we're restricting what the programs are that are allowed to execute on a Windows computer system, okay? We will lock that down, and now all of a sudden, if somebody drops malware into the downloads directory, it's not going to execute. If it's hits the desktop file, It's not going to execute. If it hits the temporary internet folders, it's not going to execute. So this particular technique makes a lot of what we do as a penetration testing company exponentially more difficult. And the reason why is because we have really hard time getting that initial code execution. Now, there are ways to still get code execution, which I can talk about a little bit later. But like one of them is if you exploit an app that is vulnerable, then that vulnerable app is allowed to execute. And a lot of times our malware will be allowed to execute as well. So when you're looking at a ton of different EDR products that are out there today, if you're looking at like, CrowdStrike, Carbon Black, all of these different amazing tools, they have AI and they have all kinds of things, which is great. But a lot of them have application allow listing at their heart. And in many ways, that is the more effective way of stopping an attack than the actual AI components of it. They're looking at where something's trying to execute from, and they're like, nope, not going to allow that to execute. And that's really effective. Right now, once again, there are ways around this, but this is going to stop something like 95, 98% of the drive-by downloads that hit your organization. And it takes out a large number of the different techniques in like lateral movement techniques, defensive evasion techniques, getting initial execution on a system, all of that stuff gets shut down. And honestly, the concept of denylisting was never really that great of an idea anyway. It really wasn't, right? And honestly, the psychology of denylisting kind of makes sense to most people because as human beings, that's sort of how we're hardwired. Let me give you an example. Whenever you look at human beings and our concepts and understanding of risk, we are very much hardwired to think in terms of blacklists or denylists. I'll give you an example. I give this every single class, basically. Let's say that you have two cavemen walking down a path in the middle of the jungle, right? And we'll name them Ugg and Thug. So Ugg and Thug are walking down the path, and Ugg walks past a mushroom, and he looks at Thug and goes, Thug, dude, that mushroom, dude, eat it. Mind you, I'm translating caveman, right? But you get the gist. And Thug's like, I'm not going to eat that mushroom. I'm not going to eat that mushroom, dude. And Ug's like, dude, you got to eat the mushroom. You're going to eat the mushroom. By the way, it had to have been dudes, right? This is just a guy thing, right? Oh, dude, eat this. Hey, this milk is bad. Drink it. It's just kind of the way things go. So they're sitting there arguing over it. And finally, Ugg tells Thug, dude, I double dog dare you. Once again, I'm translating from caveman at this point. And Thug's like, it's a double dog dare. Crap. Okay. So Thug eats the mushroom, right? And dies a horrible death. Like he's foaming at the eyes. He's like, there's massive hemorrhaging. It's like a horrible, horrible death. Like it's really bad. Like whatever, just think of it as a really painful death. And then from that point forward, his village tells the story of Thug the idiot. And once again, translating from caveman, it's like, Thug the idiot ate the mushroom. The mushroom has these yellow spots and these green lines, and we don't eat that mushroom because we'll die with blood coming out of our butt. It doesn't translate cleanly, but you get the idea. But that entire tribe had learned a deny list of don't eat that mushroom. Okay, do not eat that mushroom because these are the characteristics of this dangerous mushroom. That's how we learn. We learned not to go snuggling with polar bears. We learned not to swim with sharks. And that worked for humanity for literally 10, maybe hundreds of thousands of years because the risk profile didn't change that much. Right? The way that mushrooms grow and present themselves and the way that berries are and the way that polar bears are, it didn't modify and change all that much. So developing this model in our head of avoid these things and you will continue to live, most likely, was really effective. And we're hardwired for that, right? I remember I was sitting around, we just got done with Thanksgiving. I don't know how many of you had wonderful Thanksgiving politics discussions, but I actually made it all the way through Thanksgiving with not a single political discussion or argument. And I want you to know that I'm super, super excited about that. It's great Thanksgiving. I hope you had a similarly fantastic Thanksgiving. But when you're sitting around and you're having these conversations, like I remember years ago, I had this one family member that was like, in computer security, you do computer security, right? Yeah. I'm like, yeah, I do computer security. I got an idea. If I get the idea, you can like implement it and we'll split it 50-50. How does that sound? So here's my idea. My idea is this. You got all these viruses. Why don't you just write a program that looks for the viruses and stops the virus? You write it. I came up with the idea. We'll become millionaires. And I'm like, you literally just described antivirus, right? That's exactly what it does. But that's what people think of. That's the first thing that they gravitate to because it is the most simplistic, core human way of dealing with risk is a denialist. But the problem is when we're looking at denialists and the way it relates to computer security today, everything's like morphing so quickly, right? It's changing so rapidly. And imagine that Thug and Ugg see a mushroom today and tomorrow it's a sizzling filet mignon, right? It's changing quickly, right? It's the easiest thing to do, but it's the most ineffective, right? And that's true for almost any of the problems, right? Like if you look at any massive societal problems, you always have somebody that's got like, like simple solutions to highly complicated society issues. Those solutions sound great, but they're usually almost always wrong. And that also applies to computer security as well. So that's why we kind of stay away from this idea. So time to compromise. We have sacred cash cow tipping, right? Like I am constantly dumbfounded by what works in the pen testing community, right? I'm also dumbfounded about how we deal with it vis-a-vis corporations. So let me give you an example. We have a series of vulnerabilities that has been discovered by my team. We have like 5 people dedicated to bypassing AV. And it's a Microsoft core issue, the way that they're trying to sandbox all of their applications, right? So imagine Microsoft looks at all of these applications and they're worried about the applications escaping and exploiting and compromising the rest of the operating system. That's bad, right? So they're creating micro sandboxes for every one of these applications to protect the operating system from these applications. But here's the problem. Those sandboxes that they're creating for these applications prevent other applications from seeing in. So this means it's not necessarily unhooked from AMSI, the anti-malware service, but it means the visibility for a lot of third-party AV vendors is not able to go in and see what those applications are doing. The more we segment, the more we break up these applications and create barriers, which is a good thing, the more we're creating blind spots in our operating systems. So we've got a vulnerability where literally we can run malware all day long on Microsoft systems. We get initial code execution. We can put the rest of our malware. By the way, initial code execution is not incredibly difficult, but it's a lot of the post-exploitation stuff that gets hard. But we can move and we can add dynamic link libraries into certain directories that are blind from AV. We shared this with Microsoft initially. I think it was Microsoft Teams was the first time that we found it. And Microsoft kind of ignored it and slow walked it. Then Microsoft pushed out an update that had the same vulnerability, but now in the entire Office suite. And we coordinated with Microsoft, and Microsoft closed our ticket and said, this is now applicable to all of these other products. You have to open up a separate ticket for each one of the products separately. And it resets the timer for disclosure for all of them. This is ridiculous. I pay for their time as a penetration testing firm. And now we're doing QA and QC on crap that Microsoft literally has billions of dollars in the bank to be able to deal with this. So we find these vulnerabilities and we can bypass a lot of the security stuff that exists in Microsoft and a lot of the ecosystems that are out there. And I bring this up because if we can do it, do you think that maybe, just maybe, a lot of the malicious attackers that are out there can do it too? Do you think Russia has the ability? Do you think China has the ability? Do you think the NSA has the ability? Absolutely. So how do we deal with that? How do we try to deal with this? If we go back to that application like denylisting approach, where we're going to say these are hostile, these are legitimate apps and programs, this is something that Marcus Random came up with back in 1999. And he came up with this chart, completely unofficial and unscientific. And he said the amount of bad traffic is just growing exponentially out there. And it becomes very, very difficult to profile every single bad program that exists. So an example would be, and this is one of those techniques where there's variations of it that still work today, something as simple as ghostwriting, right? This is one of my favorite examples, right? So what you can do is you can create an executable, convert it to an ASM file, straight assembly. You can edit the ASM file directly, convert it back to an executable. Now, this may freak you out. Don't panic. First time I ever saw this was Royce Davis, a pen test geek, a long time ago. So this is what it looks like, right? We set up, and you are going to link up the libraries, get your IP address. You're going to create your payload. You'd use MSF Venom today. And then you get this assembly, all right? Now, in this assembly, you have this XOR right here, EDI to EDI, and you have XOR EDX to EDX. I don't want to get all computer sciencey, but let's get all computer sciencey. All right, so how many of you don't know what XORing is? Anyone? Go ahead and put it into chat. Come on, chat. What do you guys? How many people are unfamiliar with XOR? What is XOR? Anyone? A little bit, little, yeah. It's like ORing, but not. I like that. It's an exclusive OR. It's called bitwise comparison. I'm sure that cleared up everything for everybody, right? So I'm going to teach everyone exclusive OR, computer science concepts, and I'm going to teach it to you in the next 45 seconds. Here we go. All right, so I got a string of ones and zeros, all right? Now, in this game, if the top and the bottom are equal to each other, it's a 0. If the top and the bottom are not equal to each other, it's a 1. So if we do this, we have a 1 and a 0. They're not the same. That's a 1. We have a 0 and a 0. They're the same. That's a 0. We have a 1 and a 1. That's the same. That's a 0. A 0 and a 0. That's the same. 1 and 1. That's the same. A 0 and 0. That's the same. A 1 and a 0. Different. Gets a 1. And then we have a 0 and a 1. That gets a 1. Are they equal? No, they're not. They're not equal. Because if they were equal, what would this bottom row be? If they were equal, it would all be zeros. See? Simple. Exclusive OR bitwise comparison, where we're going to take two sets of bits. We're going to line them up on top of each other. If they're equal, it's a 0. If it's not equal, it's not a 0. It's that simple. Now, you do this in a number of different things, right? Like you do it to do comparison. So imagine a password, right? If I type a password of Apple, right? So if we do this, if I do Apple and we convert that into like bits, right? I don't know if that's right. And then I do Apple again, right? Then the bits are going to be the same. Right? If I do Apple, right, and they're different, like a lowercase, then those bits will not be the same. Does that make sense? So it allows your computer system to do comparisons of two values. All right. However, what we're doing here is we're XORing a register. Register is just a section of high-speed memory that the CPU can access with little to no penalty. It means it's really freaking fast. You have this register called EDX. It's just a register. An EDI is a different register. If we're XORing the same register from itself to itself, what is it always going to be? If it's the exact same register, what is it always going to be? Go ahead and type it into chat. 0. It's always going to be 0. Always going to be 0. Easy peasy lemon squeezy, right? So what this is doing is clearing that register. We're XORing a register from itself to itself. It's always going to be 0. So what this means is you can do anything you want to that register at all right above it. So if we have an XOR EDX to EDX, I can add 1 to EDX minus 1 to EDX. I can push EDX, pop EDX. I can do whatever I want to EDX. I can add in a whole bunch of assembly type functions. None of it matters because at the end, it all gets wiped away. So we can put in a bunch of junk code in front of that XOR EDX to EDX, and all of a sudden, your AV's ability to scan through the assembly to identify what's going on gets more and more difficult. Now, this is the base level of ghostwriting. There's other things, but same concept applies, right? So now you can push, you can pop XOR EX, DX, you can do all these different things, because at the end of the day, it's always going to be zeroed out every single time. How cool is that? By the way, this is awesome, because if you can do this at parties and show it to people, everyone's just going to be like, well done, you lead hacker, you. Look at you. Modifying assemblies just straight up like a madman. Yeah. No, it just look for those XOR register from itself to itself, add in a bunch of functions. And it's weird because if you upload the malware that you create to VirusTotal and you keep adding more junk functions, you see the AV engines start to dissipate on what they can actually detect. So pretty nutty, pretty nutty. Then you finalize it, convert it to an executable. Set up the multi-handler, and you've got a connection. There's also other techniques that you can do, like using living off the land binaries, where we can build and run on the tools and all of the different applications that exist already on the system. And it still requires that initial compromise. And that's ultimately where we're going to be stopping with the application allow listing that we're going to be doing here in just a little bit, is we're trying to kill that initial code execution. Because once somebody can get that code execution, you can start abusing administrator utilities. You can run all kinds of different things that exist on a Windows computer system, and they're generally allowed to run. So the point of all of this is AV dodging is a very dynamic process, and new signatures pop up very quickly. And when you're trying to bypass AV, you have to be flexible and very creative when creating your payloads. You test and you retest and you do all of these different things. And yeah, a little bit of Metasploit Kung Fu go a long, long way. Additional things that we can use a variety of different encoders. Tools like Metasploit or Cobalt Strike. And Cobalt Strike, they have BOF files, which are called beaconing object files that you can enhance. Let's go through, there's a great TrustedSec article on this, on how beaconing object files work. This is by Carlos Perez, I believe. No, I got it wrong. It's by Christopher. All right, so I'm going to paste this in. But these are different ways that you can modify the different beaconing object files, and you can modify them in a way to bypass endpoint security products. And there's companies out there that specialize in doing just this, like Brute Rattel. Like, what the hell did I just do? Brute Rattle? I'm sure I mispronounced it. Okay. I did misspell it. R-A-T-E-L, R-A-T-E-L. Here we go. Finally found it. All right. So this is Brute Rattel. Right here. And this particular tool is one of the main tools that we use at BHIS that is designed for this. We also have Outflank Security. And they have a bunch of different tools that they have that are designed, once again, for bypassing, like creating bots and things like that, right? So I'm kind of sharing all this because there's a lot of tools. By the way, there's one more called Unicorn by Dave Kennedy and the folks at TrustedSec that gives you a number of different output formats that you can use to try to bypass endpoint security products that work right now, which is just a great, great product. And it's free. You can use it as well. All right, so what we're going to do with application allow listing in the lab is we're going to do it different, right? We're not going to go through and try to do application allow listing for every single binary that exists on a computer system. Instead, we're going to focus on directories. Where are programs allowed to execute from? So we're going to try to shut down downloads, desktop, temporary internet directories for browsers and all this stuff, because that's usually the path that most malware exists when they first execute on your computer systems, right? So we're going to focus on, like, let's just knock it down to directories. We can talk at the end of the lab about how this works with trying to shut down. We can set it on individual executables. We can do it by publisher. We can do it in a number of different ways to try to shut down that initial code execution on a computer system. So this is a hash allow listing. This is where this goes through and it identifies every single application that exists on your system, and it only allows those applications to execute. This is really effective if you're working with VDI environments like Citrix, where you have a standard template system. That system is going to get spun up and taken down again and again and again, and it's a known quantity of what needs to execute, and it's been tested and vetted. That works really well. It also works really well for kiosk systems, and it also works well for let's say point of sale terminals or systems that like bankers are using, right? They have a handful of applications that they use and they don't use anything else. You can lock that down. Now, it's an easy concept, but it's actually difficult to push this out across an entire enterprise. I recommend setting this up for just specific types of systems that are more exposed to the public. Once again, a banking system is a perfect example. The systems are exposed. People are coming up to it every single, like throughout the day. Strange people are in proximity of these systems. There's no physical security to protect those systems. You may want to do like full hash allow listing lockdown on those computer systems. You can also do digital certs and publisher verification. I'm going to show you how to do this because Microsoft actually makes this relatively easy to implement. Let's say that you have like a download package that has to run in temporary internet folders. If it has to execute, most of these programs have a digital verification for the publisher, the name of the publisher, the version. You can verify that, and you can adjust the level of security all the way up to the very specific version number that is allowed to execute. Super easy. You give it a template, and then you set a little slider. Pretty cool. And I'll show you how to do that here in a little bit. Now, we're going to do this with AppLocker. Now, once again, AppLocker, they're coming out with all kinds of different things here in the next couple of years. They're going to become more and more effective. And I've got some links here that I can show you because Microsoft is switching over to something called application control, which kind of blows my mind because I'm not typing there. There we go. Okay. Here we go. So they're coming out with application control. So a lot of this will be changing. And let me go to Discord and I'll post this in. Looks like somebody already beat me to the punch. Thank you. So it's the same concept, but it gives you some more fine-grained capabilities of what you can do. But if you understand how AppLocker works, it makes implementing application control a lot easier. And with application control on AppLocker, we can do a rule based on path, which is what we're going to focus on here, hash, cert, and vendor, and it's easy to push out through group policy in your environment as well. So AppLocker, you just go to local security policy, you go to application control policies, and then you enable the rules. Start with the default rules. Don't do automatically generate rules. I'll show you what that looks like when I do the walkthrough of the lab. We're going to create the default rules, and then we're just going to put in the default directories that things are allowed to execute. There's also this final rule that allows built-in administrators to run as well. And then you start the application identity service and ready to go. And that brings us to the first lab of the day. All right, so we are going to go to, let's go to intro labs, go back to my lab list, and we're going to do AppLocker. Here we go. So I'm going to take this, I'm going to copy it, I'm going to paste it in. This is the lab that we are working on. And we have my cloud lab is set up and ready to go. I can connect via remote desktop protocol. When you run this, it's going to pop up something about copy and paste. You want to allow that, okay? You want to allow that because if you deny that, copy and paste does not work. Just for the record, copy and paste is really super helpful in this context. With this, we allow it, just click yes when it pops up. All right, we're now in the system. But let's say when you saw this, you saw that pop up and you're like, I don't want to allow copy and paste. That sounds dangerous. And you just made your life infinitely more difficult for this class. Well, you can actually get around that by opening up a browser inside of your cloud virtual machine and access the labs from there. You just do Strand.js GitHub. and you can go right into the intro labs and go right into the intra-class files, go to navigation, and then you can copy and paste inside of the VM, right? So there's two ways that you can do it, right? So you can do it on the outside, which I recommend, or if you can't copy and paste, you can do it on the inside as well, and that works just fine. So if we go to the AppLocker lab, you're going to go through, and I'm going to walk through it quickly, and then I'm going to do it slowly, all right? You're going to set your preferences to disable your endpoint security product, Windows Defender. The goal of this lab is not to show you how to bypass AV, is to show you how even without AV that's effective, we can still shut down attacks and a malware from hitting your system. Then you're going to set the firewall to all profiles state off. I'm going to go to this one because it looks so much better. There we go. Much better. And then you're going to open up your Kali system. You can access your Kali system from right here. You don't have to access it from the outside. Everything runs inside of the VM. The files are inside of the VM? What is this? All right. You're going to become root, and then you're going to mount a share on your Windows system. You see right here where it has the open bracket, your IP address. You replace that, and you replace the brackets with just your IP address. It should look like it does down below there as well. So you're going to CD into Windows mount share. You're going to get your IP address. You're going to create your malware, and you're going to give it the Linux IP address of your Linux system. And then you're going to run MSF console. You're going to set up the multi-handler, and you're going to exploit and run your malware, and the malware is going to work. Now, to stop that, we're going to go into the local security policy. We're going to go to application control policies, AppLocker. Then we're going to go to each one of these executable rules, Windows installer rules, script rules, and packaging rules. We're going to right click inside of this white space, and we're going to create default rules. This will create the basic default rules for you. We're going to make sure that they're configured. We're going to apply it. We're going to go to services, start the application identity service. Then we're going to do GP update force from the command prompt. And then we're going to CD into intro labs, and then we're going to try to run our malware as a non-administrative user, and you should get an error. All right. So that is the lab. Because this is the first lab, we're going to put 45 minutes on the clock. And at the end of the lab, I'm going to then do a walkthrough slowly and answer questions. From a pedagogical perspective, what I like to do is I like to walk through it quick, like we just did. Then you do it, you fumble around. And then at the end, I do the slow walkthrough, because then that slow walkthrough will have more impact for you as well. How did I launch the lab? The question was, you go inside of MetaCTF, and we have instructions. If you go over to resources, we have instructions on how to get here. There's a document that gives you step-by-step instructions to start and get into the lab environment. So if somebody can give them a link, it's over to resources. Jesse's got it for you here in a couple of seconds. There you go. And we have Cloud Lab instructions there ready to go. Now, if you have any questions, there's two places you can ask. One, you can ask in general chat, and we have a bunch of people here willing and able to help you out. The other place you can do is go to tech support and ask questions there. And you got a ton of people willing and able to help you out. Are we ready to put 45 minutes on the clock? I don't know who is running the timer today. But let's go ahead and let's set the timer, and I will resume. D Brown's got it. Let's set the clock, and I'll see you guys on the other side of the lab. Hello and welcome back. Let's get caffeinated and let's hack some boxes. All right. So we're going to go through the AppLocker lab. And like I said, we're going to do it slowly. We're going to walk through it together. And the first thing we're going to do is we're going to disable the Windows Defender. Once again, the goal of this lab is not to bypass AV. It's kind of dumb to create a class that's all about bypassing AV because literally everything that you do for bypassing AV will be broken probably by the time you get to the second run of the class. Because when people take classes, I'll give you an example. I was teaching at Sandia National Laboratories a number of years ago. I taught all the systems administrators there. And I had a lab where we bypassed, I think it was semantic, I'm not sure. And we did a morning class and an afternoon class. So it was a 4-hour class and we chunked them through 20 students at a time. And I did this and went through the first class and all of them were like, oh my God, you just bypass it like that. Oh my God. And they were all amazed. And one of my students, basically, as soon as they saw how easy it was to bypass it, instead of looking at this and saying, I think the lesson that John is trying to teach me is a deep philosophical lesson that we cannot rely on signature-based intrusion detection and signature-based antivirus detection to protect us against attacks coming into our environments. No, that isn't what he took from it. What he took from it was, oh my God, this is malware. It's bad. I need to send it to Symantec immediately so they can write a signature for it. And that's what they did. And it broke by the afternoon. So we don't do that, right? We do have some classes that are really similar to that. We have an on-demand class with Joff Thayer on implant creation that you should check out. So we're disabling it. We're also going to shut off the firewall because we're just going to upload the malware by mounting a share to the Windows computer system. We're going to set the administrator password to password 1234. Now, at this particular point, some weird things can happen to the class VM. Don't refresh your tab. You refresh your tab, bad things occur at that point. Oh, by the way, we have are those available for sale in the store? The I am what I am because I RTFM shirt. Check out those shirts.
They sure are, boss.
Oh, thank you. Thank you.
And that Canary Tokens one is as well.
Oh, both of them are there? Oh, nice. Do we have the Callisti, the one with the K and the apple? I don't know if that one's there yet.
I'm not seeing it on the shop as yet.
I'll share that shirt. That's my favorite. I'll share that here in a little bit. All right, so now I've got the IP address as well. Now I've got my Kali system. Let's go ahead and let's create our malware. I'm going to become root because root is root. And there we go. Now I'm going to mount the share. Now, when I mount the share over to my Windows box, I need to set the IP address to be that of my Windows computer system, as per the instructions say. So we go through and we do 10.10.244.103. And I'm going to hit enter, entrée. And then I can CD into mount Windows share, ls. We've now mounted that share. It's now set up and it's ready to go there as well. All right. So now I'm going to get my Linux IP address because I'm going to need that when we create the malware. I'm going to need that IP address of ETH0 to be able to make the reverse connection. We need to embed that inside of the malware. So now we're going to create that malware with a tool called MSF Venom. Now, MSF Venom is actually a wrapper of two separate tools, MSF Payload and MSF Encode. Payload creates the payloads, hence the name. And then MSF Venom or MSF Encode encodes that malware initially to bypass bad characters. Now, on any system that's using C programming, which is all of them, there are certain character sets that are bad that'll be like string terminators, like 00AF, FF. These particular character sets will terminate their string copy. So when you're moving data from one area to memory to another, 00 means that's the end of the string. So Metasploit created a tool called MSF Encode that encodes your binary to bypass bad characters. So it just recodes it with something different. Turns out That's pretty effective for bypassing some AV engines, some strict signature-based AV engines. So we're using MSF Venom. The architecture is x86 for 32-bit payload, so it's compatible 32 and 64-bit. The platform is Windows as the operating system. And then the actual payload is going to be Windows, the operating system, Meterpreter, the type of malware, reverse TCP, the communication profile for that malware. And then the L host is the IP address of our listening host, our Linux system, right? Or listening host is more accurate, which is 10.10.221.70. Your IP address will be different. The port is going to be 4444. It's going to be an executable, and it's going to share it out to a file called trustme.exe. Like, like Landshark. So that's going to actually generate this. Now, this takes a little bit of time. Metasploit is the world's largest Ruby project. So it's got a lot going on under the hood right now. Tons of things happening at this particular point. But in a couple of seconds, it's going to say no encoder specified. Here's the payload size, the final size of it, and all of it is shared into a folder called trustme.exe. And if I look there, you can see trustme.exe is present and accounted for. Now we're going to start MSF console, right? So we'll start that up. Now we've created the malware. Now we have to create the framework that receives that connection back. And that's going to be using a tool called that's going to be using a tool. We're going to use a multi-handler to do that, which is type of exploit class, which is weird in Metasploit. Like exploit is a multi-handler. What the hell is that? There's a number of exploits that exist in Metasploit for a number of different operating systems and applications. And Metasploit breaks those down by operating system, service, and exploit. So you would have Windows, SMB, and then 08065, right? That would be an exploit. So operating system, service is SMB, and then the actual exploit. But when we're setting up something where we're creating general run-of-the-mill executable malware, we use the multi-handler. So it's the multiple operating systems and then the handler for receiving those connections. So let's go ahead and set that up now. So we're going to use the exploit multi-handler, paste it in. Then we're going to set the payload to be Windows Meterpreter Reverse TCP. Now notice that that payload matches the payload up above. I'm going to tie those two things together. We're going to set the L host to be our Linux IP address. There we go. See if I can get that there. What is our Linux IP address? Now I've gone too far. Let me go up. The Linux IP address is 10.10.221.70. 10.10.221.70. There we go. And then I type exploit. Like that. And nothing happens. Nothing happens at this particular point, except it says starting listener payload handler on 10.10.221.70 on port 4444. Comes up. There we go. We've got that. Now it's waiting for the malware to execute. Now, we're showing you the problem statement, right? Like how malware can execute on a system. And then the next step that we're going to do is actually shut down that malware from running. All right, so I'm going to go ahead and open up a command prompt. We're going to CD into the top level directory. Oops. There we go. And I'm going to run trustme.exe. Now you're going to see that reverse connection coming in, and we've got a Meterpreter session. So I can list out the files. I can see the processes. I can do hash dump to dump the password hashes from the system. So I'm on this computer system. I've got malware. I've got execution. We're ready to rock and roll. That's the problem, right? The malware can execute, right? I could execute it from my desktop. I could execute it from downloads. I could execute it from temporary internet folders. I can execute it from just about anywhere. And that's what we're going to do to try to stop this from happening. All right. So now I'm going to exit my multi-handler and we're going to kill that session. All right. So I am going to run this again. So we've got it listening. And I'm going to show you how we can shut that down by restricting the execution path on Windows computer systems, right? All right, so let's go ahead And let's get started on that. So we're going to go ahead and we're going to go into local security policy here. There we go. I'm going to go to local security policy. And then we're going to go to application control policies right here. And we're going to go into AppLocker. So go to application control policies. There we go. We've got AppLocker. And if I expand this, I can see that I have executable rules, Windows installer rules, script rules, and package app rules. I already have the default rules for package app, script rules, and Windows installer rules, but I need to create it for the executable rules. So I'm going to go ahead and right click, and I'm going to do create default rules. And it creates these rules based on path. Let me expand this so you guys can see this, right? Make it bigger. There we go. And now it's identifying where the paths are for programs to actually execute. Anyone can execute anything in the program files. Anyone can execute anything in the Windows folder, and the administrator account can run anything they want. Anybody that's an administrator account can execute. Now, that is your pressure release valve. If something breaks, the administrator account needs to have that ability to be able to log into this computer system, and they need to have the ability to be able to fix whatever problems. If you don't have that rule, you brick your system, it is bricked, right? What is that song? She's a brick and she's drowning slowly. Ben Folds 5, right? So it bricks the system. So we now have created these rules, right? So we have the default rules for installer, script, package, and executable. But because it's Windows, you can't just make one simple change and expect it to work. No, you've got to go to like 3 or 4 other places. So what we're going to do is we're going to configure rule enforcement. And we need to make sure that these are configured and enforcing the rules for all of them, for executable rules, Windows installer rules, script rules, and packaged app rules. If I change those, I would click apply. We need to make sure that they're enabled there. I click oakley dokley. By the way, okay, okie dokie, right? What is the correlation between okay and Budapest Hungary? See if anybody can find that, since I'm heavily caffeinated. See if we can tie that together. All right. So now we have it set up. We've got these rules, but we're still not done. No. We need to go into services now. I'm going to go into services. And then we need to go to the application identity service right here. And we need to start that service. At which point you would think, are we done now? No, my Smurflings, we are not done. Because we need to push that rule and force the group policy changes on that system. So we're going to do GP update force, right? Like this. I'll go into the command prompt like that. Now it's going to update the policy. It's going to pull those new policies that we've created. It's going to push it onto that system. Policy update has completed successfully. And now we're going to try to run Netcat on this system right here. Oh, I need to go into CD, into intro labs. Then we're going to run the Netcat, but we're going to run it as the user whitelist. All right. I hit enter, put in the password for whitelist. What the hell did I set the password? It's ADHD. Okay. So we go ADHD. Like that. Let's try that again because I misspelled ADHD. And now it says run as error. I'm not able to run Netcat. This program is blocked by group policy. For more information, contact your systems administrator. Okay. So if anybody other than administrator was trying, it's just an executable, Mr. Mojo. By the way, dig the name. Really cool name. It's just an executable, right? What about the program trustme.exe? Okay, hell, let's go back and try that. So if I do this again and I try to run trustme.exe, like so, I put in the password, it also blocks it, right? Anything that is not in those specific directories that we outlined is not going to work. Okay, it's not going to work. But how do you guys feel about off-roading? Should we do some off-roading? I don't know if what we're about to try is going to work. I have no clue, but let's try to make it happen. All right, so we're going to go to the local security policy. I'm going to go to executable rules, right? and I'm going to right click and I'm going to create a new rule. So we're going to go ahead and go next. And we're going to say, we're going to allow a program to run by everybody. And we can do the rule by the publisher, the path, or the file hash, right? File hash is the most secure, right? That's a full hash of that executable, no question. That is the executable. The path is the directory it's in, less secure. But it really helps shut down that initial code execution in a system. Okay. But I want to show you the publisher trick. Let's see what we can do. So we're going to go publisher. I'm going to go next, and I'm going to give it a reference file. I have no idea if this is going to work, but we're going to give it a shot. I'm going to go to the C, and I'm going to put in trust me as the executable. And it says it doesn't have any publisher information, so it's not going to work. Let's try the netcat, see if that one works. I've got lots of files to try. Don't worry, we're gonna be fine, right? Do executable netcat. Nope, that doesn't work. Let's try one that I'm pretty sure works. Let's go to the desktop and oh no. Let's go to program files. Let's go to C. Let's go to program files. I think it's program files x86. Nope. Let's go to program files. I'm looking for putty. There it is. All right. So now I can take putty and I can take a program like putty. And now it's going to pop up and it's going to say, what's the level of security that I want for this? Now, the problem with trustme.exe and the problem with netcat.exe is there was no publisher associated with it. There's other programs we could have chosen those directories, but I'm choosing putty right now. So you can see that this is the publisher information for this particular executable. So the publisher is Simon Cambridge. We have the product name is Putty Suite, the file name is Putty, and the file version is 0.81.00. I can reduce the security to just the publisher, to the product name, to the file name. So publisher works if you're like, you know what, we trust anything at all from Oracle. Great, you can just create a rule that allows anything to execute from Oracle. So let's go ahead and browse a different one. Let me go back into C. Let's go into Intro Labs. I have some other things. Velociraptor. Okay, so if I'm in this program here, let me CD into Intro Labs, and I go Velociraptor. Am I in the right place? Yeah, get hung up. Yeah, let's go Velociraptor. Yep, Velociraptor. I can run Velociraptor, and let's see if I can do the run as Velociraptor. It should not allow this to run. Oops. There we go. So let's put in Velociraptor. There we go. It should throw an error, right like that, and it says it's blocked. So instead of doing putty or netcat, now I can go in and choose Velociraptor, and the publisher is going to update. There we go. It's by Rapid7. The name of the product is Velociraptor. The product file name is velociraptor.exe. I don't want to get crazy with the like version number. I want to have the publisher. I want to have the name and the file name itself, product name. So now I'm going to go next. And this is going to create the exception as the publisher. So we've got that as well. So now I'm going to click next. And I'm going to create it. All right. So now we've created a rule for Velociraptor. I might need to do a GP update, but let's give it a shot. Now when I try to run it, there it worked. All right. It didn't throw an error at that point. Right. So we can create rules based on directory. We can create rules by hash. And we can create rules by publisher and file name. And now that's not 100% certainty, but this is a really good way if you have a program that has to execute in the desktop, it has to execute in downloads, it has to execute in temporary internet folders. You can create an exception rule by the vendor of that particular rule as well. So does that make sense to everybody? So off-roading kind of worked. Hooray. Alrighty. Now I've done horrible things to my VM, things that I'm a little bit ashamed of, chat. I got to be honest with you. I feel bad. I feel bad about what I have done to this machine, and that what we've done to this machine may have impacts to things later on in this machine. So what I'm going to do is I'm going to kill this machine and I'm going to put it out of its misery. I'm going to close this. Then I'm going to go to the dashboard. I'm just going to destroy this virtual machine. I hate to say it. It's nothing personal. I'm not emotionally attached to this machine. I'm going to destroy it. And the reason why I'm going to destroy it is because I want to fix it. And I'm probably logged out right now. I'll have to log back in here. Just give me a second. I want to destroy that virtual machine to save my credits. It's selfish. It's a selfish thing. I get that, right? So I'm going to go back in and I have the labs that are started. I'm going to click destroy lab and we're going to destroy that lab. So we're going to start over, right? Yeah, don't get too attached to virtual machines. So now I'm ready to go for the next lab. I click start lab and everything's going to start over with a brand new set. So I'm excited about that. And you should be excited about that too. So let's jump in. Let's talk about password controls. So if we go back to MITRE, let's go back to the matrix. Like if we're just doing application allow listing, there's a ton of these particular initial access like vectors that we have shut down, right? Like exploiting a public facing application, drive-by compromise is done. Like they got to get initial code execution. It's not 100% done. They could exploit an existing service. That's possible. They could totally do that. But just getting someone to run a document or an ISO or a weird RAR file, that's off the table. This also shuts down a whole bunch of privilege escalation techniques. This shuts down a whole bunch of like defensive evasion. This shuts down a ton of lateral movement. It really, really limits the attacker and what they can do. And part of the reason why we're trying to limit what the attacker can do and what they can execute is we are limiting that because as we focus and funnel what the attacker is actually able to do, it creates better detection strategies for us in that system. Because if we limit the number of moves that you can do, then it becomes easier to try to start to defend and create like a gap analysis and then filling those gaps for what the attacker may be able to do in that environment as well. So that's pretty cool. I like that a lot. So let's move into the password controls as another way that just really limits what attackers can do post-exploitation trying to get into environment. So we're going to start out with password spraying. I think we're going to do the external password spraying lab. I'm going to check on that. Let me check here real quick. So I've got an external password. I have an internal password spraying lab and an external password spraying lab. God, I like this new lab. Guys, do we want to try to do a new lab today? I don't know how you guys feel about just trying this, right? I like this new lab. I think we're going to do it. Yeah. Let's do it. All right, so here we go. All right, so the idea of password spraying is you use the same password across multiple different accounts, right? You got season and year like spring 2023 or winter 2025 or winter 2026 is a password that you see in a lot of environments because most environments you have to change your password once every 90 days. And if we're looking at what changes every 90 days roughly is the seasons. So it keeps a password that's easy for you to remember and you update it and you're not repeating the password for the organization that you're working in. So it just makes it really easy for you to be able to do that, right? So it requires the attacker to conduct user harvesting before they ever get there. And then the attacker feeds the IDs through like burp to try all the different accounts. And they do this also because they're not trying thousands of passwords against one account. They're trying one password against thousands of accounts to try to stay underneath that account lockout threshold in the environment. So time to compromise, if you're looking at the size of the network, this is a huge factor, right? If we're looking at the size of the network, let's say a network that has, 6 people, it's going to be really hard to password spray 6 people. It just is because your sample set is so small on that as well. Now, when you're looking at a larger network, right? Like if you look at a medium network of 10,000, it's about an hour. It's about an hour to be successful in trying to break in to a system. And then once the attacker's in, this is the thing that's really frustrating for me, is it's a very hard attack to detect because the attacker has a valid credential on that system, right? The attacker has a valid credential. So if you're looking at this, we can also bounce the password spray attacks. You're like, well, we'll just detect password spray attacks and block the IP addresses. Great idea. Unfortunately, the way attackers work and the way we do it at Black Hills Information Security is we use a cloud provider to attack another cloud provider. So we'll bounce our attacks off of Amazon with Fireprox or CredKing to hit Microsoft Azure tenants, right? And that works really, really, really well because they don't get blacklisted. They don't get denylisted on that as well. So this is what a password spray looks like with a tool that we use quite a bit called Domain Password Spray, where you can hit like external email services to try to enumerate user IDs and passwords on it as well. All right, so what we want to do now, let me check real quick. What do I have for, let's break it up. We're going to break these two labs up. All right, we're going to do the password spraying lab right now. So let's go ahead and let's jump into that. And let me go into, I am lost. I'm lost in my own class. How wild is that? All right, so we're going to do the lab external password spray right here. Let's do external password spray. So what you're going to do is you're going to disable all of this. I'm going to start up my lab just so it's ready to go. There we go. We're going to disable AV. We're going to get our IP address of our system, and we're going to disable that firewall. We're going to disable that firewall. We're going to CD into intro labs, and then we're going to curl a tool that generates 200 users, and we're going to run it, and it should look something like this, right? Then you're going to open up a Kali terminal. You're going to become root, and you're going to grab a user list. Now, that user list would be like something that they enumerate on like LinkedIn or some portal where they can enumerate user IDs. And then we're going to use Metasploit to do the password spraying against our remote Windows computer system. So we're going to use auxiliary scanner SMB login. We're going to set the R host to be 1010.124.217. We're going to set the user file to be the user file that we would get through Recon. And it should look like this. Then we're going to open up Event Viewer, and we're going to right click into clear log because we want to see just what the password spray looks like in our event logs. And then we're going to go back to the Kali system and we're going to type run, and it's going to attempt to log in with every single user ID and password. And it's able to find out that Michael has a password of winter 2025, Christopher has a password of winter 2025, and Dennis has a password of winter 2025, and he is an administrator on this computer system. Dum, dum, dum. The plot thickens in that situation, right? Now we should be able to see the logs. Okay. For some of you, this will go pretty quick, right? This will go pretty fast. For others, you're going to kind of spend some time with it. But here's the challenge. I want you to string the two labs that we just did. In the previous lab, we took a user ID and a password. The password is password1234 for the administrator account. And then we used Metasploit to gain access to that system with that user ID and password. Now, we used the password spray module for SMB in Metasploit to find a user ID and password. I want you to try to access the system using Metasploit with the user ID and password that we just got. And then I want you to screenshot it, and I want you to upload it into chat. I want you guys to show me, how do you take this password spray with the lab that we just did to gain access? And I want you to do in screenshots. Mr. Brown, have we enabled screenshots? I think Brian and the team can enable that, but we need to make sure that screenshots are enabled and people can upload screenshots. So let's go ahead. Let's do this lab, and I'm going to add that extra step, right? I want you to string these two labs together. We got the password spraying lab, and then I want you to tie it together with what we did in the previous lab. If somebody can try to upload a screenshot on this system to verify that it's working, that would be really, really super cool. And with this, let's go ahead and let's give it 30 minutes for this lab, because the main lab is pretty straightforward, pretty easy. But the other part, I want you to string together as a challenge, team. I want you guys to string together as a challenge. I want you to then use that user ID and password to gain access to the remote computer system. Start the clock. Let's go. Help each other out too. All right. I'll see you on the other side, everybody. Why, hello. All right, so let's get through this. All right, so one of the things I'm doing with my labs as we're progressing is trying to put in like what is the MITRE technique that we're actually talking about here. So we're doing a password spray attack. This is technique 1110 in MITRE. And then these are all the APT groups that have been known to actually use this particular technique as well. So we've set that, kind of getting it established. Let's go ahead and let's open up Windows Defender, or sorry, disable Windows Defender via PowerShell. Not that it would matter in this one. It may matter with the malware that we create. And I saw a number of you mounted the share, which is awesome. That's another way that you can do this. But we're going to, I'm going to do it slightly different. Some of you did the share, which is absolutely valid. I'm going to go through and do it the way where I get a full interpreter session on that system. All right, then I'm going to get my IP address on this system. So let's go ahead and do IP config. I'm going to slide this over there. Then we also need to make sure that the firewall is disabled. By the way, host-based firewalls totally screw up this technique for attackers, right? Like if they're internally, and they're not attacking external, but like if it's internally inside of your Active Directory environment, host-based firewalls screw this up quite a bit for attackers as well. Then we're going to CD into the intro labs directory, like so. And then we're going to go ahead and curl down the user list to generate the 200 users on the system. And then we're going to go ahead and run that batch script. Oh, well, I need to do this. I'm in the wrong command prompt. There we go. Kind of chunking that up. Here we go. All right, so let's go ahead and I think I just screwed this up. I was in the wrong command prompt. Let's go ahead and try this again. Let's go ahead and do this. Do something here real quick. Let's go. Make sure that this one is right. Yeah, this is the right one. This will work. All right, we got it. All right, so we should be good. Let's go ahead. All right, so we're recoverable. All right, so now we're going to be in our Kali prompt. And then I'm going to go ahead and become root, just following the instructions, which helps. Now I'm going to pull down the user list. Now, the way somebody would get this user list is they would do external recon, and they would try to pull down a user list from like LinkedIn. Sometimes websites have like an employee directory, and we try to pull down that employee directory, but we'd use recon to get the users off that system. So now we're going to fire up MSF console, and let's go ahead and get that running. Takes a little while for it to start. And once again, Metasploit has a ton of different modules that exist. So you have like auxiliary scanning modules and things like that as well. Good point. Let me go ahead and get my IP configuration because I'm going to need that in a second. I'm just going to set that over there. There we go. Because that IP address is really a big deal. Use OSINT to get an idea of potential employees users are. Absolutely. And then we're going to use that against the target organization. Now, we're doing a scanner that allows us to authenticate via SMB because that's the protocol that we're using here within the lab. But you can also do HTTP authentication. You can do FTP authentication. You can do Citrix authentication. There's any type of external like service that has user ID and password and only user ID and password is a valid attack methodology getting into an organization. So much so that when we're testing an organization, if they have anything from an authentication portal that is just user ID and password, it is automatically a high finding. Like, don't even exploit it. As soon as it doesn't have two-factor, it's automatically a high finding for an organization. So now I'm going to use the auxiliary scanner, and I'm gonna actually do something different here. Let's go ahead and set this back. Let's try this again. I'm just gonna go ahead and go scanner and then hit tab a few times. And we have 628 possibilities because there's more than just SMB, right? There's DCE, RPC, DB2, you got FTP, Apache. There's all these different scanner modules. We're just using the one associated with SMB because it is the one that is available to me. So we're going to use SMB as the service that's provided, and then I'm going to use SMB login. I could do FTP login, and so on, right? So we would just use that. Now I'm going to set the R host to be the IP address of our remote IP address, which is 10.10.235.194, like that. So now we've set that up. And then I'm going to set the user file to be users.txt. That's the file that we downloaded that we would get from Recon. Got that as an option. And then I'm going to set the password to be winter 2025, right? So I can do that. And now I am, oh, that's right. I want to go in and clear the event viewer. And we're doing this because I think it's important for people to understand that this is really noisy. There aren't a lot of logs that are generated specifically to one user, right? We're using one password for multiple different users, right? So I'll go into the Windows logs. We're going to go into the security logs. I'm going to right click and I'm going to clear the event log. And which, by the way, as soon as you run clear event log, it automatically generates an event log that says that it was cleared. So I'm just going to clear the event log. And there we go. 1102, clear the event log. And then we're going to go back to our Metasploit instance and we're going to run the scanner, right? So now it's going to try to log in with each one of these different user IDs. And it's going to find, you can see it's red. And it's going to show in green anybody that we were able to log into successfully. And it's got a handful of different accounts. There we go. We just got a bunch of them. And Dennis is one of those accounts, right? So if I kind of scroll up, you can see it was able to log into, too fast. There we go. You can see Dennis has a password of winter 2025, and Dennis is an administrator, right? So we do that password spray. We can see that that's an account, and now we can kind of walk through the stuff that we did in the previous lab to gain access to it. So let's go ahead and do that. So I'm going to do use exploit, and we're going to do SMB, because now I want to log in, and we're going to use SMB and Windows. I got to do Windows, SMB, PS exec, right? Because we're going to use that to authenticate to the remote system. Bring up my IP address here. Oh, by the way, if you go back here and you refresh, you're going to see all of the login attempts that happened, because there's a lot of login attempts that happen. It's a very noisy attack that a lot of people don't detect real well. I'm going to set the R host to be 10.10.235.194. Once again, your IP address should be different than mine. I'm going to set the SMB user. I'm going to set the payload to be Windows. Wait for it to autocomplete. Meterpreter, reverse, TCP. And then I'm going to set the SMB user to be Dennis. And then I'm going to set the SMB pass to be winter 2025. I'm going to use exploit. All right, so now it's going to authenticate to that remote system as Dennis with the password of winter 2025. It's uploading the malware, and now we have access to the computer system. So we're kind of tying some of this stuff together, right? Like if we have AppLocker control enabled, would it have stopped this attack? No, it wouldn't have. No, it would not have, because Dennis is an administrator, right? If you remember the administrator account, it bypasses anyone that's in the local administrators groups, has the ability to run any executable they want on this particular computer system as well. So pretty cool, right? So kind of tying these different things together and showing you how we can kind of chain some of these labs together. And if you want, you can kind of leave this up right now. We can talk a little bit about password attacks and things of that nature. And we're going to do some password cracking. I'm going to leave this here because I have some extra stuff that I want to show you as some fun things a little bit later. So like basically it goes around this. So if I do a hash dump against the system, we have a ton of different user accounts that were created on this particular computer system. But you can see that we have this administrator. I'm able to get the administrator's password hash. And I'm going to show you how we can take that administrator password hash in a little bit. And I don't even need to know what that password is. I don't even need to crack that password hash because all Windows authentication is clear text authentication. And I'll show you why it's clear text authentication here in just a little bit, but it's absolutely flipping crazy on that as well. All right, so let's go ahead and let's get running on that. So let's go into the next step, short passwords. Now, a lot of you did the mounting of the share, and that's fine, right? We got a user ID, we got a password, we can mount that share. We're an administrator, we can pull down all the files. I did it with malware, just kind of show you a different way on that as well. So you all did it right. So now if we get into the password problem that exists with short passwords, we're right back into the password mix, and we're getting into that issue of easy to guess passwords, right? Like if we're looking at season and year, that is an easy to guess password because it's very sprayable. But let's say we don't allow dictionary words. Then what more often than not is somebody's going to do like lead speak substitution, and they're going to do camel case. So instead of winter, they're going to replace the I with a 1. They're going to do some kind of trick like that. And that happens all the time. So if we're looking at like password complexity, really the most important thing that matters is length. It absolutely is the most important thing that matters. Once you start getting into a password that's like 15 or more characters, mine is like, I think 24 characters. You're talking about heat depth of the universe to be able to try to crack that password. And what we're trying to do is we're trying to like stop hemorrhaging, right? So if somebody gains access to one part of an organization, right? If somebody gains access to one part of an organization and then they can dump password hashes from other users, then if you have weak password complexity between like 8 and 10 characters, you're now in the situation where basically you can go from one account that's been compromised to potentially hundreds of accounts very quickly. So that's what we're trying to avoid, right? We're trying to avoid that hemorrhaging where one account then bleeds to all of the other accounts in an organization. So we're trying to do that. Now, you get into some scenarios where someone says, well, we have two-factor enabled, so therefore we can do weak passwords. And this is one of those things that I hate in computer security, where they start doing trade-offs. Like if we turn on the, two-factor, well, then we can do 6-character passwords. No, you can't. It's this constant trade where people are trying to reduce security controls whenever you implement new security controls as kind of some type of like devil's bargain. And it really just opens up a number of possibilities for an attacker to then get access to your environment. And, I'd be fine with that if people could tell me and prove to me that two-factor authentication is enabled for every API, for every portal, for every service. Then I'd be like, yeah, sure, okay, do that. But it almost never works that way. You're constantly running into situations where different APIs and services are running that completely bypass the need for two-factor authentication, right? So there's a lot of different hidden two-factor bypass techniques that exist, right? So like one of them would be like Outlook Web Access Exchange Web Services. This is one of the first ones that we did years ago. We actually first shared this with the FBI because we'd done some research. Bo had created the password spraying toolkit stuff that he had with domain password spray. And we were going to go public with it, but I have an active clearance. I do stuff with the FBI still. And we knew that we could gain access to a number of different FBI services doing this technique. And we coordinated with the FBI to get their stuff off of the open internet and really tried to lock it down. And then we actively worked with MITRE and we worked with Microsoft to try to figure out how we could try to fix this. We didn't get a lot of traction with it. And then shortly after, we kind of did some releases of some of the tools because people weren't fixing it. They were like, it's configuration. People want to configure the things insecurely. That's their choice. We started seeing universities getting nailed all over the place, right? And then we coordinated with the FBI and different certs to try to get the word out to as many people as possible that this was an attack vector. Now, we still see this. We still see this constantly in incident response engagements, where organizations that get compromised don't have two-factor enabled, and then they get popped. And it happens again and again and again and again. And it's almost like a broken record that keeps skipping again and again and again on this particular thing. So that's why if we're testing an organization and they don't have any two-factor authentication, it's like an immediate high level vulnerability on that as well. And once again, going back to the strength of passwords, the only thing that matters is this length, right? And I see all these websites that are like how to create a strong password. They're like upper, lowercase, alphanumeric, special character, and then you can get away with like an 8-character password. Bullshit. It needs to have all the characteristics of a long, strong password, right? And, don't use the dictionary words. It's something that we see people stop all the time. They're just going to do camel case or hacker case substitutions. Happens all the time. And it just matters to get that length up as long as you possibly can as well. And then when you're looking at two-factor authentication, it's something you know and something you have. And Brian has brought up a great point. Use a password manager and randomize your passwords, right? As much as you possibly can. Token-based, even SMS-based. Like a lot of people shit on SMS-based authentication. And it's been banned at Black Hills Information Security, but that also gets into the threat model for BHIS. If we look at the threat model of Black Hills Information Security, my threat model is fundamentally different than my aunts and my uncles who are trying to protect their personal emails and their PayPal accounts, right? My threat model is nation-state level adversaries doing SIM cloning to be able to gain access to the SMS notifications hitting like my authentication for BHIS. That is in our threat model. I do not expect that an attacker would do that for somebody's like grandparents, right? I mean, it's absolutely possible. So if we're looking at this as, a threat model and you're telling people that are just trying to protect their home accounts, don't be like, well, don't ever use SMS. You're making the barrier to good security high. And what a lot of people do once they encounter that barrier to good security that is high, they get to the point where they're like, well, fuck it. Oh, geez, I'm sorry. I'm trying, Brian. I'm trying. I am. I swear to God, I'm trying to be better. So yeah, swear jar. Thank you, Jesse. I am. Okay. So Mr. Mojo said, aren't SMS codes less secure too because they travel over telecom phone networks? Once again, that goes into your threat model. For my aunt, my uncle, is a nation state adversary going to intercept that traffic? No, like they're not, right? If you're somebody that's working for the Department of State, yes, they may. And we saw this with like Volt Typhoon and Salt Typhoon, that the Chinese have that type of, that type of threat model in their space for certain types of people. But if I can get someone to install Google Authenticator and walk them through how to set it up, I'd love to do that. But man, SMS-based authentication for general users seems to work, right? And I'm going to take that a long way as much as we can, right? And all of them are better than no two-factor authentication. And that's ultimately what we are trying to avoid. You can ask the user to let you in. You can do SIM cloning. Once again, those things actually exist. And then you get into like, people are like, well, we're going to enable two-factor for everything. We did it. Service accounts. Okay. Service accounts are a thing, right? They're absolutely a thing. And you can't have two-factor authentication enabled for a service account. And I think that that's what a lot of people in security forget. And then if you push this, they're like, well, if you set up the service accounts, you set it up in a different OU, and then you don't have to worry about them being logged in. Yeah, if you do everything right. But we see tons of organizations that set up service accounts in their users' organizational unit and Active Directory, and that becomes a way for us to then gain access to those service accounts, right? And it's weird because that's external. We may find those service accounts, but you also always find them internally, and that gets even weirder. And I'll talk about that as well. And a lot of those service accounts, there's no need for account lockout. There's no need for two-factor authentication. They don't ever time out the passwords for those service accounts. And they're oftentimes overlooked by security teams, and they're beloved by attackers. And this gets into some weird stuff with service account. One of the strangest techniques that's come out over the past, like 8 years, was developed by Tim Medine at Red Siege. And he found out that curb roasting, he named it curb roasting, is a thing. And what you can do is you can query Active Directory for service accounts and get their ticket granting ticket. And in that ticket granting ticket is their password hash. And any user ID can request that, and you get the password hash for that service account. And then you can crack it. That's terrifying, right? And this is an example where you can try to do everything right, but there's going to be these like little things that exist in an organization that you can then take advantage of. Another one would be link local multicast name resolution, MDNS, and NetBIOS name service. This is wild. Okay. There was a hacker that was arrested on an airplane right here. Here we go. So this dude, whose name I can't remember, was actually running Wi-Fi. His name is Michael Klapsis. I think he was Australian, but he was doing like wireless attacks on an airplane while it was in the air. And then he was also doing it in the airport. And specifically, he was using a Wi-Fi pineapple, and he was doing it, and you can buy a Wi-Fi pineapple. They're dirt cheap. They're from Hack5. They're very, very good, easy Wi-Fi attack tools to set up. So he was setting this up and he was running it on airplanes, and he was creating evil twin attacks, where an evil twin attack is where you create a wireless network like United Wi-Fi on a United Airlines flight, and then people join your network, and then you pop up and ask them for like their user ID and password to authenticate. And he was stealing all of these people's credentials and things while he was on the airplane. Now, what's interesting also about this is he's sitting on the airplane and he is doing this, and somehow the stewardess on the airplane saw the attack. Like, I think he had his Wi-Fi pineapple out next to him, right? And he's doing all this hacking shit. And like, what idiot? I mean, one, don't be an a-hole that's doing these attacks on an airplane. Like, don't do this without permission, right? I think that that's kind of the key here, is don't do this without permission. But clearly he was doing it in such a way that was so obvious that the flight attendant was like, that looks sketch. And he got arrested as soon as the plane landed. And whenever they seized his devices, there were thousands of intimate images and videos and personal credentials belonging to other people. Wow. That's nutty. So this is easy. Like, this is like dead simple to do these types of attacks, right? There are other attacks that you can do. Like I said, link local multicast name resolution and Microsoft MDNS, and then NetBIOS name service are also protocols that are really bad, right? These are broadcast protocols to try to do resolution. And if somebody has this enabled on a plane, if they have it enabled in a coffee shop, they have it enabled in any network that you're sitting on, you can intercept their password hash. And you don't need like a Wi-Fi pineapple with a bunch of antennas doing all kinds of crazy shit. It's just basically you run this on a network. The command is right there. It's responder. You give it an interface, and that's it. And when we're talking about this, I think it's really important to understand how this happens. Now, I truly do not know how this actually occurred, but I'm assuming that there was a lot of cocaine involved. And I want to give you some examples of why I think that there was cocaine involved. So let's look at Steve Ballmer. Developers, right? So here we have, this is Steve Ballmer at a Microsoft conference.
Developers.
There is no way any human being gets that jacked up on the stage for developers, and there's no way any human being is that sweaty without a tremendous amount of cocaine in their system at the exact same time, right? So I think that that is a little bit of proof, but some people are like, that's one isolated case of Steve Ballmer. Like, the whole Microsoft community couldn't have been on cocaine at the same time. But I'm going to give you this one as well. let's do Bill Gates on a desk, right? Right here. If you're looking closely at this picture, like there's no way that man isn't jacked up. Like if you look in the background, it looks like that's snow. That's not snow. That's just cocaine on the Microsoft complex. And there's a lot of cocaine. So whenever I'm talking about how this happened with link local multicast name resolution, I want you to understand no sane, non-chemically modified individual ever comes up with an idea like link local multicast name resolution without being under the influence of altered substances. So what I think happened, and I don't know for sure, but some variation of this had to happen, is there was a bunch of Microsoft executives sitting around just doing like rail after rail. And one of them freaked out and said, what happens if DNS goes down? Right? What happens if there's no domain name services and we can't resolve IP addresses and people are trying to go to Bing and they can't go to Bing because we can't resolve Bing? What do we do? Everyone freaks out, right? Like they're starting fires in the conference room. You got people like making out, making love in the corners because it's the end times, folks. People are like, they're trying to get what they can get out of life in the last few moments with the internet being destroyed because DNS might go down. And finally, one of these Microsoft developers comes up with this idea. And he comes up with the idea of what if we created a new protocol? What if instead of DNS, what if we had a protocol that your computer system will send a packet out to every other computer on the network trying to do name resolution? So if somebody's trying to go to google.com and they mistype it, your system can't resolve it because there's too many O's in google.com. They can't resolve it. So instead, they're going to ask all of the other systems on the exact same network, does anybody know where google.com is? Somebody said, okay, that's a great idea. Do we need to have security? The guy's like, F it. We don't need any security at all. It's just going to accept any response whatsoever, and it's just going to go with it, man. And that's how link local multicast name resolution was born. And that's terrifying in and of itself. And that's one mistake, right? One of the problems about being a drug addict is you don't just make mistakes, you repeat mistakes again and again and again. A number of years later, somebody said, what happens if DNS goes down and link local multicast name resolution goes down too? Then they developed, I'm not kidding, NetBIOS name services. They created that one as well. And then you had the people over at Cupertino, those people at Apple, those people wearing the turtlenecks and wearing Birkenstocks, those hippie computer people, right? Like Wozniak. They're like, you know what? We got to compete with this. So they created something called MDNS, right? Now, MDNS is still used today on all of your phones. Whether an Android phone, you'll see it on Windows systems, it's using MDNS to do that. So this huge problem of just asking the network for, not authentication, but asking like how to get to certain systems exists in multiple different ways. And if you're sniffing on a network with full, complete authorization and permission to do the sniffing on that network, always with permission, written preferably, you're going to see these protocols show up. Again and again and again, you're going to see these protocols show up. Now, what's interesting about this when we intercept these hashes is there's a bunch of different services like HTTP, HTTPS, SMB, Kerberos, SQL, FTP, IMAP, POP3, SMTP, DNS. All of these different services exist with Responder so it can intercept those user IDs, those passwords, and those password hashes. But wait, there's more. You notice that one of these is off by default? Let me zoom in. Although I forget that Zoom doesn't actually work on Zoom. Do you see this one called WPAD? WPAD is off by default. Now, Laurent, when he created this tool, by default, it disables WPAD. Now, why would Laurent disable WPAD by default? I don't know how many of you know what WPAD is. It's kind of crazy. I'm going to get to that here in a second. It's disabled by default because it works too well. No, it's not WordPress. Good guess, though. It stands for Web Proxy Auto Detection. Web Proxy Auto Detection. Here's how it works. When your system's trying to surf to the internet, your computer will literally try to look up a computer with the name WPAD. It'll try to find a computer with the name WPAD on your network, because it expects to go to that computer system to automatically get its PAC file, which is a proxy auto config file. And the auto-config file is the file that allows you and tells your browser how to get to the internet if you're using some type of proxy to filter that traffic. See, when people were establishing proxies to filter the traffic for people going to the internet, trying to stop them from going to like porn websites or gambling websites or I don't know, social media like Facebook or whatever, they would create these proxies. And they wanted an easy way to deploy proxies in environments so you didn't have to go and visit every single system. So the systems that are out there, they created a service that would automatically look for a computer system with the name WPAD. That's it. No security whatsoever. Just go to a computer. Is there anybody on the network called WPAD? Yep. Are you my mommy? And it would come right to you and expect a PAC file. This is disabled because it's so effective that we have seen this bring a network of 100,000 systems to its knees. And the reason why is as soon as you name a computer WPAD, all 100,000 systems that go to the internet will hit your same computer, your attacker computer, trying to get a proxy auto-config file. It'll crash the network because it'll overload the one computer system and it'll seize all network traffic just by naming your computer system WPAD. So this is off by default because it works so well, it crashes networks. Like, how crazy is that? This gets into the category of something that we talk about quite a bit called forever days. And I didn't coin the term. A reporter that I talked with and did an interview with, I think she was from the New York Times when I was in San Francisco. She coined this term. And she's talking about vulnerabilities that just never get fixed. And this is one of those vulnerabilities that never gets fixed. So Tinfoil Hat is saying, how is this ever still a thing? It's not just it, right? Like WPAD is still a thing. LLMNR is still a thing. NetBIOS name service is still a thing. MDNS is still a thing. And if somebody was evil, like if I was evil, which I try not to be as much as I can, I really do. Even though there's a lot of times in this field where you're like, being evil seems to pay really well. I maybe a little evil? No, we're not going to do evil. But if I was an evil attacker, which I'm totally not, which would be totally illegal and you're not going to do this. But if you were, and you were hypothetically going to launch an attack, you have two ways. Either you have a whole bunch of antennas out of your backpack, you have a Wi-Fi pineapple and setting that all up and trying to set up authentication portals and doing all of this stuff, which once again, incredibly illegal. Don't do that thing ever. It's very, very illegal to do that. That guy who got arrested, he's going to spend 7 years in prison. But if somebody wanted to do that and not get caught, you could do this instead. And it works very, very, very well on many of the networks that I have done this, that I have full legal authorization and pen testing approval forms to be able to do. It works really, really well. Then I can get those sweet, sweet password hashes from all of those systems. Now, if we're running these attacks against organizations, we can do it in a number of different ways. We can also, as I mentioned, if I'm attacking Microsoft, Microsoft is going to absolutely shut me down and block my IP address. So if I'm trying to do a password spraying attack here from Costa Rica, I'm in Samara, right? Which, by the way, I have like full fiber optic here. It's crazy. I have better internet here in Costa Rica than I do at home in the United States. It's also funny because it's full fiber optics to the house. And we were talking about this at breakfast this morning. It's like tunneled to my house through a garden hose that's buried 4 inches deep. I don't know. It's a great country. But instead of me launching my attack directly from Costa Rica, which Microsoft would totally shut me down, we got to think of Godzilla, right? If you think of Godzilla movies, right? Like if you have Mecha Godzilla that shows up, or Kong and Godzilla. I don't know if you remember. I love these movies. I love the movies with like Godzilla, Mecha Godzilla, MITRE, all of these things. And I love them for two reasons. One, because you see these huge monsters smash each other, which I think is great. But you also have like people that are critics, like criticizing the movies, like, yes, I don't believe I like the pacing and the artistic design. It's a movie about giant lizards beating each other just over the heads with like apartment complexes. You can't beat that. It's what's on the tin and it delivers, right? But if you remember in these movies, If you have Mecha Godzilla, you get Godzilla and King Kong to team up to take down Mecha Godzilla, right? You can do that with Microsoft. If you're trying to attack Microsoft, we can use Amazon to launch the attack instead, because Amazon has things like Lambda, where you can create functions that you can use the IP address space of Amazon to launch the attack against Microsoft. And Amazon and Microsoft have rules where they will not deny list each other, because if they did, they would shut down core services that other people are using on top of these exact same IP address ranges as well. By the way, if you want to read a great book, Kaiju Preservation Society by John Scalzi is a fantastic book. He is the author of Old Man's War, another great book, and Red Shirts, which is also a good book as well. So people will put that up in chat. Now, if we're trying to bypass two-factor authentication, we can use tools like EvilJinx that allows us to create an evil portal that we can trick someone to come to and enter their user ID, their password, and their two-factor authentication token. And it can intercept the user ID, the password, the two-factor authentication token so that an attacker can actually use it. So yes, there are bypass techniques for these things as well. Now, Brian has been mentioning multiple times in the class, and he's 100% right, password managers, right? Are you going to use Secret Server? Are you going to use LastPass? Are you going to use OneLogin? There's a bunch of them that are out there. You should absolutely be using password managers because it allows you to use different passwords for different sites and autofill it within your browser as well. Now, the other thing that many organizations have is privileged identity management. And this gets into kind of some weird stuff. Let me go here. Okay, so we're going to come to this one. All right, so what these companies do is they allow you to automate the randomization of sensitive passwords, right? So if you're looking at BeyondTrust, CyberArk, Centrify, Microsoft LAPS, local administrator password solution, it'll randomize the local administrator passwords for LAPS or other sensitive passwords that you have in your organization. And if you want to gain access to a computer, it can grant you a temporary password for a short specified period of time, and then it'll kick you off. And these are awesome, right? These are great. And then, of course, one of our YouTube people, by the way, welcome YouTube people. We have Loki. Ooh, am I getting that right? I'm missing that. I'm wondering if that hex is spelled out there, but we got Loki. I'm just going to go look. Fantastic point until the password manager gets hacked. And BeyondTrust was one of those companies that got popped. This was a state level attack that was earlier this year where they were attacked and the attackers were able to gain access to U.S. Treasury Department systems. Now they're like, oh, it's unclassified data. It's fine. It's fine. It's unclassified data. It's just financial predictions, what the United States Department of Treasury is going to do. I'm sure nothing sensitive happens at the United States Department of Treasury. But they were able to then hack that system and gain access to a bunch of those sensitive accounts. This is absolutely terrifying. Pretty sure that China was behind this particular attack, which is frightening. But it shows that, yes, even sometimes these particular systems can be compromised as well. But let's have a conversation about this, right? Because this is important. A number of people will look at these things and they will say, well, I don't want to use these cloud services because I don't trust them, right? I don't trust BeyondTrust or Centrify or, whatever you're using for any of these different things, right? But I want you to look at the narrative, right? If you look at the narrative here, the narrative isn't that the United States Department of Treasury had weak cybersecurity. The narrative is they were a victim because BeyondTrust was compromised. And I think that narrative is really important. When I first moved all of our email from BHIS to Google, long time ago, there was a number of people that were kind of poo-pooing that idea and saying, well, you're using Google, it's just somebody else's computer. But I kept coming back to the narrative matters, right? The narrative matters. Because if I'm running my own email server and I'm doing all of the stuff myself and I get compromised, that's 100% on me. If I move my email to Google, if you move it to Microsoft, and there's a vulnerability that exists in Microsoft and Google and BeyondTrust, then I am another victim. of the vulnerability that this particular cloud provider introduced. And I think that that narrative is key whenever you're looking at these different things. If you're ever like, you know what, I'm going to do this on my own because I do not trust Google or Microsoft, it's time to lay down on the floor and let that urge pass. Because once again, the liability will be 100% on you if something bad happens, if you're building it. If you can pass that liability onto one of these services, that's actually a pretty good thing, all told. So now we have a lab. We've already did the password spraying lab, but now we're going to get into password cracking. So let's go ahead and let's talk through this lab. So I'm going to go all the way down here. Let's go back to the lab directory. All right. And I still have my passwords here because I'm going to show you how it doesn't matter how Microsoft is storing their passwords. They're using clear text authentication. So we'll get to that here in a second at the end of the next lab because we're going to do password crack-a-lackin'. All right. So in this, we're going to disable our AV. Once again, we're going to open up a Kali terminal. We're going to become root, and then we're going to remove the hashcat pot file. The hashcat pot file is where hashcat stores previously cracked passwords. So we're going to get rid of that because if you do this lab multiple times, it'll be like, it worked the first time and it didn't work again. Hashcat will not crack a password it has already cracked before. So we're deleting its memory of the previously cracked passwords. We're going to cd into the directory opt password cracking. Oh, you like the crack thing? Well, here's a joke. You know, I've done this at universities and I have people that like laughs. It's like, so what you do, man, is you take your hash and you put it in the pot file. Yeah. So that's actually, it goes all the way back to John the Ripper and Solar Designer from a long time ago. If you take the hash and you put it in that's the joke. There you go. Once again, we're IT geeks. Seriously. We don't have good social skills. All right. So we've got this pot file. We're going to remove it. Now we're going to crack it. All right. So here we got hashcat, and I'm going to share with you a cheat sheet here. We can do. And here we go. Here's a hashcat cheat sheet. So if you want to know what those different hash values look like and what things mean, and I'll walk through it when we get done with the lab and what we're actually doing here. But we're going to be going through single crack mode. We're going to be doing a leet speak rule that does the camel case and the hacker case substitutions. And we're going to try to crack the passwords that are in MD5.txt. Now, MD5 is a common hashing algorithm that is used by a number of different web servers to store password hashes. And it's just a straight MD5 hash. If we go to CyberChef, you have a number of different things from Hex, from base64. Do they have, I don't think they have one here for, no, they don't have MD5 hashing. But there's a number of different MD5 hashing utilities that are out there, but it's just a straight MD5 hash of the string. So it's not complicated at all. There's no salts that are being used. I'll talk about what a salt or a nonce is here in just a little bit, but we're going to crack the passwords and we're going to give it a dictionary file of password.lst. So it's going to go and it's going to run and it's going to crack all these password hashes. We're going to have peanuts, tiger, swordfish, thrasher, love 123, and cross country. Then we're going to crack a different password hash representation format called the SAM file. Now, in Windows, there's two different types of password representation formats that are used. The first one is DES. It's using a DES key. It's used in Landman. So it basically takes your password, uses it as a key to encrypt the string KGS exclamation point @ symbol pound prompt $, which just so happens to be the initials of the person that wrote this algorithm. And that was actually his password that he was hashing, which is weird. Super easy to crack Landman password hashes because it converts them to uppercase, splits them to 2 7-character strings. Bad. Microsoft generally doesn't use those anymore. Most of what it's using is the next version, which is an NT password hash, which is a straight MD4 hash of the password. So it's marginally better. We still aren't using any type of nonce or salt for that. So we're going to crack these Windows password hashes. And you're able to see those. We have freedom 8675309. That's a good password. Password, Fender, and Rabbit1. All right. So this is straight up password cracking. Very easy to do. We're only going to put like 20 minutes on the clock for this one. And then I will do the walkthrough on this. And then I'm going to demonstrate how none of this really matters. Like, we're talking about Quaint, right? Nothing really matters anyway at all because Microsoft uses clear text authentication. And I'll prove it when we get back using the power of Metasploit. So let's go ahead and let's set 20 minutes on the clock. And then I'll do a quick walkthrough and then we'll take a break. All right, so let's get rolling. See you on the other side, everybody. Sorry, I'm a little late, y'all. I'm talking with Doc. Doc Blackburn's going to be in the house. He's going to be taking over for me. Because like I said, I have some family stuff going on. Someone cut my garden hose for the internet service. No, it was just kind of coordinating some stuff with Doc. He's going to be coming in hot. He's got a meeting and he's coming in about 10 minutes before class starts. So once again, he'll be covering like the last hour. I don't know if Zach is still on. Zach. I don't know. Maybe we can get Zach to be here with Doc.
I think he's backstage.
Yeah. Do you just want to ask Zach if he's up to doing if he's doing a
Ask me anything.
Ask me anything? Because that would be cool.
Okay. I'll make sure he does.
And that makes it easier for Doc to kind of come in for like an hour and just do the ask me anything at that point with Zach. It'd be cool to get, it'd be cool. I wish I could be here because I could see their differing views of things because they're both like super awesome. Two completely different career paths. And it should everything's sorted. Everything's fine, Jelly Beanster. It's just I had the collision of my work calendar, this class, and then the personal calendar of doing a dinner cruise with my wife's family. So, and I don't get to see a lot of family. Like Eric and I travel all the time, and we don't get to spend as much time as we'd like with our family. So I wanted to make sure everything's fine with the family. It's just I want to spend time with them. No, so Doc is going to cover for me on that is all. All right, so let's go ahead and let's get rolling through this. So as I said, we're going to crack passwords, right? So I have my VM up here. I'm just going to leave that for a second. We're going to come back to those password hashes in just 2 shakes of a lamb's tail. I'm going to go ahead and open up a Kali instance, and we're going to change the settings. I'm going to go ahead and make the appearance. Let's go ahead and change the font. Let's go to bold, crisp, cool, refreshing, like the mountain streams of the Colorado mountains. All right, so there we go. We got that set up. I'm going to disable my AV, which, just the whole reason for doing that is because it just gets in the way of the labs. And once again, the goal of the lab isn't bypassing AV. I'm going to become Rita on this system. Then we are going to delete that pot file that we talked about. All right, there we go. And then we're going to CD into the password crack-a-lackin' directory. And then we're going to crack some passwords. Crack that password. All right. So we're going to do single crack mode, which is just a straight dictionary attack. We're giving it a rules file where it does leak speak substitution. But I also have like, what is the mode or what is it actually cracking with the type of hash that we're cracking. So we have this really cool cheat sheet that we've created, and you have the M type right here. You can see, that's right. God damn it. Zoom doesn't work, but Zoom does work inside of that. Oh, look at that. Beautiful Zoom. So whenever we specify 0, we're cracking the hash type MD5. Which is exactly what we are doing here, right? So we're going to crack an MD5 password hash file, and we've got the hash file is md5.txt, and we're going to use the existing dictionary file of password.lst. So now it's going to fire up. Now, we had to trick Hashcat, and just so you know, the way Hashcat works and the reason why it is like the preferred password cracking utility is because it uses something called floating point arithmetic. What the hell is that? That sounds like something someone would say to sound smart. So I want you to think of video games way back in the day. We'll come back to the password cracking here in a couple of seconds now that it's done. So my favorite game of all time is MechWarrior. Actually, it's not true. It's Might and Magic 3. But MechWarrior 1 was like the first video game that I just absolutely fell in love with. And MechWarrior 1 had this type of graphics. And it was like one of the first games that had kind of 3-dimension graphics and things like that. But the problem with computers back then and with the way that video games were rendered is your CPU was doing absolutely everything, right? So the CPU was running the game mechanics, it was running the whole visualization and the graphics of what you were seeing in the video game as well. And this was a big deal when this first came out, right? Because we had these types of graphics that you could actually see. Now, what happened with this is you hit a wall, right? With how much your graphical, what your computer could do from a graphics perspective was completely limited by the fact that you had one CPU, right? When we look at the graphics of MechWarrior 2, the graphics of MechWarrior 2 were a lot better. They were taking advantage of Intel-based CPUs at this particular point, and that was a big deal. But it was we hit a wall, basically. So when you get into like ATI and Voodoo Express cards and things like that a long time ago, they realized that there was something that they could do with graphical processing that allowed you to do graphical processing at a much greater scale than one fast CPU on your computer system. So if you look at a graphics card, whether that graphics card is in your computer or graphics, video processing on your phone or anything, they have enabled multiple little tiny CPUs, right? And they call them graphical processing units, right? Now, what that does is it takes the math that's being done and the calculations, and it spreads it across thousands of little tiny baby CPUs, and it does that mathematics and massive parallelism, right? And if you're looking at this, like what allowed us to go from a video game that looked like this to like a modern video game. If we look at like Crisis, right, which is, I know Crisis is a bit old, but if you look at like what's going on with Crisis, is there's multiple graphical processing units that are working in parallel with each other to do the exact same mathematical algorithms again and again and again. So if you're looking at like water, the way water ripples go, that's the same mathematical algorithm and massive parallelism. If you look at like the way wind goes through grass or hair in a video game, that's massive parallelism. So what Hashcat does is it takes advantage of multiple GPUs doing the exact same thing for like video games, and it applies it to password cracking. So what it does is it takes the hashing algorithm in this particular situation, MD5, and it massively parallelizes it across all of the GPUs. So they're all now working together to try to crack the password hashes. So we're running this in the cloud, which doesn't have a GPU. So I had to fake Hashcat out into thinking it has a GPU. To do that, I had to use like the OpenCL drivers from Intel, but that's a whole nother conversation. But here you can see it was able to crack these passwords of Peanuts, Tiger, Swordfish, Thrasher, Love 123, and Cross Country, right? Now that's MD5. If we go back to this monster cheat sheet, right, there is a lot of different password hashing algorithms and password representation formats that exist out there. And all of these are represented by a number. Whereas MD5 was a 0, right? We have other numbers that represent the password hashes that are used by Windows operating systems. So you're looking at Landman would be 3000 and NTLM would be 1000. So if we go back here and we want to crack some of those passwords, we absolutely can. We can go ahead and put in the password list, which is from sam.txt from a Windows system, Security Accounts Manager, and we're going to give it the M1000. So we'll put in that. Takes a few seconds for it to run. And there we go. It got freedom, blank, 8675309, password, Fender, and Rabbit1. So I was able to crack those particular passwords relatively quickly from that dictionary list that we have. But I want to go a little bit further, right? Let's go ahead and let's take it up a notch. All right. So what we're going to do is, let's say that a password is not crackable, right? Whenever we were setting passwords a little bit earlier, we had in some of the previous, thank you so much. In some of the previous labs, we actually changed the administrator password. So if we go back to AppLocker, we changed the password to something lame. The password is password 123. What happens if I change that password to something that would never be cracked? And by the way, if you look here, the administrator password hash, this AAD3B4 is the landman password hash, the 08B858277, that is the NT password hash. So let's change that to something that's not cracked. Okay, that's a sufficiently long password, right? I'm just going to change that password to something ridiculously long that would never be cracked till the heat death of the universe. By the way, the heat death of the universe is a really long time. It's crazy, right? So Now, if I dump the password hashes off of this computer system, I want you to see that that administrator password hash changes. All right. So let me go back all the way up to the top right here. And you can now see that the administrator password is right here. And now it's changed to CF2E4AB2C, whatever, right? So what we're going to do is I'm going to show you how all authentication in Windows is clear text authentication. So I'm going to take this password and I am going to, did not want to do that. Let me go ahead and close this session. Let's do exit -Y. And now we're going to set the SMB user to be administrator. All right. And then I'm going to set that SMB password to be the password hash, the landman and the NT password hash for the administrator account. And then I'm going to exploit. So I don't even need to know what the password is. I can just use that password hash without ever cracking that password hash to authenticate to a Windows computer system. And the reason why, like I said, is when Microsoft is doing an authentication verification on the system that you're authenticating to, it stores that password hash. Okay, so it stores that password hash. And then when you try to authenticate to that Windows computer system, it takes the password hash that it receives and it compares it to the stored password hash. At no point does it reverse that password hash to attempt to compare it with what the actual password is. And because a lot of the authentication, if you're looking at like Landman, NTLM v2, NetNTLM v2, is doing that authentication in the clear, there's a challenge and response, but that is sent in the clear. That means that you can intercept the authentication between two Windows computer systems, and you have the ability to hold down those password hashes and do pass the hash using these techniques. How cool is that? All right. So sometimes we crack passwords, sometimes we don't. All right. So I'm going to go ahead, since we've done horrible, horrible things to the system, I'm going to go ahead and destroy the lab. I think I've been logged out of my session here. So we'll go back in. I'll log in as Strand.js, use the password. There we go. Let's go into the Cloud Labs. I'm going to view, manage the lab, and now I'm going to destroy the lab. All right, so now we've blown that lab away. We'll come back to it here in just a couple of seconds whenever we get to the next section, and we'll restart it. But it allows me to start from a clean slate, and by shutting it down at the end of each section, it also doesn't burn as many credits as it would normally on that as well. All right, so we're moving into Egress traffic analysis, another great section that is very near and dear to my heart, and we're going to treat this as a little bit of a challenge for you all using AC Hunter to solve this challenge, all right? So when we're looking at egress traffic analysis as it relates to MITRE, there's a number of different protocols that exist that we can actually utilize to be able to exfiltrate traffic out of an environment. One of the big things that we look at is the fact that there's a number of different types of encoding options that we can use to try to encode that command and control. So it isn't an issue of just like decrypting HTTPS. There's a number of ways that we can look at it further that we can hide in plain sight. We call this steganography. Stenography is court reporting. We're talking steganography. Steganography allows us to hide in plain sight. So if we're dealing with encryption and we're dealing with steganography both, it becomes incredibly difficult for anybody to detect actual signatures that are coming out of an environment. This gets us into desperately needing some type of visibility into what is going on. Basic alerting is not enough. We need context. We need to look at gaps in endpoint security coverage. We're looking at things like Internet of Things. We're looking at a number of different things like shadow access. Oops. Crap. We're looking at a number of different ways that attackers have the ability to hide on our network in plain sight, even if we're decrypting SSL TLS traffic, to be able to view into what's going on. This is one of those weird areas where Gartner and I actually agree. Not a huge fan of Gartner, probably not going to be a Gartner rep anytime soon. But the problem I have with Gartner is a lot of the Gartner ecosystem is very much pay to play, even though they're like, that's not how it works at all. Whenever you're a vendor, you do have to pay money to get evaluated by the Gartner analysts. And the more Gartner analysts you get your product in front of, the more you have the ability to get higher up in the magic quadrant of Gartner in what you do. So even though it's not technically like pay us money and we'll give you better reviews, it's kind of what happens. Also, I've seen a number of presentations by Gartner analysts, and I'm like, this person isn't working in computer security like at all. They have a doctorate. That's good. But here's one area where we do agree. Completely simpatico. Gartner and I are like this, folks, not like this. We're like this. They say that to have a good, solid security architecture, you need to have endpoint security products like your EDR. And you also have to have it coupled with network detection and response utilities as well. So agree, hard agree on that, because we need to have that type of visibility into what's going on in our environment. So we have a number of different protocols that we can use to try to understand and evaluate what is actually happening on a network, right? We can do things like net flow analysis, right? We can look at the traffic analysis utilizing a protocol that Cisco has created that is a collection of statistics about the data that is being transferred across the wire. So we can get analysis on like when a session started, when a session closed, how much data was sent in that particular session. A lot of cool things come from net flow. And it quickly became a standard, because Cisco is freaking everywhere, right? Generally, they look at it as an exporter, the device that's getting that network traffic. An importer would be like a SIEM or some type of logging and analysis system. And then you would have an analysis engine, which also could be a SIEM or like, let's say, UEBA or, I don't know, like AI, possibly doing analysis on it as well. Now, one of the problems with NetFlow has nothing to do with NetFlow. It just has the fact that it was created by Cisco. And a number of vendors basically were like, well, we're not going to use a Cisco standard. We're going to come up with our own. So we start spawning off like JFlow and SFlow and all these other different flows for different vendors, which sucks, right? Because I think that there's an XKCD comic out there about standards and how people are like, well, we're going to create a brand new standard that unifies all of the other edge cases. And now there's 47 standards instead of 46 standards. It's very, very common to see this out there. Also, even within Cisco itself, it seems like a lot of teams that are working on different products implemented the NetFlow standard different from each other, which I find strange because NetFlow should be NetFlow, right? Maybe. All right. So the one that we're going to focus on is Zeek. This is currently being maintained by Corelight, which is a commercial product that is pretty fantastic. It's expensive, pretty cool, and pretty fantastic, all told. It's really, really fast, has a huge user base, tons of support, lots of consistency in the way it's actually logging things like connections, HTTPS data, and DNS data as well. And many of the different products out there that handle timestamps differently, we don't care because Zeek's handling it all on the wire for us. We're moving away from the concept of that signature-based detection. There's too many ways to obfuscate what's going on with all kinds of encryption and encoding and third-party services like Google DNS, which is going to bring us to an intermediary lab. So I'm going to start up my lab here. I'm going to get that running. And I want to spend a bit of time kind of showing you the problem statement, right? So let's go into, which one do I want to do? Let's go ahead and do just a simple advanced C2 PCAP analysis lab. This lab is going to take us just a few minutes to do. We're going to go ahead and we're going to look at a covert channel that is hiding in clear text and HTTP. And as we're going through this lab, I want you to spend some time thinking about how in the hell would you detect this? We're going to go through that. So you're going to go into the opt covert directory and you use TCP dump. You're not going to resolve any names. You're going to look at the ASCII and you're going to read in the file covert C2.pcap. I'm going to pipe it through less. Now you're going to see the traffic and you're going to be looking for anything with the __ view state parameter within it. That is where the traffic is hiding. When we get back and I do a walkthrough of this lab, I'll explain why __ view state was used in this particular scenario. Then you're going to close out that TCP dump session. And then we're going to look at the beaconing associated with it by looking at the SYN flags, by looking at the TCP offset and the header, the 13th byte offset with a value of 2. I'm going to pipe that through less as well. So we're going to go through, we're going to see all those sin flags as well. Then we're going to grep out all the hidden form elements, and you're going to be able to see that command and control traffic that's being put inside of the underscore view state parameter. Now, one of the challenges that you can do is try to solve what is that base 64 encoded data. What is in there? A couple of ways you can do it. I did a simple little Python script. You might be able to use something like CyberChef. So this particular lab is only going to take us like 10 minutes to get through it. If you want to use CyberChef, that's pretty fast. And then I'm going to go through it. I'm going to walk through it. And then we're going to talk about how we deal with this, because there's so many ways for attackers to hide and obfuscate their traffic. So let's set the clock for 10 minutes, and I'll be right back. I don't think I'm getting the clock. Oh, here it comes. Oh, it's down. Here we go. 10 minutes and go. Right. So let's go through this really quickly, just because I think it really sets the stage, excuse me, for what we're dealing with here. So we're going to start out in our Kali terminal. Let me connect in. We're going to start in our Kali terminal because like we're going to be doing some basic packet analysis, and I like running it from the command line on Linux much more than Windows. Not because I'm an operating system elitist. I think more just from the perspective that's what I'm comfortable with, which I think is kind of important. All right, so let's go ahead and let's open up Kali. Go through. We're going to accept that. Go ahead and make this bigger. There we go. Now we should be able to see what's going on. Find helpful. And we're going to CD into the opt covert directory. And then we're going to do some basic analysis. Now, we call this an advanced C2. I probably need to rename it because it's not all that advanced, right? Especially now. But it works, I guess, to bypass a lot of different products that are out there, right? So these are the individual packets that are going back and forth. And right here, you can see this __ view state parameter. That right there is our beacon. That's where the actual command and control is. And it's just beaconing that again and again and again. Now, the reason why we use the __ view state parameter is because that parameter is used for session state for ASP web applications. And that particular parameter is variable in the content and it's variable in length. So that means that under normal circumstances, you would expect that view state parameter to be changing constantly in the content and the size of that particular parameter. So trying to write a signature to detect any type of changes inside of that view state parameter would be very, very difficult to do effectively, right? So if we want to look at some more of the things, I'm going to skip over that one. Let's go to the hidden form fields so I can show you what the C2 traffic looks like. And in here, I'm going to say, here's the beacon. So EYJ is the beacon, these short ones that end in like, what is it? These little ones. These little ones are the beacon. And then this is data that's actually being sent right here, this big long blob right here. That is the data that's actually being sent. And I can take that data, right? And I can copy it and I can go over to CyberChef and I can paste it in. There we go. And then I can take that from base 64. Oh, wrong one. Let's go to, from base 64. There we go. And then this is the actual decoded message, all right? It can say commands, the channel ID is 6, the command is cmd.exe, channelized, PowerShell command, new object, web client, download string, this Google link, invoke shellcode, Windows interpreter, reverse TCP, lhost is the connection, the port is 443, and then we got a 30-second interval, which matches those TCP SYN packets that we were looking at. So really, really kind of cool. But as I said, I call it an advanced C2, but it's not that advanced, right? It's not using HTTPS. It could be. It's not using encryption on top of the base 64. It could be. And this is just kind of set up from an articulation perspective of how we can set this up in a lab to set the stage for the problem. And the problem is, how in the hell would you detect something like this? That's leaving your environment. Even this, with no encryption, there's no encryption here, it's just encoding, would be incredibly difficult for the vast majority of organizations out there to be able to detect this command and control. So we get into a problem. And that problem is really, how do you detect that type of backdoor? Now, part of the solution is up above where we're looking at the TCP SYN packets, which is offset 13 in the TCP header. And you can see our beacons are roughly 30 seconds apart, which matches what we saw from CyberChef, that the interval is 30. Okay. So let's say the attacker is smarter than that, right? Let's say that the attacker is smarter than actually sending that data more or less kind of sent through clear text. Say that they're using some type of encryption. They're using HTTPS. They're using encoding and encryption on top of each other. You know, they're making it a lot more difficult for us to be able to detect that. How do we go about looking at detecting that? And that gets into hunt teaming, or like threat hunting. This means that we're actively looking for advanced adversaries, right? You've probably been compromised at some point. And I'll talk about compromise is kind of a wishy-washy thing, right? Like whenever we say someone has been compromised, what exactly does that mean? And we'll get into that in more details here in just a couple of minutes. But the point is, if we can bypass like if we can bypass IDS, IPS, AV, and those things, then the attacker probably can too. And what I mean by that is any of these different types of like pen testing companies we can bypass these products, and advanced nation state level adversaries have that capability. So some type of intelligent analysis of the data sources becomes absolutely imperative for us to be able to detect these types of attacks out there as much as possible that we can deal with, right? So what does that leave us? Because we don't have the ability to actually, I guess, we don't have the ability to do this, to be able to look at the actual data itself. How do we deal with it then? Well, we can start doing some analysis, and we can start doing that frequency analysis to start trying to identify patterns in network traffic. Specifically, we want to look for the beaconing traffic that's leaving the environment. So if I can't decode it and I can't take apart that traffic, can I look at the behavioral patterns of that traffic to make some determination of, human, not human traffic? It's kind of like you want to write an algorithm that looks for hot dogs, right? Hot dog, not hot dogged. Human, not human. Can we do that? We might be able to sprinkle in some things like denylists checking, DNS view, long connections, and we can do all of this for free utilizing Rita, right? Rita stands for Real Intelligence Threat Analytics, and its sole purpose in life is doing beaconing analysis to try to identify those beaconing connections. And spend a couple of minutes and let's break down what this actually means. Okay, let's get into artificial intelligence a little bit. Even though it pains me to talk about artificial intelligence for a number of reasons. And I think one of the biggest reasons why it pains me to talk about artificial intelligence is whenever I talk about it, I think everybody has a completely different concept in their head of what AI actually is, machine learning algorithms and all those expert systems. So we're going to break it down into a couple of different things, right? We're going to break it down. Let's go back to Plato, right? I haven't done the Plato thing in a long time. So how do I know a chair is a chair? Like, what makes up chairness? What's the context associated with that? Like, I have a chair. How do I know it's a chair? Got several people typing. It's stable, hopefully, right? Oh my God. Silicon Valley, the chair in the back of the pants. Oh my God. Has 4 legs and it doesn't walk away, but a chair could have 3 legs, right? A chair could have 6. So this shape is known as a chair. They're getting on it, Chad. What do you mean shape? Stool? Is a stool a chair? If bushes were trees, then trees would be falling, right? You can sit. Dude, that chair that guy had in his pants has 2 legs. Or no legs. Some chairs don't have legs, Sophia. We have beanbags. Those are kind of a beanbag chair. Mama, if I fits, it sits, right? There we go. All right. So let's talk about this and let's kind of break down the concepts of chairness. I want you to break down what are the components of a chair. And you guys mentioned 4 legs. That's valid. 100% valid that it has 4 legs, right? Maybe a back. Some chairs have backs. That's chairness, right? You can sit on it. It's a seat. That's chairness, right? It's a surface to sit on, but a countertop is not a chair, right? So when we're doing this, we're taking up the characteristics. And as a human being, you're evaluating all of the characteristics. You're weighting all of those characteristics. And you're making a determination based on the weighting distribution of the characteristics that are presented to you about the chairness attributes of them. Yeah, socially constructed term, absolutely, right? I think that's a big part of it. And we're slaves to that social construct that has been developed for us. All right? Okay? So chairness, not necessarily, mama. There's absolutely some subjective things, right? Like, let's take a look at Let's take a look at money, right? Like I love people whenever they're talking about Bitcoin. They talk about Bitcoin and they're like, Bitcoin is evil. Okay, so that's the statement, right? Bitcoin is evil. Why is Bitcoin evil? Bitcoin is not anything. It's not valued in anything whatsoever. Bitcoin is used by criminals, right? You literally just described the monetary system that exists today, right? It's not really based on anything. We're decoupled from the gold standard, right? And it's used for crime, right? But you start developing these concepts of things, and as human beings, the context matters. All right. As human beings, the context matters. So you create a weighted distribution of the different concepts of what a chair can include. And when you look at something, you see how many of those attributes exist and at what level they're Greeks. Plato was trying to understand how human beings come to the understanding that a thing is a thing, epistemological analysis. And it turns out Plato was a computer scientist. He really was. It also turns out that Plato was a computer scientist that was really trying to understand what intelligence was. One of the first computer scientists dealing with artificial intelligence, even though he didn't even know that he was doing it, but he was. Now, Plato believed that we were all, and he was using analogies, right? Like analogies are a very effective tool, right? He was using the analogy of the cave, right? Human beings are all sitting in the cave, and what we see as reality is merely shadows of perfect forms, right? So somewhere in the universe, there is a perfect chair. And that perfect chair is represented by all of the chairs that you see, but none of which are perfect chairs. And as human beings, we're seeing but shadows of what a perfect chair actually is. Deep, right? Deep. Let's apply this concept to a beacon. Let's apply this concept to command and control detection. Turns out it's actually easier to understand whenever we try to think of it in terms of the inverted flux capacitor that you see on your screen now. So I'm going to give you 3 attributes of beaconness, right? Like, let's say I want to look at a beacon and I want to detect a beacon in an environment to detect non-human traffic. These are just 3 attributes. There's multiple attributes that we can utilize. I'm going to show you 3. All right. Now, as we get closer to perfection in interval, as we get closer to perfection in connection time, as we get closer to perfection in data size, it clusters closer and closer and closer to the perfect, which would be a 1, which we would represent at the center. The further you get away from the center, the less perfect an interval is, the less perfect a data size is, and the less consistent or perfect connection time is as well. Okay. So when we're trying to identify a beacon on a computer system, a non-human beacon, we can run some analysis to look for the beaconness of us staring at the cave wall of that connection: interval, data size, connection time. Just 3 things that I'm going to talk about. We have others that we can do as well. And when we're thinking about a beacon from a computer system, I also want you to think about it as like, what was it, Wolf of Wall Street? A couple of analogies in your heads, you know, right? That's a beacon, right? Another beacon, if you've ever been around children, which I just flew into Costa Rica again, and there was lots and lots of children. By the way, screaming children on airplanes don't bother me because the screams of children don't bother me. No, I'm joking. Screaming children don't bother me because they're not my kids. It doesn't bother me. I've flown with children. I know how those parents feel. And I know a lot of times it's not fixable, right? Doesn't bother me at all. But I want you to think of the kids that have a conversation with their parents like this: mom, 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 mom. That's a beacon. It's a beacon. It has a good interval. Mom, 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 mom. Has a data size, MOM, MOM, or dad, 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 dad. Very consistent data size. And its connection time is very, very consistent as well. That would be a beacon. So the more perfect a beacon gets, the closer it gets to center, which we'd represent mathematically with a value of 1. So we'd evaluate connection profiles on interval, data size, and connection time. And in doing that, we would evaluate them looking for clusters. This is important because it doesn't have to be a perfect interval to be a beacon. It doesn't have to be perfect in data size to be a beacon. It doesn't have to be perfect with connection time to be a beacon. We're looking for clusters because you're always going to have and introduce a little bit of variance in interval, a little bit of variance in data size, and a little bit of variance in connection time. So we're looking for those connections. We can do that with network traffic analysis utilizing tools like Rita. So the other thing we can do is we can look at long connections. So I want you to imagine a string of spaghetti, mom's spaghetti, because there's vomit on a sweater already. We have this long string of spaghetti. It's uncooked, hard spaghetti, right? If I break that spaghetti uncooked, it's going to shatter into a variety of different sizes of pieces. We're going to have very, very, very small pieces. We're going to have some long pieces, some medium-sized pieces, but there's going to be very little consistency. That's what happens whenever you have an attacker that's trying to be a little bit crafty with their beacons. Instead of having like a really strong frequency, it can try to get creative. But when you reassemble all of the different spaghetti strings together, it always adds up to like an entire date, 86,000 seconds, right? So we can look for that. And Rita does this. We can look at beacons. These are some beacons, number of beacons that you can see. On the left-hand side, you can see the score. 1 is perfect. 0.83, not perfect, but it's a pretty good beacon, right? It's a pretty good beacon. So we have 1, and then we have like another perfect beacon, but then we also have some other beacons like 838, 835, 834. Those are also pretty good beacons. But those other beacons are different. If you look at the top 2 beacons, we have 108,000 connections of a perfect beacon. We have 20,000 perfect connections of a perfect beacon. You want to start with those. There's a lot of communication going on right there. All right. Now, you're going to find things that are not malware. And when I said that your environment's going to be compromised, I didn't necessarily mean by a hacker. There's all kinds of weird stuff in an environment, if you will, going on. It's kind of a little bit freaky. That isn't evil, but it's really weird. Like, it's like, I don't know, foot fetishes. Not necessarily evil, but weird, right? Furries. Not evil, but weird, right? So you're going to find these things that are a little strange in an environment like TeamViewer. A number of people use TeamViewer to communicate with computer systems at home. So let's say, I think I have TeamViewer on this. I think I do. All right. So I've got TeamViewer. I'm going to go ahead and see if I can still connect here. Maybe we'll see. Here we go. I'm going to connect to my computer at home. All right. Well, that's not going to work. No. I must have lost power or something. But I can use TeamViewer to connect into other, it's a live demo, to other systems. It's very, very, very common for people to use TeamViewer to be able to bypass security restrictions like porn or gambling or video game restrictions on computer systems. They can absolutely do that. That is a thing that they can do to get to what they need to go to, or what they need to as well. Another one, remote desktop protocol. We've seen a number of organizations over the past few years that have been compromised via RDP because RDP was exposed to the open internet. To wit, you would ask, how many systems on the internet actually have RDP open to the internet? Good question. Quick, to the internet. All right, so we're going to go to Shodan. Show enough. Here we go. And I'm going to log into my Shodan account. And yeah, we're going to log in with the Googles. The Googles, they do nothing. We're going to do images.shodan.io. Oh my God. We have a lot of RDP systems, right? I can do desktop sessions, do Windows desktop sessions. These are all like RDP systems, and there's 439,000 RDP systems just sitting on the internet, no big whoop, just hanging out, doing their thing. We could also do, let's do port. By the way, full disclaimer, we're actually doing a live demo on the internet. But whenever I do live demos on the internet, especially whenever we're dealing with recon, it's entirely possible that some untoward things may show up, like furries or feet. It's at this particular point that I strongly recommend, if you have any children in the room, that you cover their eyes, cover their ears, and then you lock them away into a basement until they're 18 years old, because we don't want them to be exposed to anything whatsoever that may be a little bit off on the internet. But be sure, whenever you lock them in the basement, if you're going to hide them for the things that they would have in this particular class, or if you're going to hide them from books at schools, or if you're going to hide them from different music that you don't want them to hear, it's absolutely essential, and I mean this, that you give your children a cell phone, because the best thing to do whenever you're trying to protect your kids from books at school, like 1984 or The Handmaid's Tale or The Red Tent or any of those books, which are terrifying books, or if you're trying to keep them from anything else like music, like Rage Against the Machine, absolutely fantastic band, Rage Against the Machine. It is essential when you're protecting them from those things that you give them a cell phone so they can have Snapchat to be able to gain access to the internet. All right, there's my disclaimer. So I'm going to do port 5900. I'm going to go ahead and run that. Oh my God, we have 1,000 VNC systems, 1,166 systems that have VNC up and running. That's kind of a bit terrifying. And notice that some of these are absolutely like logged in. Isn't that nuts? So I can do logged in, trigger this tag. There we go. We got ICS systems that are logged in. Yeah, there's a lot of this stuff that exists on the open internet. Okay. So what do we do with this, right? Well, it turns out whether or not somebody's using VNC or they're using remote desktop protocol, there is a beacon associated with it. TeamViewer has a beacon, remote desktop protocol has a beacon. You also have individual devices like this USB to Ethernet device that is affectionately known in the universe as a land turtle that creates a beacon as well. We've actually seen land turtle type devices where people have used USB to Ethernet adapters that have built-in Linux microkernels that connect back out to the manufacturer of that microkernel so you can remotely manage these devices. Nuance, not Petya Attack, Nuance are the people behind Dragon Naturally Speaking. They have customer support utilities that allows them to remotely access your computer to troubleshoot their software. Point I'm trying to get at is there's a lot of things in your environment that may be leaving your environment or maybe backdoors that exist in your environment that are not evil per se. Once again, they're weird, but not evil. These would be things that you would want to be aware of in your environment so that you can deal with them appropriately in your environment as well. Also, Rita is free. A little bit of background on my mom. So it's named after my mother. I didn't name it after my mother. The developers did. My mom used to work at Black Hills Information Security. She was kind of like helped out with the accounting department and did a bunch of cool stuff, really helping us get launched, working with my wife very, very, very closely. And my mom would work in the Rapid City office a lot whenever I was traveling. And that's where our developers worked. And she became very close with a number of the developers of the Rita project. We didn't have the name Rita back then. And they named it after her because she kind of became a surrogate mother to a number of people. Now, if you'd like to know more about my mom was featured in Darknet Diaries episode, I think it was 67. I'm not sure. Someone will find it here in a little bit. But my mom passed away from cancer a number of years ago. And she was very much into she was working a lot, like right up until the end. And I found out some things like recently, very recently, like within the last week. Some crap didn't make any sense to me. And it all of a sudden does now because I know more about it. But my mom, when she was fighting cancer, we would go down to the Cancer Treatment Centers of America. My dad really was with her all the way up until the end. It was just amazing to deal with it because a number of us kids weren't able to be there as much as we should have been. But I remember we would go down to Cancer Treatment Centers of America and I would do presentations like this. And she would come out and she'd listen and I would be in the hallway because she would do chemo, she would sleep. My mom had this thing with chemo, right? When she was done with chemo, she would go and work out, like ride the bikes and do ellipticals and get the blood moving until she threw up. And she was like, yeah, if I do that, it flushes it from my system a lot faster. But she would sleep after the initial chemo treatments and she would come out and she would hang out with us whenever we were doing the classes or the webcasts or things like that. And we had this tool that the developers named after her. And she asked that the tool remain free. She wanted the tool to remain free to the community. And I remember you guys have probably, some of you have been on these a number of times, and something that's always baffled me that I finally realized what actually happened. I said a number of times in my class, like 24 hours before she passed away, I remember she had us come to the house and she wanted to give me her computer system, right? And I remember she was like, I can't work anymore. She was working and doing stuff limited capacity right up until the very end. And about 24 hours before she passed away, I remember we were all sitting on the porch. She actually had eaten. She was feeling really good that day, which I'm going to come back to. And she got me into the computer. She had me change the password, and then she handed it to me, and she goes, "I won't be needing this computer anymore." And that was really hard because that was like she was admitting that was it. It was over. So that was really difficult, having your mom give you this computer and she's like, "I can't work with you anymore." And I've talked about this a number of times. Oh, you want me to tell that story, Brian? If you can find a picture of the Choose Wisely shirt that we have, I can talk more about that as well. I don't know if I have that picture anywhere on me. I'll talk about it a little bit more, but I found out that what actually happened is whenever you're fighting cancer, it's incredibly common for people to they feel really great right before they pass away. They feel awesome. They feel like they beat it. They feel like they've turned the corner and they're ready to go. And what I discovered, like I said, very, very recently, is that's common because your body is putting so much energy into fighting cancer that it gets to the point where it's completely exhausted and it's completely depleted and it gives up. That's why people right before they pass away are like, they felt so good. I don't understand. They turned a corner, everything. It was literally because their system stopped fighting. And all of that energy that they were putting into fighting it just all of a sudden was available to them. So that was it. So you wanted me to, that's the hat. So I'll see if I can find a picture of it. But Choose Wisely comes from the fact that whenever I was a kid, I was really into Superman. And my mom, this is back in the 80s, okay? This is early 80s, like 83, 84. And I was really into Superman. And if you remember the costumes in the 80s, we didn't have like, the Halloween spirit of Halloween to go buy crappy costumes from. So you would make your own costume. And my mom made me this blue Superman cape and bought me red underwear. And there's a picture of me in like jeans, a blue jacket, because it made me more bulky, made me look like I had muscles, with a cape that my mother had made. And then the red underwear was over the top of the outfit. And she's got a picture of me on that. Now, at that, like ever since I was a small child growing up, I had this picture by my godfather. It was a painting. It was actually a hand-drawn pencil painting, drawing that he had made when he was in prison. And it was a picture of a wall of like prison cells and like what he would see across the way at the prison that he worked at. Or not worked at, where he lived, because he was there. He was incarcerated. And in one of the pictures, you can see him drawing that picture. And that picture was always outside of my door as a child. Always. And I remember, my mom would always tell me, she's like, either A, you're going to end up in prison and you're going to be a criminal, or B, you're going to end up being Superman. She says, there's going to be nothing else in between for you. And this is what I did at DerbyCon. And the talk is out there. You can pull down the DerbyCon presentation if you want to watch the whole thing. But that last day when I got that computer from my mother, she pulls out that flipping cape and she hands me that cape. And she goes, "I'm glad you chose wisely." Like she had kept that cape like all the way up until like my late 30s. And she found it and she gave it to me. So that's where Choose Wisely comes from. So if you look at a lot of stuff at BHIS, it says choose wisely. That's the point, So that's it. So this stuff is free. It's free to the public. It will remain free. We have 26 patents on it, on what it does. And we do that because we want this technology to be available to you all. You can run it at home. You can do this. And my mom asked that it kind of stay free. We have a commercial version with GUI and all kinds of stuff that we sell that you're going to take a look at here in just a couple of seconds. All right. So if we're trying to look at the data capture, right, we're trying to do this. By the way, those of you that have been with me for a while, I finally made it all the way through talking about that without breaking down crying. I don't know if that's sadder or what, but it was, it's always been hard for me to get through that stuff, but it's good. It's good. It makes one of us okay. Yeah. So, all right. So whenever you're trying to get this data, like getting that full PCAP is, it's full PCAP. It's very, very portable. Everything supports it. You do run into issues of size because it's uncompressed and all of those different things. And encryption can cause issues, right? And there's a high learning curve. And tools like TCP dump and Wireshark are very effective. Now, if we're trying to capture the data, we got to position our sensors in such a way that we can capture that data properly. And this gets into pre-network address translation and post-network address translation. So when we're looking at pre-network address translation, we're plugging in on the inside of a firewall where we can see the IP addresses of all of the systems on the inside of the environment, right? We can see all of these individual systems. We can see their internal IP address, because if one of those is compromised, we want to be able to differentiate what that computer is from all of the other computer systems. And if we're on the other side of the firewall, everything's going to appear to come from the firewall, and it's going to look like everything is compromised all of the time, right? So we want to be on that inside of that firewall or that routing device. Now, there are dedicated capture devices that are fantastic, right? You have Gigamon, you have Corelight. These things are plug and play. They're very expensive. And it gets into, yeah, they're expensive, but how much time is it going to take for you to set up and configure one of these things bespoke in your environment? Like, how hard is it going to be to actually build that up and do that on your own? Now, additional things that we can look at with Rita and the commercial version AC Hunter is things like user agent strings. Now, user agent strings are the strings that you would present to a web server to identify the service that's making the connection. So if you're a browser, you would see something like Mozilla compatible, right? If you're bit services, you would see that. Windows Update Agent, you would see that. You would see these user agent strings identifying what that device is. Now, this becomes important because you can see here like how often we've seen these user agent strings. And then we have this user agent string that is 7,658 times, but only one computer system in the environment ever used that user agent string. That's things that make you go, huh, we need to look into that, right? We can also use JA3. I need to replace this with JA4. JA3 has been somewhat deprecated because of the randomization of the TLS client hello messages, but it still works very well for historical analysis of older like backdoors and services that have been fingerprinted. And JA3 is just TLS SSL client signature fingerprinting. And we have seen that now been migrated over to JA4 to be able to do that. So it's still part of the JA rule family. I don't know. 50 Cent may not like me bringing up JA rule, but at any rate, JA rule. So the JA3, JA4 that we can use for those methods to identify it. Now, ultimately, what we're trying to do is do long tail analysis, right? Trying to look for these outliers that exist. So we got like fat head and long tail. I'm not that interested in like all the systems that are going to Google with standard communication profiles matching what a human would do. I'm really, really interested in the long tail analysis and what we can do to look for the outliers and the things that are unique in that data set as well. Now, this is true for an endpoint, it's true for a network, and it's just a simple sort of the network connections that we're doing. We can also incorporate denylists. So whenever you have bad IP addresses out on the open internet, you can look and see if there's any known bad IP addresses that have been previously discovered. And you can compare that to those denylists as well. And of course, all of this can run on Security Onion, and it works with Rita. So very, very cool. And that brings us to the AC Hunter lab that we're going to do. All right, let's go ahead. Get back to the lab. Check something though. Oh, cool. That'll be a good section for Doc to do. All righty. So we are going to do, it's up here. Can't even find my own stuff right now. Here we go. Rita and AC Hunter. All right. So you're going to go to this URL right here, and you're going to log in. You're going to get a TLS SSL certificate warning. That's fine. I'm going to go ahead and log in, training at Black Hills InfoSec. And I think the password is got beacons. Oh, there's the choose wisely thing. Nice. There we go. Now I'm logged in, and we're all going to be logged in together. All right. falling like an avalanche coming down the mountain. All right, so if we want to change our data sets, you go to the dashboard. So if we're over in beacons and we want to get a data set or strobes, we can go to the dashboard, click the gear in the upper right-hand corner, and it loads a new data set. So if I'm looking at like WinLab agent data set, I can select that, confirm. Now I've loaded that data set. Okay. And if there's a question about beacons, you can click on beacons, right? And you can answer the question related to beacons. If we got a question based on DNS data, you can click on DNS and you can, well, certain data sets. I've got what's going on with the DNS resolution that's out there as well. All right. Let's go ahead. There we go. So you have a number of questions, and you can see the little individual sections down below can be used to help answer those questions. So let's go to the questions themselves. We got some usage information here. I've got 4 questions that I'm going to ask you. First, what is your name? No, I'm not going to do that. Not going to do that. All right. So with this, let's go ahead. Oh, no, that's not good. Oh, that's weird. My iPad just went out as my second screen. I can't see the Discord. All right. WinLab agent dataset, what is the connection interval to 10.10.98.30? In the GCAT dataset, what is the historic fully qualified domain name for the beacon on 10.55.100.111? And for the DNSCAT2 JA3 strobe dataset, what is the domain with the highest lookup count? And for this, it's going to take us 30 minutes. So let's go ahead and set 30 minutes on the clock. Actually, we didn't take a break. Let's do 35 minutes on the clock, if you don't mind. There we go. So now we got a good break, and then we got some time to answer these questions. I want you all to work with each other in solving these particular questions, and put your answers in Discord. There, it's back. There we go. And then just kind of share with each other how you answered it. And then as you're doing this, I want you to think about how in the hell would you do this with anything other than Rita? Like, how would you do this type of analysis to find these things? With that, let's get rolling. I'll see you all on the other side. All right. Let's click that over here. I don't know why all my Zoom controls just showed up on the main screen presenting on. Let's go through this lab. Got a lot of submissions. Good job. Good, cute pictures of dogs too. I like that. Looks like we got a lot of right answers. It's good. All right. So let's go ahead and go through this. So the first one is in the WinLab agent data set. All right. So lucky for me, I don't need to have another tab open for this one. I'm just going to put this right here. So in WinLab agent data set, what is the connection interval for 10, 10, 98, 30? So I'm going to go back here to the dashboard. I'm going to click on the gear when it comes up. Looks like I might be logged out. Might have to log back in. Yes, that is exactly what is. Oh, that's funny. Looks like someone's been trying to break into that system for a while. Let me go ahead and get that password. Got beacons. There we go. Paste that in. Uh-oh. Did I not put that password? Did I copy a space? I didn't copy the G. It ain't nothing but a G thing. All right, paste that in. Remember me. Now we're logged in. All right, so we're going to start out with the GCAT data set, or WinLab agent, I think is the one we're starting with. So WinLab agent, what is the question? The question is, what is the connection interval for 10, 10, 98, 30? So if I do that, let's go to beacons, and let's look at 10, 10, 98, 30. And we have like the mode here, if we're getting in statistical analysis, is we have 3,729 connections at 15-second intervals. Now, whenever we're looking at this, there's a couple of interesting things that are going on here. Now, this particular backdoor was created by BHIS, one of our analysts, Joff Thayer. And Joff created this backdoor, and he introduced something we call left drift. So if you're trying to detect a beacon, there's actually a number of different tools that do beaconing level detection from an EDR perspective, like CrowdStrike does beaconing analysis and beaconing detection. And they use an algorithm called k-means clustering. And there's nothing wrong with k-means clustering at all. It's just an unsupervised machine learning algorithm. And it's actually pretty good. We actually use it as one of the algorithms that we do analysis on that as well. But this is the mathematical algorithm for it. And I think that pretty much speaks for itself, right? Yeah. All right. But one of the problems of using just k-means clustering to try to identify a beacon is it doesn't handle drift and it doesn't handle outliers really well. So there's two things going on with this particular backdoor. We have this left drift here, which is heavily weighted on another side. And then we also have this outlier out here that's like 92 some seconds way out there in the middle of nowhere, left field, doing its own thing. And that's enough to break k-means clustering. So whenever you're doing analysis, you want to do analysis for multiple different attributes. Now, we were talking about the beaconing frequency, the data size, the connection interval earlier, whenever we were talking about detecting beacons on a computer system, but there's other things that you can do, like a mode clustering. So this is a very heavy cluster. Right, 15-second intervals. We have 3,729 connections at that interval. The other thing is down here, we can look at the histogram, and the histogram is really important as well. It's a pretty damn flat histogram, right? This is the number of connections by hour. And you can see by each hour, we're sitting at about 300 connections or so every hour. So we can actually flatline that out and do that analysis across the board for all of those various connections that exist. Now, the new version of AC Hunter has switched over the backend database from Mongo to ClickHouse is the new backend, and the new ClickHouse database is really wicked fast at doing this type of statistical analysis. It's about 10 times faster than Mongo. And to kind of put that in perspective, the existing version of AC Hunter running on Mongo was able to run on 100 gig link, 100 gigabits per second. And now it took a pretty powerful series of systems to do that, but you could do it at 100 gigabits per second. that we have our largest customer, and one of our other customers, it's running at like 50 gigabits per second for a university. So it's pretty fast as it exists, but now we're 10 times faster doing the data analytics at it using something like ClickHouse gives us that type of capability. But one of the things that ClickHouse is really good at is identifying flat histograms or histogram analysis. And that's what you see at the bottom on that as well. All right, so that answers the first one. The first one is 15-second intervals. Next one is in the GCAT dataset. What is the historic fully qualified domain name for the beacon at 1055, 100, 111? Let's go ahead and let's open up that GCAT dataset. And let's talk a little bit about what GCAT actually is. So GCAT is a backdoor that we created at Black Hills Information Security as a proof of concept. It was created by an intern. And it was, let's try Byte Bleeder. And here we go. And this one, he hasn't updated it in years, but it's now GDog is now kind of the spiritual successor to GCAT. But a decade ago, when we worked on this particular backdoor and we created the proof of concept code for this particular backdoor, it started with a theory that I had that if you had a backdoor that was using all of its command and control going through Google, it would be very stealthy and most likely not detected. And we created this backdoor, we put it out, and literally what it does is it constantly checks its email, like standard Google email, and it's looking for commands. And if a command comes through email, it will then execute that command and then email itself the results back. So all of the command and control for the hacker tool looks just like standard Google email lookups. So we have GDog is the new version of it, and also has some jitter and some pretty cool things on it as well. It also has encryption, unique ID for different systems, job ID, retrieving system information, geolocation information, list of clients, execute systems command. It slices, it dices. It is the Ron Popeil of Google account command and control. So pretty cool tool. Now, the reason why this particular backdoor is important is this particular backdoor was picked up by the Russians and was used against Ukraine. Not during the current phase of the war, but before the actual current hot phase of the war began, Russia took over a whole bunch of computer systems and inside of Kiev, and they were able to shut down the power grid in Kiev. And GCAT was the mechanism that they were using for communicating outbound. It's another one of those situations where it's like, this is a problem, people. We need to deal with it. Not a lot of people did anything with it. And honestly, you know, getting the FBI calling me and asking me about this particular backdoor is always a fun time, I guess, when we're dealing with this stuff. Now, with this backdoor and the fact that this was used by the Russians, there's a bunch of different things that this actually kind of uncovers. One of the things that it uncovers whenever we're looking at the backdoor associated with the beaconing traffic that's going to Google is the fact that it's just standard Gmail SMTP or smtp.gmail.com as the fully qualified domain name going back and forth to Google. The second thing is it makes total sense. Makes total sense that this worked as a backdoor and it wasn't detected. And it makes total sense that when you're looking at nation state level adversaries, that they're using these types of backdoors as well. And the reason is most of your security appliances are ignoring absolutely everything that goes to Google all the time. Why does that make sense? Well, that makes sense because I want you to think of false positives, right? How many of you use Google on a daily basis to do Google searches for what a command does, what a tool does, right? This is something that is very, very, very common for a lot of us in the industry. We are using Google literally all of the time for all of the different things that we're doing. So this would generate, as Brian was just bringing up, lots of tuning opportunities, right? And this is an example of that tuning opportunity, because if I was using just something that was doing simple signature-based detection, I wouldn't be able to detect this backdoor at all. And most of your products aren't intercepting all of the traffic that's going to Google either. So I love it because there's an XKCD comic on tar that I just love. And it says, Rob, you use Unix. Come quick. To disarm the bomb, simply enter a valid tar command on your first try. No Googling. You have 10 seconds. Rob, I am so sorry. Now, imagine if every time you Googled how to use a command, Google was like intercepted, decrypted, and then all of a sudden an alert would show up that John doesn't know how to use the tar command properly, right? Literally every time anyone was Googling a command, anytime Googling an output of log, you would have alerts being fired. So the first part about this kind of makes sense because trying to do that type of analysis across the board for everything that goes to and from Google is a lot. That's number one. Number two, it's going to Google Mail. And if you're looking at people that are going to Google Mail, if you're intercepting the TLS SSL, there's a lot of HIPAA and privacy questions that need to be answered by your company about intercepting and tracking that traffic that is going to private email. Many US companies just honestly don't care. But if you're looking at Europe, they have full GDPR that makes it illegal for organizations to intercept that private information and store it and analyze it at all. So it doesn't make a lot of sense for your firewall vendors, intrusion detection system vendors, and all these different vendors out there to intercept and try to do full decoding of that traffic that's going to and from Google, because it's just, let's just be honest, it's a lot of traffic. And it's also something that's going to run afoul of a number of different privacy violations that would exist as well. All right, the final thing, speed, right? All of these different devices, they live and die on speed, right? So if you're looking at it from just a purely just kind of logistics perspective and doing analysis on that, you're really running into a scenario where if you can ignore a whole bunch of traffic that's going to Google, then that means you can spend more of your time processing the other traffic that exists. And that gets into just kind of the general day-to-day logistics of trying to run a firewall company and doing that type of analysis on it as well. All right, so that is the GCAT data set. The next question is, in the DNSCAT2 JAW3 strobe data set, what is the domain with the highest lookup count? All right, so let's go ahead and let's go back to AC Hunter. Let's go back to the dashboard and let's open up that DNSCAT2 JAW3 strobe agent data set. Let's go right on over here to the DNS information. All right. So let's talk a little bit about what a domain is and a fully qualified domain, right? So if I go to google.com, google.com is a domain. Okay, that is a domain. Now, there's a bunch of other things underneath google.com, right? Like I have www.google.com. I can do maps.google.com. It's going to take me to Google Maps. That is a fully qualified domain for that, right? If I go to mail.google.com, that is also a fully qualified domain as well. If I do APIs, that is a fully qualified domain. Now, I want you to think of a company like Google and how many fully qualified domains exist under Google. I mean, can I Google that? Let's do that search. How many fully qualified does Google have? Let's see how many Google has. Google has over 16,000 registered fully qualified domain names, although the full number is not publicly disclosed. That's a big company, right? That's not a small company. That's not small potatoes whatsoever at all. That's a lot. Okay. So if we're looking at this data set, right, if we go back to AC Hunter and you have this r-1x.com, it has 109,227 fully qualified domains. Does that seem legit? That seems strange to me. Like it might be odd that an organization would have 109,227 fully qualified domains. What's going on there? Well, that's a C2 backdoor. All right. Now, the reason why, well, it's a C2 backdoor, and there's one example that I know of that does that differently. There's an organization called Kimry. which is, if you try to read it, not Welsh, it looks like CRIMU. They're a security company, and you can send a hash to their domain, and it'll check that hash and say whether or not it's malicious. So it's kind of like an AV. Let me see if I can find that. What is it? I think here, this is it right here. So this is their hash registry. And it's a DNS API, supports 75, SHA-1, and SHA-256. And you can submit a dig, and then you can submit that hash to Kimry, and Kimry will do a lookup on it. So let me go ahead, put this. Oh, somebody's already got it in the chat. So you can write your own tool that actually submits the different hashes via dig or any DNS utility where you can put in the hash of a file and you can send it in, and it'll come back and tell you whether or not it has any AV hits. And it looks like the hit is a percentage, right? So that hit percentage is 29 on that particular hash, right? So you can do that hash lookup very quickly via DNS. But this right here, that long string at the beginning, is exactly how DNS Cat2 traffic looks, because it generates a unique hash for the beginning of the malicious domain. And the reason why it does that is because if it doesn't, like if it tried to do this lookup to www.kimry.com and it did it again and again and again, it would not work because the local cached answer on your DNS server would take precedence. So by randomizing that value at the beginning of that, you're going to run into a situation where every single lookup goes all the way to the C2 server. So that's why you have 109,227 individual lookups for that lookup coming into the environment. So that's why it's generated. Now, okay, so I've got an example of where that might happen, right? Now, that's really an edge case. Just because there's one, trust me, it's not normal. The only reason why I know that that exists is because AC Hunter does this type of analysis, and we deal with like hundreds of companies and terabytes of data. And we have one that I can speak of. That's Kimry. All right. But let's say that you have a high lookup count, right, for a particular domain. And the reason why attackers use DNS as a lookup tool is because it's very rarely analyzed by any of the different security products that are out there. It's not really looked at all that often whenever we're digging around. So that's number one. Number two, if we're dealing with like a very sensitive network segment, let's say a SCADA ICS environment, a lot of those SCADA ICS environments are very isolated and they may not have direct connection to the internet, right? So if it tries to make a TCP connection directly to the internet, it ain't going to work. But if I do a DNS lookup, it does, because DNS needs to be allowed for a lot of these systems to communicate internally. They'll keep DNS available to these highly sensitive network segments for like medical equipment, SCADA ICS equipment, or like PCI credit card processing enclaves. And you need to be able to do internal name resolution because that's what it has to do, which brings me to the second part of this. If we look at the queries, we have 109,227 lookups, and they're all coming from this one IP address, 192.168.88.2. All right. Now, if we're looking at that particular IP address, 192.168.88.2, every lookup is coming from one system. How likely is that? Turns out pretty damn likely. Actually, very likely. Because if we go back to the sensitive enclave, right, the system that does the DNS resolution that converts the names of systems to IP addresses of systems, predominantly in most environments, is actually the domain controller for the systems, for the environment, because that is the primary DNS resolver. So it's common for an organization that has thousands of computer systems to filter all of their DNS requests to one computer that does recursive lookups on behalf of those computers. So how do we differentiate what is a malicious internal system versus what is a system that's possibly an internal resolver for an environment. Well, it turns out we can see who's doing the DNS queries. And here you can see it's one computer system on that network. We have 192.168.88.2. That could be your domain controller. But then we can look at who's making the direct connections, not just the DNS lookups, but then who is making the corresponding direct connections to the IP address associated with r-1x.com. It's the same system. And that's weird, right? You should see other systems making those direct connections if it was a normal standard DNS lookup, because you would have the DNS lookup that would go through the domain controller, but then when the IP address connection is made, it would be made directly from the internal computer system, not from the domain controller. So we have this one computer system that's making every single one of these different connections that are out there as well. So this becomes a really cool way for us to detect that DNS command and control traffic in an environment out there as well. All right, so that is it for this particular section. Do we have Doc on yet? Megan? Daryl?
Hello.
There he
there
is.
See, Doc, and here's the deal, man. I questioned your background and your lighting skills in an email this weekend. Remember, I asked you, like, how's your background? What does it look like? And you told me, it's like, well, it's the same one I have. Like, I've looked at it yet. And I'm going to tell you, sir, I apologize. Your background and your lighting is spectacular. Very, very
Thank you. John, I went through a few iterations of this. Ryan knows I actually the other 2 days ago, I painted the wall behind me again because the color I had it was too dark, and we are trying to get the right contrast between the foreground and the background. I literally repainted the wall for you, not knowing that I would be doing that
today.
So early, yeah, today. And I have something to admit.
Go for it.
I was asleep. Yes, it was 8:30 and I was still asleep when John originally called. And he had texted me earlier and last week. And I figured, okay, well, I'll call him when I was getting up soon. And then he calls again, like 15 minutes later. And I was like, I better answer that phone. And so,
yeah, I was panicking.
Where it's like, wake up and just, and don't sound like you're asleep. John,
yeah, I'm sorry about that, dude. Like I told you, I panicked and I feel bad about it. I do. So, but for those of you guys that don't know, Doc, how long have we known each other? Like we both survived the dark place.
It's been 12, 13 years.
Yeah, it's been, oh God, it's been that long. But Doc has been an instructor as long as I've known him. I don't know. Did I murder board you? I kind of remember murder boarding you
twice.
Yeah.
Oh, man, you survived 2 John Strand murder boards.
He was not at all. I think.
And you came back twice. Jeff McJunkin came back like 5 times. Like just okay. So people don't know what a murder board is. So whenever they stopped this, and since we're well past the thing for me, I will speak, Doc. You don't have to talk about this because I'm further out than you are. But I used to run at SANS like the instructor prep program, and we would do this thing called a murder board, where people that wanted to be an instructor would go through pure hell with other SANS instructors. And we would pretend to be 3 separate students: a clueless student, a student that hates you, not a particularly bright student, but they hate you, and then a really incredibly bright student, probably as smart, if not smarter than you are on the topic. And the whole idea of it is to see how someone fails. Like, we've had instructors cry, we've had instructors lie, we've had instructors that just flat out are like, dude, that's a good question, I don't know. Way to go. And that's a good thing. But we would take and channel all the horrible students we've ever encountered and focus it into somebody. And it was really designed to, it's better to encounter that amongst friends than it is to encounter it for the first time with a student. Because whenever you've gone through it a number of times and you encounter it in a student who's just being an a-hole or whatever, you're almost like, am I being punked? Like, I've been through this before. And it's really cool. And they stopped doing that and they replaced it at SANS with the precious snowflake board, which is kind of a thing. But Doc was he was too as well, fantastic instructor, and
Thank you.
really proud to have him over here at Anti-Siphon. He's got some cool stuff coming up. Some class. Doc, do you want to talk a little bit about the classes that you're getting in the can for us now?
Oh, absolutely. So first, when John murderboarded me, there was two different levels. The first level was of a certain instructor program, and then the second murderboard was a higher level of just ramping up the instructors. And I remember the second one, I think I had prepared for, say, 10 slides, and I got through like 2 of them because John was being all 3 of those problem students all at the same time. And so I got like through 2 slides, and I remember it sounded, it was over the phone. And there were other instructor candidates that were going after me, and they were on that call. I think you scared the crap out of the next person. I mean, you murderboarded me so hard. I felt bad for the person that was coming after me. Mm-hmm. I stayed on that one, and that guy you'd ask a question, and he sounded like Beavis and Butthead. He's like, and
oh my gosh, John, I could just imagine.
I think it was because John
much kinder and gentler these days, Doc.
Yeah,
gave that person
not when it comes to
just instant PTSD from hearing what John just did to me. And they even prepared all the other instructors, saying, "Well, Doc's going for that next level. You guys are all at this level, so don't worry, you're not going to get the same treatment from John as that."
The worst one we ever had, Doc, we had a guy that was coming on and he wanted to do Netcat with Ed Scotus and I. And we warned him against that. We were like, dude, don't do Netcat. Like, you really shouldn't do Netcat. And he told us, he goes, go as hard as you can. There ain't anything you can ask me about Netcat that I can't answer. And he got like 10 minutes into it and he's just like, I got to get off. I can't do this. Like, there's just no way. Like this is insane. And he was pretty despondent. But no, we always loved the people that kept coming back. And and like you and Jeff McJunkin, actually Tim Medine, I think did 4 times. 4 times. Like, and like all of these people, like you and Tim and Jeff, like just absolute monster instructors, because I mean, nothing's going to phase you now, right? Like you've been through it. Of course, now it's your chance, everybody. No, don't do that. But I need to get going. Doc, thank you so much. We did end right on the UEBA slide. So you're ready to take over. So what's going to happen is Doc's going to do UEBA, do a lab, and then we're going to move into the Ask Me Anything. And don't treat it like a murder board, y'all. Be nice to Doc. You've got a wealth of experience. And Zach is going to hang out, and we like to close out our classes with Ask Me Anything, just so a lot of times, and that's one of the things that we talked about, Doc, like we teach our slides, and a lot of times we have to get through like 100 or 200 slides a day. And this class, we do 100, like we don't do the full 200 death PowerPoint thing. And I think we get it on our evals all the time. They're like, I wish I could have spent more time just asking this person questions, and we've got stuff to get through. So you're going to get a chance to get access to Doc today, Zach today, and then me tomorrow. You get a lot of perspectives on computer security. And with that, I need to get running. Thank you again, sir. Everything looks fantastic. And I will see you all bright and early tomorrow morning. Take care.
All right.
Sounds good. Thanks,
easy, John. And I'll be here too, Doc. I'm in the background too. So
all right.
I'm hanging around as well, Doc.
The voice with no face there, Megan. All right, so let me go ahead and I gotta share my PowerPoint presentation, and it looks like that's being shared now. Do you guys see that screen?
Yep.
And now I move this around. I've got multiple monitors and not enough room for anything, of course, because that's how life is. And so now John was mentioning I am writing a few different courses that are foundational, introductory level for anti-siphon. And it was so exciting. Just a couple of weeks ago, we had our first workshop. It was a 4-hour workshop on cryptography. And it was a wonderful class. I was really excited to teach that content that I wrote. It was the first time it was being presented. Now I have, since I've got the microphone and I can ask Megan this question. Megan, hopefully you know the answer to this one. I've been asked by a few different people who weren't able to attend that workshop live. They were asking when they would be able to see that, like on an on-demand type situation. Do we know when that is going to be available for people to view later?
So the only people that will be able to view it later are the people that actually registered for the workshop itself. So your next workshop, as long as the people register, they'll get access to that. And then, we can kind of touch base after and maybe talk to the on-demand team about recording it for specifically for on-demand.
Okay. Thank you for that. I was under the impression that, and I believe
you may have, and that could have been something that you were doing.
Yeah, that's what we were doing. I was receiving specific instructions to, in the live setting to address concerns from folks in Discord and stuff in a general sense, because it's going to be a recording that's available later. Maybe in the course of the next 2 hours, we could see if that's the case.
Let me reach out to the team. A lot of them are in the EU though, so they may be gone for the day. But worst case scenario, I'll have the answer tomorrow morning, and I can let everyone in class know, and I'll let you know as well.
Full Frame Overkill was there. Doc says, Doc, it was amazing, and so thank you for that. It was a lot of fun to present that class. We have coming up in January an 8-hour one-day course in networking essentials, and so for those that are interested in understanding, one of the things I plan to do, I absolutely 100% want to do, and if I fail to do so, then I've failed in life, is to in the networking course make John Strand angry with me by just talking about the OSI model. And I don't know, because I wasn't here for earlier, did he go off on his rant about OSI and all of that, and how it just isn't a model that should be, and maybe that should be the safe word. I know somebody in Discord was saying, what should the safe word be? Maybe OSI model is our safe word here. He did not rant today.
He didn't rant today, but he usually rants every other time.
Did not. Okay. We got to remind him tomorrow to make sure that he rants about OSI at some point. And so, So anyway, let's go ahead and get started into user entity behavior analytics. Now, where we left off was really about how machines behave. What are those characteristics of machine behavior that would be an indication that an adversary has compromised the machine and now are using it to their own for their own evilness? And now what we're going to do is we're going to switch gears. It's more about behaviors again, but this time we're going to talk about the user behaviors. And so people log in, and what do they do from there? And what does normal behavior look like? And once we understand what normal behavior looks like, we can then pick out what abnormal user behavior looks like. So that's where we're at here with user entity behavior analytics. That's a big mouthful. We'll just call it UEBA now. And then we have to ask ourselves, so where does this fit in MITRE? And it fits everywhere. When it comes to the MITRE attack framework, in gaining initial access, that is user behavior. People log in, people access systems, in executing programs, in maintaining persistence, in escalating privileges. Our regular users, they need to occasionally elevate their privileges. And in privilege elevation, that is, let's say I'm sitting at this computer and I am logging in as Doc. And then I need to make a change to this machine. I now need to elevate my privileges to admin. And so either by giving myself that role, that permission, or logging in as a separate account in Windows called the administrator account, if I've done that successfully as the intended user for this machine, this is my computer, I've elevated my privileges. Well, when it comes to privilege escalation, that is doing that elevation, but without the proper consent of those who own that machine. Now, the attackers escalate their privileges while we elevate our privileges. And in lateral movement and collection of information, sending that information back out, all of the MITRE attack framework, with very few exceptions here, is addressed through UEBA. Now, the main area that we're going to be looking at here in understanding those behaviors is when I logged into the system, a log file was a log entry was created and put into a file. And then when I elevated my privileges to admin or however I did that, then another log entry was created and added to that log file. So now all we need to do is go into those logs and see what those behaviors are, right? And then we can figure out, we can detect when somebody's escalated their privileges instead of elevated them, right? And that's not how things work. Our logs are a disaster, and there's a reason for that. Our logs have always, and I know some people will argue with me about this, and that's fine. They can argue with me. They can be wrong. The problem is that logs were something that were created as an afterthought when it comes to how computers work. Computers are not designed to create logs. Computers are designed to enable people to do things, get the work done that they need to get done. Logging is then added on as a description. How I'd like to describe logging is that logging is the words that tell the story of what happened on the network. Ah, isn't that nice? Yes, but what does that story say? In order for us to get that story straight, we need to know what are the logs that we need? What are the right words that tell the story of what happened? And are they in the right order? Are they the right information? If I were to start speaking English sentences to you, but I jumbled all the words up, and I could give you a demonstration of that, and I'd probably do it very poorly because I'm always trying to make sense, even though half the time, ask my ex-wife, I don't ever make sense. But what we're trying to do here is we're trying to detect what that, understand what that story is. And so we need to have the logs in the right order. We have to have the right words that tell that story. Now, once we do that, it still isn't a panacea for us when it comes to detection. About less than 5% of all detections of malicious events come from the logs. Wait, just 5%? Why are we bothering to talk about logs here if they are so little, such a small part of our detection? Well, for one, we need to have those logs to tell the story. Most of the logs that we collect are not for detection of those events. Most of the logs that we detect are for when we have discovered that there is an adversary in the system. And so we're doing incident response, or after the fact, the event is over, we're doing forensics. We need those logs to be able to tell what happened on the system. Oh, this username was logged into successfully on this system. There were no prior attempts to log into that system, so there were no failed events. It was during a normal period of time. It was, Monday at 9 a.m. So I'm just telling the story of what happened. And then that user had opened up that web browser. The user then went to this certain website. That website had a program that the user then downloaded and ran on their computer. Our logs tell us those things. But what I just described could have been a regular user downloading a program that they're going to use on their local workstation because they need to get some job done. Our other software on the machine doesn't do that for us. And so they're downloading this program. Whether or not, I know some of you are getting hives and getting itchy skin just thinking about users downloading programs from the internet and then running them on their machines. If that doesn't scare you at this point, folks, then John has failed to do his job earlier today, right? That's a very scary thing. Well, in some environments, a lot of the people that I consult with, their users have to do that because there really is no central management. Now, that's regular user behavior. But then what I've also described is something that an adversary accesses a system, downloads their malware onto that system. It's the same events. Was it for good or was it for evil? We have to be able to tell. Now, when it comes to logging, it isn't just a matter of programs running, people accessing machines and the times that they're running. What was actually executed at the command line? Bash and PowerShell logging, we can do that, yes, but it's not very usable for our detective measures. So let's go ahead and start talking about our logs and how we're going to manage all of this information. You are not going to take the logging information that you have and just start reading it like a story. There is no way you're going to get usable information out of manually going through your logs. Maybe there was a time decades ago, but there are too many logs now, too much erroneous information. So what we're going to do is we're going to use tools. Now, earlier, when I had mentioned that a user logged in and opened the web browser, downloaded a program, that sounds like regular user behavior, but that also could have been the attacker. The reason that attackers like to look like users is because they may not have to put malware on that machine if they've got access to it. They like to do what's called living off the land. Living off the land means using things that are built right into Windows and Linux, like WMIC and CertUtil, PSExec, and Task Scheduler, all of those in Windows. All of those are perfectly valid applications that are installed and running on the machine, and not all of them are running. Those are programs to be run, but all of those programs could be used for malicious activities. And so a tool like JP-Cert will look at those the analysis of those tools and how they were used and put together a story about what were the attack methods and what are the artifacts left behind that were created and left behind, and so that we could tell that story of what happened on the system. So now, all of this stuff, even when we're not detecting through our logs, all of these behaviors have the potential to be reflected in the logs somewhere. First, we need to make sure to have the right logs turned on. Your default logging in Linux, your default logging in Windows will have a lot of useful information, but we also need to make sure that other things that are useful to us. And it is a very personal thing for organizations, because not all organizations operate the same way. You, in your organization, will need to figure out what logs do we need in order to determine what are the behaviors, and was it for good? Was it for evil? And we're going to need to collect that information from a lot of different resources as well. And so some of the things we're going to be looking for, and we're going to, when we do our last lab of the day, we are going to be looking for an attack scenario that is common, because for one, it's very hard for a lot of tools out there to detect. A lot of the security tools don't detect this well at all. And that's why attackers love it. And it's called the password spraying attack. I believe John I know we were talking about passwords earlier. I'm sure he's already mentioned password spraying is where you take a known bad password. This password has been compromised in some form or fashion, and we spray that password at a whole lot of accounts in your environment, hoping that somebody in the environment has that bad password because it's a very common and it's now an exposed password. And so what we need to do is we need to be able to collect our logs, not just from one system, but from many different systems. So we can then get all of that information back to one location so we can determine what was the behavior going on here, who is doing it, and what are they trying to access? What is their end goal? One of those end goals is lateral movement. Let's say the attacker has compromised a password for a user account, and then they use that username and password, those credentials, to then start trying to log into other systems. When I'm looking at my logs manually, it could be really hard for me to try to figure out, well, wait a minute. So this user logged into this system at that time. That's interesting. They're not normally logged in there, but maybe that's just something they need access to for that particular day. Or, how often did that user do that? Here we've got a tool called Logon Tracer. And this Logon Tracer tool does a few different things for us. Most importantly, it gives us a graphical representation of what happened on our systems. It shows that relationship between the different systems over time and through different accounts, using just simply some very useful event IDs in Windows. You'll see up at the top of Login Tracer there, it's got the event IDs, and it's really hard for me to read. I believe that's 4624, 4625, 4768, 4769, and 4776. These are all events like an account was successfully logged into. An account was failed when it was an account failed to be logged into 4768. And these are all things that you can look up online easily if you just simply type in Windows Event ID. I know John likes to Google things. I'll just go ahead and show you one here. Well, actually, you know what? We're going to be covering that in just a moment there. So I'm going to save that one for a moment here. But if you just simply, do a Google search for Windows Event ID and then that number, it'll tell you, the internets will tell you exactly what that event was. 4768 was Kerberos authentic. Having a hard time with this word today for some reason. Authentication ticket was created. A Kerberos service ticket was requested. 4776 is the domain controller attempted to validate the credentials for an account, which means that our domain controller in Active Directory is now checking to see, hey, is that user valid? This system is requesting that. Just based off of that information, we can get a lot of data visualized to see how did this one system that apparently is compromised was used to then try to log into other systems and then highlight which ones of those events, for example, was failed. That 4625, an account had failed to be logged into. Well, maybe that was and I see it for a lot of different systems in the environment. That is one of the indications of a password spray attack. And now, John, as you guys know, has strong opinions. I've got a strong opinion on this one as well. And thankfully, our strong opinions meet together. And absolutely, me and John stand strong on this one right here. There's no such thing as a false positive. And I stand behind that. Thomas Edison, when he was trying to create a light bulb, he failed hundreds of times. I believe that the number of attempts was around 700 different times. And then he finally figured out how to make a light bulb. Oh, look, we now have light from this filament. We did it. Congratulations. He was interviewed. Thomas Edison was quite a publicist. He was very much self-promoting. And so, and a lot of his inventions that were attributed to him, either he was the one that perfected it, or he was the one that convinced the rest of the world what its value was. Now, I'm not impugning his abilities, an incredible inventor, but he didn't invent all of these things from scratch. A lot of times he took from others. Steve Jobs did it as well. Steve Jobs would tell you, now I'm doing a reference inside of a reference. Watch out, I'm working on levels, guys, here. I'm doing the weave, I guess. Anyway, and now I wove myself right out of that one. What was I talking about here? Steve Jobs. Steve Jobs says that, and I'm going to mess up the quote here, that somebody put this in Discord, if you can find the quote, was something about that good people create things, great people steal from others. And so Thomas Edison, we'll go back to him now, unweaving myself from this rabbit hole I got myself into here. So Thomas Edison was interviewed, and the interviewer asked him, well, how did you feel about those 700 attempts where you failed to create a light bulb? And Thomas Edison said, well, I didn't fail to create a light bulb 700 times. I figured out 700 different ways to not make a light bulb. It was like, whoa, okay, now that our minds have been freed from the jail that they are in, let's talk about false positives. A false positive, I would argue, is the same thing. A false positive is where we have an event that we believed could be an indicator of compromise, an IOC, and it turned out that it wasn't. We just, congratulations, figured out a way to not find that indicator of compromise. Yeah, there we go. The statement is artists copy or steal. I want to say it for the recording here, so we've got that. Nope, that's not it. It's probably in that article, but I don't see it right there. Thank you for getting that, pulling that for me. Now, talking about false positives, I have an alert, and the alert is wrong. Well, wait a minute. The alert's not wrong. The alert is what happened. This thing happened. The alert was created because we told the rule set, hey, when this thing happens, now alert us. And so it worked perfectly. That's not a false positive. The only problem here is it wasn't the indicator of compromise that we thought it would be. All right. Why? What about this particular event is not interesting to us? And then we filter those out. Oh, I don't need that information. I need to know this thing, but not like that. So tuning our intrusion detection systems, tuning our tools to find these indicators of compromise, we have to do a lot of work to make sure that that thing works well in our environment. Going back to my statement earlier, when it comes to organizations, we're all snowflakes. We're all different. The way that I see my organization, the way somebody else sees their organization, they are two totally different things. And so what we need to do is we need to tune our alerts, and so that we reduce the number of events that alert us that we're not interested in. So let's go ahead and talk about ways that we can actually improve this. And one of those concepts is called stacking. think of a deck of cards. You've got a stack of cards. I've got a deck in my hand, and I am going to, for certain events, I am going to put a card down on the table. And then for other events, I'm going to pick a card up off of that stack and put it back in my hand. Now, let's say a user logs into a system. That's a +1. I'm teaching you guys how to count cards in Vegas. All right. Now, this isn't going to help you in blackjack per se, but it's the same concept of trying to determine whether a deck is hot or not. I see the user has logged in. All right. We put a card on the table. We're a +1. And then the user logs into another system. Okay, another card. We're a +2. User logs into another system, +3. All right. Well, you just described my day where I log into my computer, I log into my email account, I log into my web browser. I'm doing all of these different things. Now, each time I log out of one of those accounts, we remove one of those cards from the deck and I put it back in my hand. Now, what should normal user behavior look like for the number of applications, number of systems that somebody is logged into? Let's say we set that threshold to 6 is what's on the screen. I'm fine with that. That number is not as important as you may think it is, because when we have somebody using a tool, let's say to send passwords spraying to multiple computers, all of a sudden we're at a +2,000. So all of a sudden that 6, yeah, I can set it at 6 to alert. But if people log into a lot of different systems for a lot of different reasons, I need to set that number higher. When the attackers are doing these behaviors, they're typically doing it a heck of a lot more than your normal users are. So now we see behavior that's unusual. It's going to stand out from the rest. With artificial intelligence, AI, we have a real opportunity to score some wins here, because one of the things that AI can do for us is it can learn what normal user behavior looks like for each account. Some of these accounts are much more active than others. Let's say we've got Bob. Bob logs into 40 different systems, and that's his usual. Okay, well, now AI knows that as a usual behavior for Bob. Let's say Alice normally logs into 3 different accounts. Okay, that's normal for Alice. So those are the types of things that we're looking for. Another thing is, though, is what are the types of behaviors that user does once they log in? Let's say Bob is logged into a database. Great. Now, normally, so let's say Bob is a salesman and he is accessing sales accounts throughout the day. He usually pulls about, let's say, 30, 40 records for and I'm not even worried about the record count so much as the amount of data. Let's say it's 30 megabytes of data off of this server, and that is normal for him. AI says, okay, Bob pulling about 30 megabytes of data is perfectly fine. And all of a sudden, now we're at 300 megabytes, and now we're at 1 gigabyte. Now we're at 3 gigabytes. Okay, something's not right. Bob, as a salesman, we wouldn't necessarily want to shut off his access hey, if he's having a hot day and making lots of sales, I don't want to stop Bob from doing his job. But there's going to be some point where we say, yeah, do you know what? That's not usual, normal human behavior. We need to alert on that. And you'll notice that with all of this, when we're talking about AI and these normal behaviors, we're not talking about one specific event. We're talking about the amount of events. And so that's where that stacking comes in. How much of something is going on can be just as important as what is actually going on. Now, here's the question. Where are your logs at? Where are they generated? Where do we keep them? Where do we then query them? Where do our tools access this information? First, we got a problem here. The systems that are logging aren't necessarily in front of us anymore. I log into my computer and now I have a log that I logged into this computer. Problem, it's on this computer. What if the attacker is logged into that computer and then the attacker deletes that event that they logged into the computer? So I need to put that log someplace else. That log entry needs to go to a central location so that, for one, it's not modified. Now, Evil Doc. Oh, I haven't introduced you to Evil Doc yet. Oh boy. So I'm Good Doc. Hello, everybody. I'm a cybersecurity professional and I am fighting for the side of good. And how do I defend our systems? Well, I have to understand the mind of the attacker. What does the attacker do? So the question then is, how does Evil Doc think? Because in order to attack your systems, Evil Doc thinks evil. And then I do evil things with those evil thoughts. I, as Good Doc, what I need to do is I need to think evil, but not for the intent of doing evil. I need to know what Evil Doc is going to do so that I can then detect what those behaviors are. So now Evil Doc, now we've introduced Evil Doc to you, is a fictional character, by the way, because if I ever say Evil Doc did this for plausible deniability, there could be law enforcement in this classroom. Evil Doc is a fictional character, all right? So now Evil Doc has deleted the entry from the local computer. Well, hopefully Evil Doc doesn't have access to that central log server as well. So now we have a record of what actually happened on that system while Evil Doc has access to that system. But the other thing we needed to also be able to do is then be able to correlate all of those events. I need to have a central location. So when Evil Doc logs into this system and system number 2, system number 3, system number 55, system number 5,000, we now have all of that information in a central location. Remember, the logs are the words that tell our story. Well, we need to have all those logs in the same place. Now, let's take things a step further. I'm not logging into this computer I'm sitting at. I'm logging into a server over the network. Oh, right. Now that's a different proposition. I need the logs from this system, but I also need the logs from that system in that server room. Great. So far, so good. We're tracking. Let's log all systems. Let's put those logs in a central location. Yeah. Well, what about the cloud? Ooh, that big fluffy cloud. Doc logged into some cloud service that we manage. There's logs up there too. I need to be able to get those logs back to that centralized system. Those are always a problem. How do we get the logs from all of these different services that we're using up in the cloud back down to where they're usable at one location? So now we get all of these logs, we put them together, and it's not just about the endpoints. I was talking about these services and the systems themselves, but what about the networking gear? A lot of our information in network logs can be very valuable to us. I'm going to go off on just a little bit of a side note here on purpose, because I want to be able to give extra value to you guys. Since I'm not teaching these 2 full days, I would normally talk about this someplace else, but I feel this would be a good spot to talk about this. If you would like a quick win on how to detect an adversary based on their behaviors on a system. John was talking about systems. This is kind of an in-between that user behavior, because it's not about logins and things like that, but this is about user behavior from a system, is gather 3 lists. And by the way, I do not know the original source of where this research came from. And the reason I'm not sure is because I've heard multiple people take credit for it. And so I'm not sure where this came from, just simply because I know of multiple people who have claimed to have invented this, all right? But basically, we've got 3 lists. These 3 lists are going to be the top talking computers on your network. And it is top talkers that are going outbound from your internal network out to the internet, okay? I'm not concerned about system-to-system communication here. I'm not concerned about from the internet going in. I am talking about internal to the outside world. get these three lists. The first list is the top talkers based on the number of outbound connections to the internet. And you don't need to worry about taking notes. In just a moment, I made myself a little note here, and I am going to be posting this for you guys in a little bit here. Chris, you don't know how much joy that meme gives me there of Steve, played by Jack Black, in Discord, because I actually, as you can see, I've got my hair grown out a little bit here. And for this Halloween, I was Steve. And in fact, I got it right here. This is my prop. I was all ready to go. Yeah. So anyway, that meme gives me a lot of warm fuzzies because I was Steve for Halloween this year. Awesome. Good stuff. My wife got me a turquoise. I should have worn the turquoise shirt. I've actually got it on a hanger over here. I should have worn that today. That would have been perfect. And so now let's go back to these top 20 talkers. List number one. Top 20 based on the number of outbound connections to the internet. So how many outbound connections does this machine make from our internal network to the internet? Now you've got your top 20. Where can you find this? Your networking logs. Your firewall is that ingress egress point between your internal network and the outside world. And so all of these logs are sitting there in the network logs, looking for these behaviors that would be outliers. Now, I set that list aside of the top 20 number of outbound connections to the internet. And now I make a second list. List number two is the top 20 talkers based on the length of connection over time. How long are those connections? And then I set that list aside and I make a third list. The third list is the amount of data that was sent from that machine outbound to the internet. So now that I've got those different things there, I'm putting that in Discord so you guys have that list right there. You're welcome. Now, I've got these three lists. If there are any machines that are listed on all three lists, investigate that machine. It's likely compromised. Now, the reason that I mentioned that here, because that's machine behavior, and John was covering that earlier, we're talking about user behavior here. I found, and this was incredible when I had heard this, one of the people who uses this method, this isn't in theory, folks, people actually use this and find compromised systems on the network using those three lists. This one gentleman had told me, yeah, so do you know what? It's always worked. He said, except for one exception. There was a case where we had a machine on all three lists, and it turns out the machine was not compromised. I was like, oh, well, that's interesting. That's the first I've ever heard of that. That list has been infallible up until that point. He said, yeah, but here's the thing, is that when we went to investigate, it turns out it wasn't the machine. It was the user. The user was exfiltrating intellectual property from his workstation out to the internet. Oh, well, I guess there is a tie-in here to user behavior. It detected unusual user behavior in that case. It wasn't a compromised machine. It was a user that was compromised. Good stuff. All right. So now, one of the places that you can get that information is from Active Directory. When you have an Active Directory installation in an organization, I'm sure most of you that I'm speaking to do, Active Directory does so many different things for you. It is authenticating users. It's authenticating machines. It's authenticating the services. It's authenticating a whole lot of different things. And it's also then logging the fact that it's done these things. There's going to be a lot of noise. There's going to be a lot of cruft, but our Active Directory logs will give us a lot of very useful information, be able to pull all of that together. Now, let's go ahead and talk about another tool. This one's called Logon Tracer. And as I'd mentioned earlier, I really like to see those visualizations. And I'm sorry, Dio, I'm introducing it like it's the first time. This is a different view of that same tool that we were introduced to earlier, where we saw that password spraying attack against all those different systems. Here we're using Logon Tracer for one particular username. Here, it's interesting because that username happens to be administrator. Oh, well, unless we've changed it, the administrator account is that SID on the local machine of 500, that security ID 500 is the administrator account. Now, you can rename the administrator account. Most folks don't. And so in this case, let's say we haven't. The administrator account is very interesting. I want to know what's going on there. And we can see an association of a bunch of different systems all being accessed through that one node there. And all of that information we're getting there is from those Windows Active Directory event logs. And so now I can see, I get a clear picture as to what that story looks like. We were talking about the fact that our logs are the story that tell what happened on the network. Well, here, when we visualize the data, it's like we're getting a movie. Now we can see what's going on, and we don't have to analyze, oh, well, look in that log, it says this thing, and oh, by the way, it looks like that's associated with this. Now, forget about trying to manually go through those logs. Let's have tools like Logon Tracer tell us that story graphically, visually. Now, when it comes to those user names, how often they're being used is very interesting. And here we can see Logon Tracer has my top 5 usernames in the number of logins. We also see that there are, on the right, we see that there are machines that are being logged into the most. How often are those machines being logged into? All of this information is very valuable to me to find those outliers. Remember, we were looking for not just the fact that somebody logged in, but how many times are those things happening? If my administrator account is number 1 on the list, and I have no reason to expect that it would be because we don't normally log in as the administrator account on our systems, the fact that I see that very high in the list could be a very interesting data point for me to now investigate. And it isn't just about the number, it's also about the times that these things happen. With Logon Tracer here, we've got some interesting events we can see, and they're flagged in a different color there, where we are now seeing a bunch of things happening with these different usernames on a Saturday. Oh, wait a minute. Why is that? Sometimes this might be normal behavior. Maybe a bunch of people are working on a Saturday because we've got a project that we need to get out the door, and so everybody's working late on the weekend. Or maybe there's some sort of a change control process that we're going through, routine maintenance that was scheduled, and so that would be usual activity. But now I can see there's some really interesting usernames with some interesting login times in very specific timeframes on a weekend where I shouldn't normally see those accounts logged into. Now, here we've got a tool called Deep Blue CLI. It was created by Eric Conrad. And now, as special as John is to my life at SANS as an instructor, Eric Conrad eclipses that, just simply because I guarantee to you folks that if it wasn't for Eric Conrad, I wouldn't be in front of you right now, virtually teaching. And I hope you consider that a good thing that I'm here. Eric Conrad was my second instructor at SANS. I had taken a second course because I took one course and I was like, oh, I got to have more of this, right? So I took a second one. And I also at that time realized I'm not going to be able to continue to just be a student all of my life and take these courses. That's not a job, right? A permanent student. And when I took my second course, Eric Conrad had taken about 5 minutes of class time to just talk about how SANS at that time, they always need instructors, and John was that person that helped onboard me. Well, Eric Conrad was the person that convinced me, and he didn't do it directly. I was in front of a class. He said, we're always looking for good people to teach. One of the things that I love is to be in front of a group of people. I'm a bit of an attention hog, in case you hadn't noticed, right? And so I was like, wait a minute. Being an instructor would scratch so many different itches of mine. I could be in front of that group of people. Awesome. I love that. And also, and that reminds me, because somebody had asked earlier, ask again once we go to lab and we do the after class chit chat time. Just somebody asked about my guitars. There's a tie into all of that. Okay. I'll go ahead and back up for a second here, because I'm getting ahead of myself. At the age of 8, I was doing radio commercials. At the age of 11, I was a radio personality in radio commercials, like, the Flo, the progressive lady. It was kind of like that. I was the Teskey Lumber Company expert at a small radio station in central Wisconsin. And by age 14, I was doing community theater. I actually had to learn how to play the guitar to be on stage and all of that, playing the guitar. And by the time I graduated high school, I was graduating at a performance arts high school, where basically our mornings were our typical high school classes, and in the afternoon was actually rock band practice for me. Wonderful, wonderful times. So Eric saying, oh, well, we always need instructors. Oh, I can be in front of a group of people. That would scratch that itch. Also, I love cybersecurity. I love being able to talk about cybersecurity. My career before I became an instructor in cybersecurity topics was I was a contractor that I just basically learned a lot of everything out there, because when you're a contractor, for those of you who do independent contracting work, let me tell you, if you haven't caught on yet as to what the most important thing you do as a contractor, the most important thing you do is you put food on the table for your family, right? That's the most important job as an independent consultant, as a contractor. The reason that I mention that is because when your clients ask you, hey, can you do this for us? Because I'd been asked things like, I got into it doing web design back in the 90s. And my clients would say, hey, you helped us with our network. Thank you. I mean, with our web design. Thank you so much. Can you help us with our network? Now, web design and networking have nothing to do with one another, right? But to the client, it's all the same thing, because you're the computer guy, right? You're the computer expert. So now, if your goal, your number one responsibility is to put food on the family's table, and somebody is saying, hey, I will pay you money to do this thing, what do you think that answer is? It's always, yes, I can do that for you. And then I was trying to figure out, how do I get this thing done? Excuse me. Sorry, I get all choked up about these things. So I was saying yes to all of these different things because I wanted to get paid. So I learned all these different areas of computing, and then realized when I took my first SANS class and then my second one with Eric Conrad, I was like, wait a minute, security is the way that I could do all of those things that I learned to do. Because the attacker, remember Evil Doc? Evil Doc is going to find some way to get into your network. We have to find and fix all of those ways that he can before he does. So that's our job in security. And so now I'm bringing all that right back to our user behavior again. We need to understand all of these different areas of networking and cryptography and application design and systems administration, configuration management, logging and auditing. We have to know all of these different areas in order to defend our network. He builds himself the solution. He created the threat hunting tool called Deep Blue CLI, and it's a PowerShell module that allows us to find certain types of events, certain types of things of interest for us through the Windows event logs. Now, we can do all of that through Sysmon, which isn't necessarily a default on your Windows installation, but you can install that, and it's a perfectly valid, trusted program inside of Windows itself. And Eric is just leveraging those tools that are already in our systems to be able to gather that information in order to tell us what's actually going on in ways that are useful to us. Here's an example where you can see on the screen, we've got this security event 4672. That is that there's multiple admin logons for one account, and the access account number is at 22,451. Something doesn't seem right there. Right? Now, I see that there's some other security IDs that have multiple admin logins, and we've got Bertha Schultz, we've got the administrator account. Those are at 75 and 29. That's not near as high a number, but those are worth us investigating. There's something going on there. I want to take a look at that. It's a good point of detection so I can dig deeper. So now, another thing we can do is we can see things like special privileges that get assigned to a new logon. So let's say an account was created, and that account was then provisioned with these other privileges that are some sort of special access. It's not a regular user account. It's some sort of administrator access. So here we can see that we're looking for event ID 4672, special privileges assigned to a new logon, and there's a whole lot of them happening in a very short period of time. Something doesn't seem right there. We're probably going to want to investigate. Now, with all of that buildup, would you guys like to see the tool Deep Blue CLI? Would you like to touch Deep Blue CLI? Would you like to play with it? I'm not trying to be salacious here. Guess what our next lab is? It's in Deep Blue CLI. Now, my marching orders were this, is to kick you guys off to the lab, and then we'll have some post-show banter and all of that. And one of the things that John loves to do, and I certainly want to honor that, is he is all about demoing some of these things that we're doing in the classroom after the lab is over. Well, what I'm going to do is I'm going to kick you off to lab, and then we are also going to do our post-show banter. We'll also be here to support you guys in the labs. But what I want to do with one particular, before folks go for the day, I want to give you a taste of a particular part of this lab that's worth investigating. And as I had said, now, Deep Blue CLI is not a tool that I use in my normal comings and goings. And so I'm going to do, and as you guys know, I was woken up this morning by a call from John saying, hey, I need you to teach today. And so I didn't get time to make sure that I knew all of the ins and outs of each part of this particular demo I'm about to give. So I am just a free form without a net, going to do some reading of this output that we see here. And so bear with me if I stumble at all. The first thing I need to do correctly is find where my sharing is and share a different screen. All right, hold on. Let me go ahead and get us over to the right screen here. Screen number 2. You guys are now looking at the lab machine with the PowerShell window open. Is that what we're all seeing right now? Let me go ahead and check in Discord. Is that what you guys are seeing right now? You see it?
Yep, I think.
All good? All right, great.
Good. We got it.
Awesome. Let me go ahead and make this nice and big here. Make that text a little bit bigger. So what I've done is I jumped ahead in the lab, and of course it put me at the bottom of the command line there. What you're going to do, you guys can go ahead, and since it takes a moment for the lab machines to start up, ladies and gentlemen, start your lab engines, and so it'll be ready for you in a few minutes, so you can log in and do the same. I am skipping to the last of the lab steps to show you that we've got a Deep Blue CLI will allow us to find things like unusual, the potential obfuscation of commands. We can see here that in PowerShell, we've got this event ID for suspicious command line activity. The results say possible command line obfuscation. What that means is it seems like perhaps somebody is trying to hide their activities from us. I want to know what those activities are, right? If they're hiding, I'm going to seek. And now with this particular result here, the obfuscation is only about 60% of the command line is alphanumeric and common symbols. That seems unusual. We should be pretty close to 100%, right? There's something not right here. And we can see this is the command. It was recorded, and it looks like they're running some interesting sort of loops here. And of course, they're doing some unusual things like almost every other character. It looks like we've got 2 characters would be uppercase, 1 lowercase, 2 uppercase, 1 lowercase, so on and so forth. Windows PowerShell doesn't care about capitalization. And so one of the things it looks like they're trying to do here is that they're trying to hide their activities by using unusual commands, loop commands, to hide what their activity is. All right. So that's useful information. We'd want to unpack what's going on there. But now you'll see this next one here is a suspicious command line. In this case, it's a long command line, longer than 1,000 bytes. And I'm sure some of you are saying, yeah, well, it's PowerShell. Duh, it's going to be really, they're very verbose commands, right? I think the greatest thing in PowerShell, and I know this isn't a PowerShell thing per se, but the best friend of yours in PowerShell is the up arrow key, because you're going to make typos. Up arrow, fix that thing. There's no way I'm going to type that long command in again because it's very verbose. So now we see only 6% is alphanumeric and common symbols. Here it was only 60%. Now we're down to 6%. Something's not right there. And I'm looking at the command saying, well, that looks like 0% because it's just blank, right? Oh, wait a minute. If I keep scrolling, here's the rest of it. What they've done is that they have put all of this blank space in here. That PowerShell is just politely ignoring all this blank space and then the command. That might be very valuable to the attacker because a lot of these tools may only look so far into a command. Because one of the things that attackers can do to obfuscate their commands is to hide their malicious activities until later in the command. Many of these tools, for usability, they are not going to parse an entire, let's say an attacker has now DOSed your security tools by submitting commands that are hundreds of thousands or millions of bytes long. Now the attackers just DOSed your security tool. The security tool may only be looking for the first, 100 or 200 or 1,000 bytes, but it has an upper limit where it's just going to stop. The attacker has now put their evilness after the security tool stopped looking. All right, that's interesting. Now here's another one. This is a long command line, longer than 1,000 bytes, but we get into it right away. And whoa, wait a minute. What's this? This is basically the same thing we were seeing before, but instead of in normal ASCII characters, it's calling out the characters in their position in the character chart. You see over and over, you've got this CHAR, that's char, character, and then the number, the decimal number for each of those characters in the, I believe it's the ASCII chart. And so this is a different way of saying the same thing. Your Windows is going, your PowerShell program is going to look up those characters. And so this is just another way of saying that same thing. This one's really ugly. I know that this is a thing. I can't even tell you what this is. And this is one of those things where I'm flying blind here. All I know is this looks really unusual. There's something going on there. There's something not right. But then we've got basically that same character situation we saw above. But rather than calling out each character separately, what they're doing is they're just simply, okay, we've got an array of characters, and here's the characters. And so it's basically saying the same thing we had above, just a little differently. And here it's base 64 encoded. John was showing you base 64 encoding earlier. Now it's base 64 encoded. Now we can see that we've got this is written out in 7-bit binary encoding. Same characters, but now we see it's 7-bit encoding instead of the position that character is in. Now it's just written out in binary encoding. So you guys get the idea here, right? There's a bunch of different ones. I don't have to go over every single one of them. What I'm going to do is I'm going to kick you guys off to lab. We won't put a timer up on the screen for this, because what you're going to do is once you're done with the lab, we're officially done with class time. You're free to go at any point there, but we're going to stick around here for two reasons. One, I'm going to unshare this screen. Let me go ahead and do that real quick here. Stop that share there. And so I should be, am I full screen now? I should be full screen now. Am I the one that should be full screen?
Yep.
All right, cool. So hi, now you get to see this again. I'm sorry that's much bigger on your screen now than it was before. The reason I've got so much hair and facial hair here is the less of this face you see, the happier everybody is. What we're going to do is we're going to stick around for two things. One, we're here to support you while you're doing the lab. And so take your time, go through the lab, enjoy. Don't forget at the end of the lab to destroy that machine. I know that you were able to, you could stop or destroy the machine. I recommend that you destroy the machine at the end of this lab, because when you stop those machines, it's going to eat into your credits ever so little bit. It's just an extra little bit that it's going to eat into those credits while the machine is stopped. And so from today until tomorrow, you don't want to have those credits being eaten up. And so go ahead and destroy the machine. And that's reason number one we're here, is to support you in the lab, and you're free to go at any point. But the other reason is that now we get to have lots of fun here. Let's go ahead and can we put the, make the Discord channel nice and big for us here and start going through some of these questions that people have in Discord. I always love to see what's on people's minds here. Now I lost my Zoom window. There we go. You gotta make this nice and big so I can see that as well.
Did you answer the question about your guitar?
Yeah, so let's go ahead and get into that now. So I've got a few of them here, and I'll start with the most boring first. It's probably the one that you guys saw most readily available. This particular guitar is just your standard Kramer with a whammy bar on it. This is the guitar that I bought. It's nothing special. Paid $250 for it, but this is the guitar that I travel with. If you're ever at a training event with Anti-Safe in Black Hills, where I'll be in person, I'm almost always going to be traveling with this guitar. I travel with this one because if something happens to it, I don't care too much, not too worried about that. And so that's what this guitar is all about. And it's just basically my daily driver right now. Now we get into the special babies here. This is my Ibanez bass. I've always wanted an Ibanez sound gear, right? Bass. And I always wanted this body style. But then I just happened to be traversing the internet, looking at different bases and stuff. And I saw this one with the burled top and this amazing burst finish from that burled wood into this blue. It's the neck on, for those that know about guitars and stuff, this is a 13-piece neck. That's 13 different slices of wood there that comprise this neck. All of the hardware is gold plated. It's beautiful. It's got a 4-piece bridge on it. It's just wonderful. And so I had decided it was during COVID. And I was teaching from home in my basement, which I'm basically doing here. It was my quote unquote home office. And you all know in COVID times, your quote unquote home office is basically your basement or extra room where you're just working out of from that location. And I'd been doing a lot of teaches, just staring at an unblinking eye of a camera. And I said, do you know what? I'm feeling a little bit crazy, a little bit stir crazy. I need to do something for myself here. And so I talked to my wife. I said, you know what? I'd really like to get this bass. She says, you know, you've been working hard. You earned it. And so this is actually my most recent purchase I bought during COVID. And I love this bass. It's just wonderful. And now I'm saving the best for last. I was mentioning the fact that I was at performing arts high school and all of that, and basically my my high school existence in the afternoons for my last 2 years was band practice. I bought this Washburn Force 2. Too bad John's not here right now. John has held this guitar before. He's played it. I traveled. Would you believe I traveled with this guitar to some events, and I decided after a while, do you know what? That's not a good thing anymore to be traveling with this guitar. I bought it. It's an 83, and I bought it in 1985, and it was my daily driver for decades. As you can tell from the neck here and how well it's worn, this has been a very loved guitar for many, many years. And so I don't travel with it anymore. I am surprised that it's still in such good condition, considering the fact that this guitar has survived 4 children. And for those who are guitarists, and you know, here's the thing, is that the cable plug-in is in the plastic pick guard. And I was convinced that at some point with these 4 kids, that somebody somewhere along the line, some toddler would have come by, tripped over the guitar cord, and just broke that. And phew, I'm through those ages. But now I'm a grandfather, so now I start worrying about that all over again. So this is my baby. I love my baby, and this guitar is just I'll probably have it buried with me if maybe I'll go that route. I don't know what I'm going to do with this guitar. It is my life. I could be homeless on the streets, and I'd probably be hugging this guitar at night, right? And so those are the ones that I have here in the studio. Who's all guitarists here? Let's hear it from the guitarists in the group, or at least the guitar collectors. I don't consider myself a guitarist. I'm a guitar collector. If I make one sound good every now and then, that's just a bonus, right?
Looks like we have one. I see Chris
What is it with all the
Very-
testers being musicians though?
I know that it must be the way their
security.
brain works. That's my theory. Is like
says
they
I am a
review-
lead guitarist.
yeah.
Now here's the thing. And I'm sorry, I totally interrupted you, Megan, but I wanted to
No, it's okay.
before it went off the screen there. I've been told before that I'm a lead guitarist, and I'm not too comfortable with that because you know what? Somebody calling you, especially another musician calling you a lead guitarist, is they're telling you you're the guitarist that can't keep rhythm. At least that's me right there, right? Cody's got one, mostly sits around. So my granddaughter is actually my oldest son has 2 children, and he's teaching my granddaughter how to play the guitar. We were on a video conference recently, and I played a few things for her. And she's like, oh, "How'd you do that?" And I was like, "Well, I put my fingers on the fretboard here. I pluck the strings, and that's what happens." And I know she was trying to figure something else out there, but that's the thing. Been playing for 19 years, Chris. You should put down the guitar at some point. I mean, I can play for 19 minutes now, but not 19 years straight. I know that's not what you meant.
I picked up the sarcasm.
My favorite is when I'll start playing and somebody like, "How long have you been playing?" "Oh, what, about 10 minutes now?"
Yeah. Yeah, my brother-in-law is a musician, and he can pretty much pick up any instrument and teach himself how to play it. It's crazy.
There was a time that I could do that. I was so my senior year at that performing arts high school, I did receive it, and I still don't feel like it was justified. I shouldn't have gotten this award, but they named me the outstanding musician of the year. And that was a great honor. But the thing is, honestly, just between you and me, the only trick that I knew is to play everything in a minor harmonic scale and just simply play it fast.
Yeah.
Just play it fast and nobody knows which notes you missed, right?
Do you play anything other than guitars? Any other like my brother-in-law plays banjo, for instance. Do you play any other
banjo? I've got a keyboard over here.
Yeah.
Where's my other sequencer? I've been trying to I've got a sequencer that I've been trying to plug into my computer. Here's the most embarrassing thing for me is I know computers, I know music, and I still can't get that damn sequencer to play on my computer yet. It's all user error. It's just I think it's mainly I just don't have the patience for it. But then just off camera here, and I won't show you guys off camera because it gets really ugly in this off of this space right here.
Yeah.
For those of you who were not at my cryptography class, I think I explained in the cryptography class that this room that I'm in is just pretty much a dungeon back here. It's not even it's in my basement. And it's not even the room that's under the stairs. There's a room that's past my staircase. And so there's a room past the staircase. And I'm not even in that room. I am in another room that is actually, it's cinder block on 3 sides of the room here, and just has this small opening out to the room that's under the stairs. That's how dungeon-esque I am here. I could literally, I think
you're like in the root cellar.
I totally could, like in the dining room area there, I could cut a hole in there, make a trap door, and then a cinder block wall this, and it's literally outside of the footprint of the home to where law enforcement would never know this room was here if I were to take this third wall and just put cinder block there.
Listen, we'll scrub the recording. I think you should do it.
I think where this room came from was the house that I'm in. We moved into this house 2 years ago. It's celebrating its 75th anniversary this year, its 75th birthday. It's an old home, and I think that this area was actually the was just the access to the basement before the other staircase was built. This was an external staircase because it's outside the footprint of the home. It's just like, okay, this is just a really weird setup. It's the best I can determine. I don't know. I don't know if the city has better records on what this floor plan was like before, but I mean, it's just, I am so dungeon-esque here that pipe that you see going vertically in the wall there, that's my main water line. That's why that pipe is there, is because I can't move it.
Don't talk about water in the basement. You'll trigger Zach.
Oh, God.
He gets very upset with his flood of 2025.
It was not fun. That's for
No.
sure. Did we ask, I'm sorry, I want to ask a question to the students, though. I don't know if you asked this, Megan. I'm sorry, because I was late. But since Doc came in and helped out, what did y'all think of Doc's teaching style? I'm putting embarrassed Doc maybe, or maybe we'll get some negative feedback. You never know, but the negative feedback is always constructive, right? Keep it.
He survived the murder boards with John. I've got full confidence, and he can handle any sort of feedback.
Come on, people, tell me how much I suck.
Or Doc Blackburn, Steve.
No, we like.
If you say nice
evil Doc.
This head just gets bigger. Oh, do you know what? While we're at it, let me go ahead and, for those who haven't seen
your workshop come up, your anti-chaos, so I was about to link that.
I did post the link to your next. You've got your intro to binary hex and decimal systems coming up in 14 days, 18 hours, 34 minutes, and 53 seconds.
I should finish that slide deck.
Yeah, you probably should. You know, sometimes you can just wing it. That is another thing that they teach you at SANS too. You can wing it.
Oh yeah, absolutely.
Modifies his classes anyway. He just does them live.
So here's in Discord, you guys got, there's the only known picture of Evil Doc.
Yep. And this we will I did ask the on-demand team about your recording from your previous class, and I will make sure to tag you tomorrow, and I will let the students know as soon as I get the answer to that.
Awesome. Good. Yeah, it was my impression. It was I believe I was told straight up that was going to end up in the catalog, but
okay.
All right, and so now we've got Doc. I'm considering Strand. In what way is the investment worth it? Be honest, please. Okay, so let me answer the question like this. John Strand is a former SANS instructor. I'm a former SANS instructor. Tim Medine is a former SANS instructor. Joff Thayer is a former SANS instructor. Who else am I missing, guys?
Alyssa Torres, Jake Williams.
Jake, and Hal Pomerantz.
Yes.
I know I'm missing one other.
I know I'm missing them too.
Here. Yeah, and if Jake is anywhere around, Jake, you ghosted me on text, and I'm upset with you about that. I know, right?
Well, and Kevin Johnson.
Oh, Kevin Johnson. There we go.
Mm-hmm.
Funny enough, so I had met Kevin Johnson just a few years ago at Way West Hack and Fest in San Diego.
Oh, yeah.
And I had never known him before. I walk up to him. I said, "You're Kevin Johnson?" And he's like, "Yeah." I said, "I'm Doc Blackburn. I don't know how we've never met." He's like, "Doc Blackburn, I don't know how we've never met." It's like we heard of each other a lot, and just all of a sudden, it's like, how did we not know each other there until that point, right?
Yeah.
So to go back to answering the question about SANS or not, you have some of the best instructors in the world here that have proven themselves at SANS, and I would say of all of these instructors we just named, all of them now, because we've gone through all of those experiences, we are better for it than we were before. So you've got the finely aged instructors of sands for a lot more of affordable price. So ask yourself, can I afford that? I would ask the question, why should I pay that kind of money out?
Just real quick, Patterson-CK and Matt Toussaint too. I didn't.
Yes, Matt Toussaint, Patterson, absolutely. Yeah, that's
I can help answer this one too. Is it worth the investment for you personally? More than likely not. Is it worth the investment for your company to pay for? Yeah, probably.
Yeah.
Oh, sure.
So
yeah.
And what John likes to say is, I've heard him say in the past, is we want to train you to get the job that pays for the SANS classes.
Oh, I like that. Yeah. And here's the thing. I have no bad things to say about SANS. I really don't. SANS is very high quality. SANS is it's an incredible organization. It's just, it is a different price point. And
Yes.
That's the big difference between the two. One of the things, and I'm going to turn that question then into a selling point here for my classes coming up. My goal in coming over to Anti-Siphon is to give you that same high quality in not just instruction, but content and labs. I'm sure for those of you who were in my cryptography class, hopefully you enjoyed those labs as well, and the content and what I had built out there. My goal is to offer that same SANS quality at Anti-Siphon prices. At prices that everybody can afford. One of the things that I had been asked for many, many, many years, and I never really did have a good answer for folks until recently, is they ask, well, how do I break into security if the classes are so expensive? They'll ask for, here I am in SANS training and my company paid for it. My brother or my sister is trying to get into security, but they don't have the job yet. How did they get into it? And for the longest time, I didn't have a really good answer for them. And now I do. I've been up on the rooftops screaming out to everybody, check out Anti-Siphon, because absolutely wonderful training here at a fraction of that price.
Yeah.
Everyone's different too. Anti-Siphon got me my start with John. That and networking.
Yeah.
I'm sorry, say that again, Brian?
Anti-Siphon was how I got my start, and networking with John.
Nice.
And I pretty much got very cheeky in one of the classes and figured 1,000-odd students in the class, global class, maybe somebody knows a job I can do fully remote. And I basically asked the class if they did. John read it, and basically 2 months later, here I am.
Yeah.
There you go, Chud.
And look at that. Zach's
creature.
got a black cat. We got black cats here. If I could, I'd go upstairs and get my black cat.
You could play Cat Scratch Fever, maybe. No.
Oh God, no. No.
The younger people are probably like, what is that?
Yeah, for one, we don't want to. That's one part of rock history we don't need to introduce the youngsters to for multiple reasons. And
Right.
Once you get to a certain point in your playing days, there's certain songs that you just don't touch.
Yes.
Cat Scratch Fever is one of those. Smoke on the Water is another one.
Stairway.
And if you start playing Stairway, you better damn play the whole thing.
Yes.
Not that opening line.
No, nobody's got time for that.
Yes. Kid, there's no way kids. I can barely get my kids to watch like a 3-minute TikTok. If it's over like a minute, they're like, Mom, that's too long.
I was really proud of myself that I was able to do this with my with one of my kids. He's 22 now, and I ended up unexpectedly traveling a long distance from Iowa City to Fort Collins, Colorado, sharing some windshield time with him. what happened was he was moving from, we're in Western Pennsylvania here. He was moving to Fort Collins to attend Colorado State University, and that's why I've got the CSU Rams banner up in the top corner there. He got as far as Iowa City and was in a significant accident. He's okay, thanks for asking. But he totaled his car in the process. So we got him a hotel room that night in Iowa City. I flew to Chicago, and because there's no easy way to go to Iowa City, let me tell you. I flew to Chicago. I rented a car, picked him up in Iowa City with all of his stuff. And you know how, college students, they've got their mini fridges and all that. My son is also a hockey player and he's a goalie. And so, half of his stuff was hockey equipment, piled it all in the car. And I drove him the rest of the way to,
that'd be a stinky ride.
And I know, right? And I was very proud of the fact that I was able to introduce him to artists that these younger folks, they just don't get to listen to. I played the entire 2-album Pink Floyd The Wall.
Oh my gosh, Pink Floyd. I was hoping you were going to say that. I love Pink Floyd.
And he's
from the beginning to the end.
Yeah.
Because his major was in psychology, and so I was like, "Son, you got to listen to this for the psychological aspect of it. There's so much craziness going on in that." And then he reacted so well to it that I actually then had him listen to Heart's Dreamboat Annie album from start to finish. Yeah, can you believe Dreamboat Annie just turned 50 this October?
No. I think we were talking about this earlier. I still think that 1980 was 20 years ago. I
know.
It's so weird how math works.
It just happened, right?
I know.
The folks, when you watch Stranger Things, you youngsters out there, we lived that.
Yeah.
That was our time.
Yes.
Except for all the monsters in the Upside Down.
Yeah, get this. The save icon is an actual physical thing.
Yeah, I have one of those around here, don't I? I actually.
And they're not 3D printed out either. They were an actual diskette.
I have an actual disc.
Speaking of old technologies here, I've got some albums and records up on the up on my shelf here. All of these are all albums from the 70s and 45s. And I know that there's only certain people in this virtual room here that understands what I say when I say 45, right?
Yeah.
Those are 45s. That's from our jukebox. Yeah, my parents had a jukebox in their.
Oh, wow. You had your own jukebox? You guys must have been fancy.
It was even better than that because my mom worked for a radio station at the time. That's why I got into doing radio commercials and stuff. My older brother was a DJ for that radio station. I was doing commercials for them. And what she would do is when the radio station took, oh, look at the floppy there that Zach has.
Heck yeah.
Put it on the record player, see if it plays.
Play it backwards.
My mom would bring those records home and put them in the jukebox. And I've got some pretty crazy things here, including I'm gonna break things.
Don't break it.
So from
Shame, no.
No, I don't have any pinball machines. We'll have to get a hold of Eric Conrad for that. Fun fact, I hope he doesn't mind me saying this to the general public, but Eric Conrad loves to fix up old video game cabinets and pinball machines and things like that. Like he's got a full garage of them. But shows like Casey Kasem and the Record Report with Charlie Tuna and Wolfman Jack and all of those. On the radio stations, obviously, those nationally syndicated people weren't in your local radio station. It was a recording. Well, here's the thing. A little known fact is that those shows were actually shipped to the radio stations on albums.
Oh wow, I didn't.
And so the radio
Cool.
station was literally playing an album. And I've got things like this is the week of January 30th of 1978 here. And the first track is the level tone. So the radio station can set the right level for the track. And then you've got Monday report, Monday afternoon report, Tuesday morning, Tuesday afternoon. And so they're just basically playing tracks on an old album. Isn't that wild?
That is wild. I didn't know that.
Look at that.
That's so cool.
Chatter's got a museum here as well. Do you have any? I don't see any zip discs there. You got some zip there?
Every time somebody mentions zip disk, my mind automatically just goes to like Windows ME for some reason.
Oh,
just put
geez.
those two together of just horror, right? Like I don't know why that's where my head goes.
I was the idiot that bought
the
ME in box. Gotta have a zip disk with ME, right? I
do have.
You have both?
5.25 DOS 4 and DOS 5.
Oh wow!
Windows 3.1 and 3.2.
Oh wow! Those were the days, right? Those were the days.
All right. Does
So I'm
anybody
doing a lot
have any
talking
other?
about stuff.
Yeah, I was going to make sure everybody, if anybody has any other questions. Otherwise, we can. We can end the training for the day, and y'all can get some time to maybe go through some labs and things like that.
Yeah, and we will be starting a little bit later tomorrow. We won't have the full 30-minute pre-show banter. So, and for people that are still doing the labs, you can always, I think Brian will be around for a little while still because it's tomorrow anyway. He's our future. He's in the future. And tomorrow we will get right back at it with John, and it's another full day. Full day classes.
I think we need to have John first thing in the morning. Megan, have John say, as he's starting class, say the line, Andy, open up the cabinet.
Andy, open up the cabinet?
Yes.
Okay. I better write that down because I've got grandma brain and I don't.
Chet's going to remind you, I'm sure.
Okay.
He wants
Chet, you got me?
Yeah.
And Andy, we need a big sign inside that cabinet that says the OSI model's the Bible.
Oh, yeah. Oh,
trigger.
Yes.
Man.
Who was that? Was it this group that I said that to? Is it folks just simply, if you want to set John off and get me fired, just say tomorrow, Doc says OSI is Bible. Just say that. That should either
listen. We don't want to mad Strand. Brian tries to provoke him every class.
Just remind him he's mature, not old.
Next thing you know, I'm getting a call from Megan saying, "Doc, you need to relieve John here. He's going off."
Swear is paid through the end of the year. Thank you. Well, that's true, Andy. But we don't want to. John will get on his rant, and he only said the F word once today. I was very proud of him. He's come so far.
He has. He's doing very well. Yeah. Now we just need to get Kevin Johnson to the same place.
Oh no, that's never gonna happen. Like if you want to like triple the swear jar, have Kevin on for like 5 minutes, and we'll be done.
I remember in some remote webcast, John had, when he was introducing me, he had said that he was introducing me, I was saying some nice things, and he says, and Doc swears more than any person alive or whatever. He said something like that. And I had responded with, "What the fuck are you talking about?" So I totally missed the opportunity there. Because my mic hadn't been unmuted yet. So now there's something else you guys have to bleep out. I had to put it right at the end there so you guys can find it easy.
Yes, there you go. we'll add money. My mouth is terrible. So, but I try and maintain on camera.
I heard. I read.
Not around my house.
You're very good.
People that swear are that swearing is one of the signs of intelligence.
Of course, yeah.
Yeah. You know.
Hell yeah, I totally agree.
It's a very clear form of communication.
Yes. And I'm pretty sure that my granddaughter will be swearing in context by 2. I'm sure that she's not going to just use random swear words. So,
Andy, one of my favorite things on the internet are those children caught saying things that their parents say. You know, one of them is like this one kid was out in the snow and said something like, "It's bleeping cold out here."
Yeah, yeah.
Like, well, you know what their parents are saying. Oh boy, good stuff.
All right, y'all. I think
tomorrow we will start at 10 Eastern time. I'm pretty sure.
Started
Right?
today.
Eastern time, because today we started at 9:30 Eastern time.
Oh yeah. We will start at 10. Yeah.
See,
we'll have no pre-show tomorrow.
We'll have
You'll have like 2 minutes of pre-show.
A bit early, but
yeah.
We're usually on here, but sometimes John will come in and we'll be talking about something and then he'll just hit go live. And I think I've been caught a couple of times, like telling it like a personal story. And I'm like, oh my God.
So to Renegade's question, those credits stay in the account until you use them all up, right?
Yep.
And so just make sure to the most important thing you do is destroy those machines. And so it's not using any of your credits going forward until you're ready to use them again. If you only stop the VM, there's a little leak in the bucket there. It's just your credits will leak out even though you're not using the machines directly. And as a few people had mentioned, it really is, this platform is very cheap to add credits to. It's
absolutely
$25 for 10 hours or something like that.
Yeah.
Or even probably better than that as far as the rate goes. And don't quote me on anything. I'm just the helper today.
Yeah. Well, thank you so much, Doc, for stepping in and helping John, letting John have some family time today. That's really important. And we really appreciate you coming in. And we're so excited for your classes coming up. I will make sure to get everybody the information on your last class, and then we'll see you in like a couple weeks for your webcast.
Absolutely, folks. It's been my pleasure. This was a wonderful phone call to be woken up to this morning, saying, "Hey, can you teach for me a little while today?" John does this to me all the time. He literally, when I first let him know that I wasn't going to be teaching for SANS anymore, he was like, "Will you teach for us?" I was like, "Absolutely." And it was like a week later, I got a call from him. Oh, and it was during that time where I was taking my son back to Colorado. I was sleeping on a friend's couch that night, and the next morning, John calls and says, "Hey, can you be in a European country in a couple of weeks teaching this class for me? Can it be me for the week?" I was like, "Okay." And then I was like, "What the heck did I just agree to here?" But it's been absolutely
all of us have gotten those calls and we're like, oh yeah. And then we're like, oh my gosh, what did I just agree to? So
absolutely. John learned that one I don't know if John taught that one to SANS or John learned that one from SANS. The same way. It's like, "Hey, can you be in Amsterdam Monday?" And I literally I got the call 7 p.m. I was having dinner Sunday night. I got the call from SANS and they're like, "Can you be in Baltimore in the morning teaching?" And it was so it was 14 hours before I had to teach. And I just got in my car. Baltimore is about a 4.5-hour drive from here. I got my car, drove there, got there like 2 a.m. and it did
What class did you teach?
That was for SEC 401.
401, yeah.
the foundational course. And so for those that know, that's 10 hours a day for 6 days. And so it's like, hey,
boot camp
can you drive? Yeah. Can you be in front of the class after a 4.5-hour drive and then teach for 10-hour days for 6 days straight? And that's just one of those things that you do, you know,
you just have to do it.
When the bat signal goes off, you got to answer it. So I was really happy to be here. Thanks for having me, folks. And I hope to see all of you that are in this classroom. I hope to see you in my future classes here. Can we, just for a second here, could I just mention a few of the classes that I'm working on for the future?
Yeah,
absolutely.
So I've got my list here. The first class that I put out was that 4-hour intro to crypto workshop. I am also, and I'm contemplating exactly how we're going to do this, but I'm planning on making that an 8-hour course as well. What I'm trying to do is figure out, do we just create 4 more hours to add to that, or exactly how that should be formatted? So, but hopefully we've got the 4-hour workshop in the catalog soon, so folks can see that those recordings on demand in January. And Megan, do you know, is it do you know what, there's no schedule for that right now, I guess.
I don't think it's up yet. We were discussing it earlier. The only thing that we have up is your webcast, but by the time your webcast is up, we should have your class actually scheduled on the website.
Okay, great. So we've got an 8-hour class on intro to networking that I'm going to be recording the second week in January, and then that will be the intent will be that will be online, and then I've got, so this 2026 is going to be awesome. There's a lot of demand for, I don't know anything about technology, teach me security. And that's what I've got coming up this summer. There's going to be 2 4-hour workshops. One of them is in cyber concepts, and this is probably not the audience for this type of class, but you probably all know people that this is the audience for. This is going from zero to hero. You know nothing about technology. I'm going to teach all of it to you in a security setting. And so 4 hours on cyber concepts, that's one workshop. Another workshop is a 4-hour workshop on IAAA, that's identity, authentication, authorization, and accountability. Is going to, I know that doesn't sound real exciting. Folks, we're going to be doing things like password cracking and all sorts of fun stuff in that 4-hour workshop. Those 2 4-hour workshops then are going to introduce students to the concepts so they can then take a 16-hour 2-day course that's Intro to Security. That course is going to have a lot of overlap with what you see at SANS Sec 301 Intro to Security. Mm-hmm. And basically, it's Anti-Siphon's answer to that class. Those 2 4-hour workshops and the 2-day 16-hour Intro to Security is going to be that solution to what SANS is charging a heck of a lot more money for. I don't know what Anti-Siphon will be charging for that, but what our goal is to for Intro to Security courses, they shouldn't have to be a $10,000 course, right? Yes. Agreed. And so our goal here is to make security accessible to those that are going from nothing to, now I have, they came from some other part of the organization, project management or, HR, something like that. They're hearing, we need all of these security people in our organizations. There's just not enough security people. How do I get started? And no, my HR director isn't going to pay $10,000 for me to take a security course to then leave HR, and so how do I break into this? That's the answer right there. Also, down the road, what we're expecting to also do is an 8-hour course that's Intro to Computers. what is RAM, what is hard drive, things like that. And then there's also waiting in the wings. I know I got a lot going on here.
That's so awesome. I'm so excited because
all of this.
people need these foundational classes. I'm so excited.
Yes, absolutely. Oh, Cheddar, you're pulling out Grace Hopper quotes. I love it. Did you know? A lot of people know who Grace Hopper is. Did you know that Grace Hopper? This is a less known fact. She's the one that she and a few others wrote the COBOL language. And I was about this old when I found out that she, along with others, wrote COBOL. And just a wonderful, amazing lady. So the course that I'm also really excited about for those who are in healthcare, there is a 24-hour, 3-day course in healthcare security that I absolutely, I have the bones of that course. I just got to put the meat on the bones. I'm not sure when that's going to be, but a 3-day healthcare security course with an emphasis on data privacy and very focused on, and it's not just for this, but very focused on the HIPAA security rule, of course, because that's what healthcare, and it's not just hospitals, but it's the health insurance, pharmaceuticals, clinical trials, human subjects research. Just there's so much need in healthcare in understanding how to secure the healthcare environment. What I do with that course is I take the HIPAA security rules, and rather than focusing on complying to them, I show students how they better secure their environment using those security rules, because the rules are there for a reason. They're there to make things, make patient data more secure and private. But your goal isn't to obtain certification that, you're HIPAA compliant, because that HIPAA certification literally does not exist. Health and Human HHS, they are not going to come in, audit you, and say, stamp, yes, you are HIPAA compliant. No, the only time you find out whether you're compliant or not is when you're audited by them. And if you're being audited by them, it's because somebody thinks that you aren't. And so this course isn't about obtaining that HIPAA compliance that doesn't actually exist. It's about how do we secure the environment using the security rule. And therefore, if you've done those things, you are therefore able to demonstrate that compliance. And so for those in healthcare, hopefully that excites you. But that's my next probably about 18 months here of writing for Anti-Siphon, and I'm really looking forward to it. The intro to networking is the next one here, and so we're going to knock that one out real soon. It's going to be recorded in mid-January. I'm assuming then a few weeks after that, it'll end up on the Anti-Siphon website.
Nice.
And I'd love to do
really
that as a
exciting.
Yeah.
Yeah, that's awesome.
I appreciate that.
Yeah, thank you very much, sir. Appreciate it. We appreciate you taking the time to be here with us and take over for John and share your knowledge with us.
Pleasure.
Hope you all had a great time today, and we will see you back tomorrow for more.
Yeah. Thanks everybody for your interactions. So sorry I didn't get to answer to everything that everybody had said there, but I was reading all of it. And thank you so much for being part of class, and enjoy tomorrow. Maybe I'll
everyone has to register for his webcast. So that's when you'll
register for. Oh yeah, now register for the webcast. That is December 19th. Is it?
It is.
I should know when that's happening, right?
Yeah, you probably should. The 17th. Yeah.
The 7th. Oh, we got 2 less. Oh, in 2
14
weeks.
days. There's a countdown. God. You got 14 days, 18 hours, 2 minutes, and 41 seconds. So you got plenty.
Oh my, I got some work to do, especially since and this has nothing to do with you guys, but one of the things that I've done since leaving SANS is O'Reilly Publishing has asked me to put together some videos for them over there. So I'm working on their content there as well. Just keep looking for this face, and I'll be around here. I hope to see you guys on the 17th. It's all about, for those who have never learned or for those who have learned before and that just kind of forgot how it works, we are going to introduce you to or reintroduce you to numbering systems in computers, binary, hexadecimal, decimal. It's going to be a blast. It's a free 1 hour thing, right? It's free.
Yep.
So go ahead and register for it. As link is in. Yep, there it is. Oh,
Yep.
cool. There's a graphic. I should steal that graphic and start promoting it.
Yes.
Oh, you guys are on top of things here, and I am not. I got a lot to catch up to do.
Snag it.
Yep.
All right.
All right.
Well, I think with that, we'll say goodnight to everyone, and we'll see you tomorrow. And again, thanks, Doc. We'll see you soon, I'm sure. And with that, and the rest of the anti-siphon team, I'm going to go ahead and say Daryl or Ryan, whoever's back there, kill it with fire. Have a good night, everyone.
Bye, everyone.
Thanks, everybody.
I don't.
Have a good night.
See you later.